Joining at 8:40 a.m. on a Saturday for day 2 of AI Engineer Singapore. Just as a way of introduction, I'm Sherry, and I'm one of the members of 6.5 Labs. We're one of the largest grassroots builder collective here in Singapore. An article actually recently came out about us this week. It's just a few of us who are actually doing all of this in our spare times. We all have full-time jobs, but this is something that we are all very, very passionate about to bring to Singapore. So this conference really is our love letter to the ecosystem. Now, somewhere along the way of all these hackathons and build nights we were running, something magical really happened. Some of these frontier AI teams that are here today, building the models that you use every day, started to show up for our community. They're giving credits for our hackathons, even showing up late on Zoom to do workshops for people. And we've really had all sorts of people being supported, from as young as 13 years old to folks who are in their 60s just learning all of this as well. It really is just a great time to kind of come together and be a builder. But what we got was more than just a few credits. We started actually to build a relationship with some of these teams, and that is the magic that we see in this room today. Now, you might think that this is the first time all of this is happening in Singapore, but it's really been happening under the surface for a long time before we gathered at the Capitol Theater here today. So that's why it was no surprise when some of our speakers actually told us their entire plane from San Francisco to Singapore was actually just full of folks coming down for AIE. So how did this conference actually happen? We actually met Swix, who is the CEO and co-founder of AIE globally. Met him actually in New York City. And I don't know if you guys know, but he's actually from Singapore originally, so it just clicked and made sense. We've been working with a lot of these teams remotely, and we just wanted to bring them in person in Singapore all together for the first time. So to hear a little bit more about the AIE story, Swix will be speaking about cognition, but also be closing out day 1 to share a little bit more about the AIE story. All right, now show of hands, I'm kind of curious, who was all at the workshops yesterday? Woo! All right, that is pretty much like 98% of the crowd. That's awesome to see, because that was a laptop open day, and that's what we wanted to do differently about this conference, where we're not just yapping about stuff, but we're building and apping in a way. So we wanted to make sure that all of this is designed for practical knowledge, right? And yesterday, just so you know, we actually had 20 workshops running, 5 rooms concurrently, and an entire leadership track as well. So we really wanted to put programming at the absolute heart of everything here. So we're all learning and building alongside each other. And because we want to create this place for learning, we also wanted to give the opportunity for the next generation to get this experience. So we were actually able to come together as a community to support 20 students who are actually scholars here today at the conference. So would you stand up and wave? So every one of these tickets were actually partially or fully sponsored by builders in our community who believe that this is what Singapore's AI future looks like. So what can we expect over the next 2 days? We didn't just string together a bunch of talks to keep you guys here for lunch and things like that, but we wanted to bring you the kind of conversations that you can't just Google or find in Coursera, but actually be in the thick of these conversations that are happening with the people who are actually building with these tools, whether it's on Twitter or research papers and all of that. So we want to bring these conversations so you can be in the middle of them as well. And we know that there's a lot going on. There's over 60 talks actually within the next 2 days across 3 themes, and you may need some help kind of navigating and figuring things out. So we actually have a guide that we sent out in email that has a map that we actually vibe coded, as well as a complete program list as well. Not only that, we created an API that you can actually use that's publicly available, so you can actually build your own tool on top of the program, because we didn't just want to create like a one-size-fits-all app that you download and you use. We wanted to create something that you can actually build for yourself, because that's kind of the spirit of what we do. So AIE today and tomorrow is going to be spread across different spaces. This theater right here in Capitol Theater is going to be where all the talks are going to be happening. And once you kind of get that inspiration for like, you know what, I really want to go talk to this team, that was super interesting, we have 2 expo areas set up. One is going to be in Pullman across the street, and the other is the Atelier in Kempinski. And these are, again, not just booths that people are just setting up just because, but we actually made this a curated space where you can actually have face-to-face conversations with the very people who are building the tools that you are using. And then finally, we also wanted to make sure that we give you space to decompress and touch grass as well, because it's a long 2 days. So we're happy to share that we're going to have a 15-minute break session where there's going to be an experiential space called The Cave, which is a immersive sound reactive decompression room that was actually entirely vibe coded by the creator. You'll also find a lot of folks running around with red shirts. These are our amazing volunteers who will be helping you navigate the spaces and make sure that you get the most out of every conversation happening here today. And we'll not be in this room without our incredible sponsors. So our diamond sponsors are OpenAI and Exa AI. And our platinum sponsors are Google DeepMind, Arise, and Cursor. And thank you to the Capitol Theater for providing us with this beautiful space. Now, the Singapore story has always started with the builders, which is why a few weeks ago, it really blew our minds when our very own Minister for Foreign Affairs, Dr. Vivian Balakrishnan, went viral for a post on Twitter for building his own second brain. And it makes sense because he has a role that demands navigating large volumes of information and rapid context switching. So his reflections on building this kind of workflow and tool for him really underscores that meaningful conversation about AI should involve understanding the tools themselves and not just thinking about, the abstracts of it. With that, I am absolutely honored to introduce our keynote speaker and a builder himself, Singapore's Minister for Foreign Affairs, Dr. Vivian Balakrishnan.
Hi, good morning, everyone. We can be a bit more informal in Singapore. So, good morning. I know it's raining, but Singapore's usually sunny. I feel like an imposter here. For those of you who don't know me, I'm actually a retired eye surgeon. Took a detour into politics for perhaps too long. But I've always retained an interest in getting things done, building things, fixing things. And since I don't get to operate on eyes anymore, I assemble watches, I reprogram appliances, and now there's some other stuff, which is what I'm going to talk about today. But actually, I wanted to explain why I did it and the implications of this. And I think with this audience, you'll get it straight away. But let me jump to the end and to say these are the 3 key messages, which you can forget everything I've said, but just bear these things in mind. We're now at an age when you can outsource a lot of stuff. Calculations, computation, memory, replication, dissemination of knowledge. The one thing which you cannot outsource is your personal understanding. And if you are in a position of authority, you can delegate work, you can't delegate accountability. So remember the personal element in that. Understanding and accountability. The next point, and I would refer you to a nice short letter published in the Financial Times by Professor Neil Lawrence, University of Cambridge. He's the professor of machine learning. And there's a lot of hype about AI, models, data centers, top-down systems, rules, governments. That's macro. But his hypothesis is that real value for the economy and society is created at the ground level, workflow by workflow, sector by sector, department by department, and in fact, at the individual level. What this means is that look, I know you guys are great, and I know the guys working on frontier models are incredible, but the real payoff is when ordinary people, teachers, lawyers, technicians, managers, doctors, lawyers, or even ministers are actually using the tools which are already available, already invented. People who know their jobs and are empowered by these tools. That's how you create real value for society and for the economy. So I'm looking at decentralization, individualization, bespoke models. I'm talking about making yourself better at what your day job is, and even better still, re-engineering the workflows of your life. That's where the real value boost is. And the third takeaway, and that's why I'm making this presentation, is that I sincerely believe the barriers for achieving all this have collapsed. The tools have already been invented. It's a matter of getting people to understand what tools are out there, assemble their own tools, and put ourselves on a completely different trajectory. Okay, so now let's do the fun part as to what my adventures began. Now, my personal agent first came to life almost exactly 3 months ago. Yes, I got caught up by the OpenClaw hype, but immediately, given my job, I knew that was not practical because security was an issue, and then someone else then pointed to NanoClaw, and I think we are going to hear from Gavriel after this, where, and as a geek and as a tinkerer myself, I like stuff which I can grasp. So the fact that NanoClaw has a very short code base, which even an idiot like me can read and sort of understand, the fact that it's containerized, and as a surgeon, I know that there's no such thing as a routine operation, and things will go wrong, things will break, and when they do break, hopefully you want them to break within barriers. So the containerization part, the understandability part was vital for me. Anyway, simple, go to GitHub, download the stuff. And the other attractive part about it is there are no configs. In fact, because you rely on an LLM to do all the bespoke, tailored customizations, in fact, you realize everyone running an instance of NanoClaw is running an individualized system. Now, that's both good and also has its share of complications. But anyway, so let me tell you what I did with it. Right? So NanoClaw provides the platform. It allows me to communicate through WhatsApp with my agent. That part's not rocket science. The thing which, if I could go back one slide, the thing which I was really after was how could I use it for my daily life? Let me give you an idea of my daily life. This month, I'm visiting 12 countries. I will therefore have to meet hundreds of people. I will have to understand the country's economy, geography, culture, history, war and peace. I need to know people as individuals and not just something from a brief. And there's a huge, huge cognitive overload on every single diplomat. And the question is, how can I turbocharge this process so that if I need a fact or a factoid, I can get it anywhere, and I can go down the rabbit hole if need be. So it's got to do with this whole overload. The LLMs are useful for analysis, for abstraction, for expression, and certainly for drafting briefs, drafting speeches, formulating answers to questions, including, I must add, parliamentary questions. And 3 months ago, which includes the whole debates in Parliament, it was extremely impressive to see both the questions and the answers which it generated. And with due respect to all my colleagues in Parliament, some of the AI-generated debates far more incisive, shall I say. But anyway, so it communicates with me through WhatsApp. So there's this bit of software called Baileys. I suspect it's probably not entirely in keeping with what Meta or WhatsApp would like us to do, because it's actually simulating. You know the way we get WhatsApp to work in our browsers or on our laptops. So it's a pseudo terminal in a sense. Then the bit which I believe is the real frontier for people like me is memory. And fortunately, I came across this obscure piece of software called Nieman. I still haven't met the developers, so I don't really know, but a memory system with graphs. So it's got entities. The edges are entities, causality, temporal relationships, and semantic. And also, because I didn't want to be confined to just keyword searches, the fact that I could run Ollama locally with an embedding model means I also have semantic search built in. So with these elements, I mean, Whisper is the part that's easy, because with WhatsApp, I didn't want to only have to type. I wanted to be able to speak, and it can speak back to me. And of course, my dream is one day to just have my agent answer supplementary questions in Parliament. I'm not sure about the legality of that, but if it happens, you know that I shared the idea with you first. But the point is, I was now able to curate material, speeches, transcripts, particularly of my own contributions, get it into the system, digest it, extract it, put into that memory database, and then around the same time, Andrej Karpathy came up with his LLM supervised wiki generation, so I added that in as well. And then for the UX, the user interface, I used Obsidian. Partly also because Obsidian allows me to use the Apple iCloud. And that therefore immediately means I've got a personal cloud, and all the wikis which are extracted from this personally curated database becomes available to me. Because remember, I started off by saying the key is personal understanding. So I've got a memory system, I've got a communication system, I've got an analysis system, but all nice in theory. But what I'm here to share with you is that in the last 3 months, I found it incredibly useful. Meeting people, traveling, first drafts, first cut of a speech, even today's presentation, even the slides actually were generated by Claude. You know, it's turbocharged the pace at which things can be done. And as a practitioner, so not as an engineer, but as a practitioner with a day job, it's useful. And I can attest to its usefulness because I can honestly tell you I have not dared to switch it off. And NanoClaw, unfortunately, well, has moved from version 1 to version 2. When version 2 came on, because that transition is not at all smooth, I've left version 1 working, and I put version 2 on another computer. And I should also add, all this stuff, my most daily used agent is running off a Raspberry Pi, which is at least 2 or 3 years old, all it has is 8 gigabytes of RAM. You see my point about accessibility, personalization, relevance, use. Let's go on to the next slide. And this is my point. The barriers have fallen. Because I did this without writing Claude, Baileys, Neiman, Whisper, or the credentialing system. You know, there's this whole thing about vibe coding. I won't even dare to claim I was vibe coding. I was just assembling tools. It's just tool assembly. And so I should actually change that line. I didn't write any glue. I can honestly say, yes, I have gone through the code. You know, the NanoClaw insists that you approve for every time you give bash access to the agent. So I do scan through it, and it does help. It does help if you don't understand coding. So you understand what's going on, even if you're not actually typing and editing code in the raw. Next. In a sense, my approach to all this has been to learn by doing. It's not enough to sit down and read, get the headlines, get the summaries done. If you're interested in anything, get your hands wet. Learn, and you learn best by doing. And because the barriers for entry have come down so dramatically, everyone should embark on their personal experiments. And you know, Claude came up with this quote, which I got a bit suspicious about. You know, who has said it before? It says it claims no one else has. But actually, I kind of agreed with it. And this is a shout out to my government colleagues. You cannot govern a technology that you have only been briefed on. You better get your hands dirty. And then you understand both the potential and the limits and the problems. A few other digressions down here. There are constraints. So for instance, depending on LLMs, and quite frankly, I mean, the prices for which the AI majors are currently charging us, I think we all know we're enjoying, in effect, a subsidy. Tokens are not cheap. Compute power is limited. Electricity prices have risen. Wars do not help. And we should beware of just trying to throw every problem and every step in a solution at an LLM. It reminds me of the old proverb, you know, for a man with a hammer, everything looks like a nail. And in fact, there are good both economic and design advantages so that you use LLMs, but do not forget there is still a role for deterministic systems. There is still a role for expert, rule-based systems. And my personal belief as a biologist, in the end, some kind of neuro-symbolic system, rather than just the LLM model. And I have some sympathy for Jan LeCun, who says, you know, I think that LLMs are great, but actually that's not the way we've solved it in nature. If you look at the human brain, actually I suspect we have less layers of computation in a human brain than in many of the large language models which we have today. And I can tell you as an eye surgeon, the cortical computation for vision, for language, for cognition are often based on far more efficient structures than the energy gobbling systems which we have today. The point I'm making, and where I'm agreeing with Yan LeCun, is that in the end, these are pattern recognition systems with attention, with memory, and out of what looks like simple fundamental abilities is emergent behavior, which gives you conceptual understanding, which gives you language, which gives you the ability to do things. So my point is, this is a field which is still exploding. And therefore, approach this with humility, approach this by just doing your best, improving the productivity of your daily job, but understand that actually we are perhaps one of the most privileged generations to be living through a revolution. Tools matter more than models, and I think Gavriel will know, I've told him by June, I think it's June the 15th, I need NanoClaw to make all models first-class citizens. There are reasons for that, which we can discuss later. And then finally, memory. It is a very human, and I think it is the great unsolved part of this frontier. Next slide, which I think on security, I'm not going to belabor this. Just as an aside, even if you hack my system, the most thing you'll get from it is my phone number. You will get summaries of foreign policy, but since it's foreign policy which I have espoused, and in any case I have curated the stuff I put in, even if you take my system, I think it will generate the foreign policy of Singapore anyway. Now, that's one way of addressing security, by making sure you only put what is already open source, what is already published, and you subject your systems to a level of transparency and scrutiny that can be withstood. But do not forget, security remains paramount. And in fact, the complication to the dissemination of AI is going to be commercial competition, national security, cyber security, and the superpower contestation. These are the political factors that are going to affect the availability, the speed, and the dissemination of AI of the future. This, again, is a separate political talk, well worth a deep dive. And next slide, and I hope that is my last slide. So, the goals. I'm a believer in deployment at the edge. I'm a surgeon. I believe in doing. I believe in fixing. I believe that's where lives are saved, value is created. Second, therefore, the public policy goal is the democratization of these tools. And that's why you'll see in the Economic Strategy Review Committee, DPM Gan said Singapore is not likely to be at the frontier of model development, but we can be at the frontier of deployment at scale. So, democratization. And therefore, if that's what we believe, then it must be a decentralized, ground-up approach. And that's why I'm here today, because I found out this conference was organized less than 3 months ago, 65 labs, all the people you meet here, this is all not even their day job. It's a hack, right? But this is the way I believe the future is going to be created. So thank you all for being here. Thank you for part of this journey. Have a wonderful day, a wonderful future. Thank you very much.
Oh,
I should have worn this before. You should have given it to me before. I would have worn it.
we weren't briefed, but thank you so much, so much.
Thank you. Okay. Where do I go?
Oh, come down here. All right.
open, right? Go Gary. Sherry's beside me. Should I let her know to make an announcement? Yeah, make an announcement.
All right, everybody, and I'm super excited to be introducing our next speaker, none other than the creator of NanoClaw himself, of NanoCo, Gavriel Cohen.
Yeah, he's just going to make an announcement first. Can you light the audio mics? Okay.
Hi, everybody. Really excited to be here. Just getting things set up.
I just need our sites to load, then
Yeah.
we'll punch it out.
Yeah.
Okay, the Wi-Fi is down. Wi-Fi is down.
Should I try to go to hotspot?
Can you mute the podium mics and just play some? Can you mute the podium mics and play some BGM first? Yeah. I don't see your Wi-Fi.
Wait, loading now.
I don't see the Wi-Fi. I don't see Wi-Fi name. Sorry, give me a second.
Yeah.
No,
It's gone. It's gone.
I don't see the Wi-Fi.
It's getting there.
Yeah.
There we go.
Okay.
All right. So this one, just order. I got it already here. Just needs to erase.
Can I stop extending the camera?
No, I'm gonna do extend. All right. Thank you. Hi, everybody. I'm Gavriel Cohen, and I created NanoClaw. I have in my Telegram right now a AI assistant that's connected to my emails, my calendar, connected to my call notes. It has access to sensitive information. It can take sensitive action like reading my emails, sending out an invite. At the end of this presentation, 15 minutes, I will give everybody here access to talk to it freely. And I can do that, and I'm not crazy, and that's not dangerous. And throughout this talk, I want to explain to you a few concepts about NanoClaw that make that safe. To demonstrate those concepts, I'm going to talk about our agent factory that we built. And along the way, I'll share some things that I think are interesting about choices we made while building it. So first of all, NanoClaw is an open source framework for building secure autonomous assistants, or claw assistants. In just 3 months, we have over 30,000 stars on GitHub and many thousands of users all over the world, including Dr. Vivian Balakrishnan, Foreign Minister of Singapore. More importantly, though, than stars on GitHub, over 12,000 people have forked the repository, and that's the main way people are using it. They're forking it, experimenting with it, and making their own autonomous agent based on NanoClaw. Together with that, we have over 2,500 pull requests and issues. So maintaining an open source project today, there's never been a better time to build open source projects. At the same time, there are new challenges. With coding agents, it's easier than ever to open a pull request. And many people, many thousands of people are making great contributions to the project. But there are, frankly, also spam pull requests. People will point their coding agent at a repo and say, contribute something here. It is very difficult to tell the difference between a spam pull request and a good pull request today. They look the same. They can have similar amounts of code. And telling the difference comes down to a deep understanding of the project and the direction of the project, the vision. So we built, to help us sort through these pull requests, we built an agent factory that helps us review every single contribution. This is our agent factory. It's in our Slack. It's hosted on an xe.dev virtual machine. Every single PR that's open in GitHub fires a webhook that creates a new thread in our Slack. A review agent first triages and then does an in-depth review. It then gets passed on to testing. First creates a testing plan for in-depth testing, real-life testing, not just automated tests. And then once we approve the plan, it gets a new VM is spun up. It goes through a whole series of tests. And then once it's done, we can merge it directly within the factory, and it goes live. So half of you are probably looking at this going, amazing, I want to build a factory like this myself. The other half of you are thinking about the security implications and going, this is crazy. This is reckless, it's unsafe. Pull requests, of course, are unsanitized input. Right? Anybody can open a pull request, anybody can put things in there. You can't really sanitize a pull request because I don't want to remove information from it. There's going to be false positives and everything. You can imagine a pull request that's opened to harden for security to defend against prompt injections. It would trigger any kind of detection. So this goes way beyond lethal trifecta. And our workers, our agents in the factory are taking very sensitive actions. They're spinning up VMs. They're merging pull requests. So how can we prevent our agents from being prompt injected? You obviously can't do this, right? If you go into a code base and you see at the top of the claw.md, never run drop database production. So that tells you two things about that agent. It tells you that that agent has deleted a production database before. And it tells you that the agent can still do it if they put that instruction there. So it still has that ability. Instructions are not for security. They're not for safety. Instructions are for steering your agent towards producing valuable, high-quality output towards the direction you want it to go for you. So how do we deal with these kinds of risks with NanoClaw? So we think about our agents as if they're operating in enemy territory, behind enemy lines, because they're in contact with the enemy, right? Somebody who's potentially a malicious actor who's trying to work against you and get your agent to work against you. So if you think about a map of a conflict, you have the red zone and the blue zone, and the blue zone is our side, the red zone is the other side. Agents are operating in the red zone, and at any moment they could be turned into a double agent. So we don't trust our agents. In NanoClaw, agents are not considered trusted. Instead, they're isolated. So this is a simplified version of the NanoClaw architecture. You have on the left side Slack or whatever messaging app. You send the message there, it goes to the Slack servers, and then it gets sent to wherever your NanoClaw is running, in this case, say a VM. There's a Slack bridge which connects to the Slack server with a socket or webhook. Every message gets sent to the Slack bridge, and then from there through a router and pushed to the agent. The agent responds, it produces some output that's sent back through the router, back to the Slack bridge, Slack server, and appears in your messaging app as a response from the agent, from your Slack bot or whatnot. But the agent is potentially compromised. It's operating in the red zone. So anything that the agent can touch is potentially compromised. If the agent can access the router, if the agent can access the Slack bridge, it can manipulate those and change what messages it has access to and who it's able to send messages to. So rather than letting the agent access anything in the VM that it's running in or anything in the environment it's running in, we isolate the agent and put it within the VM within another isolation layer. In our case, normally we put it within a container. Now the container limits the blast radius. We control what goes in, what goes out, and what happens with the things that are coming out. So the agent isn't directly connected to a messaging channel. That already does a lot to limit the blast radius, but in order for our agent to access the outside world, it needs to have credentials if it wants to connect to services, whether it's GitHub or your calendar. And that could be using CLIs, APIs, MCPs, it doesn't matter. It needs some form of credential. So the second principle, first principle, isolation. Second principle is keep credentials outside of the agent environment. The agent's environment is enemy territory. You don't want to put anything that's highly sensitive in there, definitely not secrets and credentials. The only way to ensure that the agent will not leak a credential, it can't be done through instructions. It can't really be done through DLP or analyzing the outputs. The agent can circumvent that as well. The only way to prevent it from leaking a secret is to not give it a secret. So the way that we let it talk to external services that are credentialed without giving it credentials, we add between the agent's request a proxy. We give the agent a vault. We partnered with a really great open source project on this called OneCLI. Every request leaving the agent sandbox is proxied through the vault, and then we check the request and decide if we should add credentials. The request leaves the vault with no credentials, with literally authorization, bearer, placeholder. Literally the word placeholder. At the vault, the placeholder is replaced with the real credentials if the agent is supposed to have access to that resource. But isolating the agent and giving it this proxied credentials isn't enough, because if someone is talking directly with my agent, even if my agent doesn't hold the key, if it can take the sensitive action and you can manipulate it and prompt inject it, you can get it to take sensitive actions for you. So maybe you can't get my GitHub access token, but you can potentially get it to add you as a code owner. So we need to have another layer of policies, not just rubber stamping, letting every request through, but adding policies of what the agent can and cannot access. The most flexible policy for the most sensitive actions is human-in-the-loop approval. And what that looks like is, at the level where we're enforcing policies, we can have a policy set. This requires human approval. A request is then sent, not from the agent, but from the vault or from the router or the delivery part of NanoClaw. That message gets sent through the router to the Slack bridge and shows up in your messaging app as a permission request from the agent. Now this is actually an illusion. This was in the video before, and it looks like the agent is requesting your approval, and then you give the agent your approval, and then it goes ahead and merges your PR for you. None of that is happening. The agent can't request approval, and the agent doesn't actually have credentials to merge. Instead, the agent is trying to make a request using an MCP, where it writes out the command that it wants to run in GH with GitHub CLI. And then we display that to you as if it's a message, as if it's a request coming from the agent, but that's actually coming from the NanoClaw host process. Once you approve, the merge is actually done not at the level of the agent, but outside of the agent's environment. And that same pattern can be used to do any kind of sensitive action. Initiate a wire transfer, for example, the most sensitive actions. You need to separate the tool call from the tool execution. The tool call happens within the agent's environment, within the red zone. It leaves the red zone, and outside of the agent's environment, you then enforce policies and implement the action if it meets your policies, including human approval. One interesting pattern that's emerged that we found in our agent factory is that we have multiple different people reviewing and providing oversight over the reviews, the plans, the triage. Whoever presses the button to approve or to send it to testing, it uses their credentials. So you won't see in our GitHub any PRs being merged by a NanoClaw agent. I'm the one who presses the button. It means I'm approving that this is correct. I'm taking responsibility for it, and it's done with my credentials. So this is what our factory looks like. Another interesting thing is, so you can see here you have the Slack app, connects to the Slack bridge. We have multiple different bots, and then each of those bots get routed to a different NanoClaw agent. Each NanoClaw agent runs in its own container, so NanoClaw by default, by design, is multi-agent and can be multi-user, multi-tenant. Now, when the test plan is approved, that isn't running automated testing. What happens is we have a test orchestrator that creates a new VM, checks out the branch for that GitHub pull request in the VM. Our test agent then SSHs into the VM, runs the NanoClaw instance, and starts poking and prodding the agent, sending them a message in Telegram, getting a response, real-life testing, and then also is able to check databases and logs to verify behind the scenes that what you're expecting to happen does happen. Another last interesting pattern is that each of the agents in the Slack thread has a persistent environment and a persistent session. You can come to them at any time, tag any one of the different agents. We have a testing agent, reviewing agent, and give them direction, ask a follow-up question, change the depth of testing like you see here. We also have this ability to tag a supervisor and give feedback. You feel a little bit like a Karen, if anyone knows the meme. Can I talk to your supervisor? You leave feedback, and then the supervisor can suggest changes to the instructions and to the skills based on that feedback. And then once we approve those changes, they get implemented. So our factory is improving itself, essentially. So as promised, that QR code, if you scan it, I have my agent in Telegram. It has access to my emails, to my calendar, to my drive. But I feel safe giving you all access because this agent doesn't have any credentials in its environment. It's isolated. I control what goes into its environment and what comes out. And there are human approvals on every action. So that's connected to my calendar. I'll be here all day. I'd love to grab coffee with some people building interesting things in this space. Talk to it. I told it to be a little bit protective over my time. I hope it's not mean. But if you talk to it and tell it what you're building, hopefully it will schedule a coffee chat for you with me. Thank you.
All right, I'm super excited to introduce our next speaker. This is Thibault, who is the head of Codex at OpenAI. Now, Thibault unfortunately could not make it in person today, but he wanted to do the talk because it means a lot for him. So he will explain when he's up on the screen, which I think he's there. But the other thing that we'll be doing, which is super cool, is Thibault is excited to speak with some of the students for a Q&A. So let's give Thibault a warm welcome. Woo.
Hi, everyone. Glad to be here. I would have loved to be in person. It's just really incredibly exciting to see the room so packed. Singapore has such a unique energy, and I'm excited to chat to you all from San Francisco. I feel really proud to say that Singapore is actually in the top 5 countries globally for Codex adoption and engagement. It rose there fast. It feels like Singapore is just adopting new technologies at an unprecedented rate. Our mission overall is to deliver the benefits of AGI to all of humanity, and I believe that in the coming months, we'll make such incredible progress towards making AI deeply valuable to each and everyone in the world. We started with ChatGPT, and with Codex, we have focused on builders and developers. You might know Codex as this little app, but for us, it is our frontier agent. And I'm going to talk a little bit about what agents have done to software development and the whole life cycle. I don't have really to tell this room, but software development obviously is unrecognizable compared to 2 years ago, even 6 months ago. New models are capable of full agentic delegation, or examples like we saw with NanoClaw, where you have a full autonomous system just doing stuff for you, going far beyond programming. You just give it a job, it works on the task, the code base perhaps for hours independently, sometimes a full day, until the job is done. From the beginning, that's been our goal, to build an AI teammate you can delegate to. A useful way to think about the SDLC and building things is to think about it as a throughput problem. For decades, the software development lifecycle was designed around one core assumption. Code is hard to write. That assumption shaped really everything around it. We planned heavily because engineering time was scarce. We reviewed every line carefully because code was expensive to get wrong. We built delivery systems around the idea that the build step was the narrowest part of the pipe. Agentic coding has really changed this assumption. It has dramatically widened the build section of the pipe, but if the rest stays narrow, the total throughput does not actually increase. The constraint moves into the systems around the build step: planning, reviewing, validation, CI, security, release operations, debugging, and even learning and understanding of what's actually happening, which is a big part of the new bottleneck. That shift is something that everyone here needs to understand. The opportunity was not just to generate more code faster, but it is to redesign the entirety of how we do engineering and how we can increase the overall throughput of what we deliver together. The first wave of AI coding just really expanded this build phase. We were all very excited to be able to write a lot of code faster. That matters. It means engineers can generate, modify, and test code at a speed never seen before. But as we said earlier, just widening the build section does not increase total throughput. The next step was really to look at expanding capacity across the full software delivery lifecycle. This is how we think about Codex, our agent. It's not just a coding assistant, but an agent that can work across the full layer of building software. In the build step, Codex can help engineers delegate implementation work. In review, Codex can help inspect changes, surface issues, support human review. In deploy and operations, cloud agents and automations can help teams respond to triggers, investigate issues, and keep work moving through the system at unprecedented pace. The goal is not to remove humans from the process. The goal is really to make every stage more scalable, so higher code output can actually become more shipped value. This is a key distinction. Agentic coding increases code velocity, but agents like Codex help organizations expand the system around that velocity. So there are like these different steps here, and we can see that you can use an agent to increase the velocity of planning, velocity of building, the velocity of reviewing, and even the velocity of deploying. If you think about it, planning, building, and reviewing is a little bit easier because you don't really have a side effect upon the world, and deploy is when security starts to really matter as you're having an actual impact and the code gets actually deployed out there and meets your users where they are. We have automations for this. We allow to build around the agents in CK as well, and then we have a version of our cloud agents, which can have secure access through our plugin system and allow you to deploy and verify that the deploys are correct through human approvals. This is a journey we started a long time ago. The Codex team is special in the sense that we designed both the agent and the models to power those agents, and we work deeply within the research in order to advance the state of the art for our models. This started with a model, GPT-5.1 Codex Max, which is now famous for its name, which we released at the end of 2025. It was trained on end-to-end RL for compaction for long-running tasks. This means that in its environment, during RL, we were exercising tasks that would challenge the model to work well beyond its context window. And at the end of its context window, it would need to delegate to itself in order to achieve a task across many context windows of inference. We also shipped a high reasoning effort. We trained it to operate natively on Windows, and we showed that we could achieve better performance with 30% fewer thinking tokens and achieving a new state-of-the-art token efficiency. This is a theme that will continue and that we've seen across every other model ship. The token efficiency just gets better and better and better, which both makes it faster and cheaper to run agents over time. With 5.2, we increased cybersecurity capabilities, which is really a precursor to what we've seen now with models with unprecedented capabilities around cyber. We've improved performance across large code changes, but also we added vision capabilities. We're not just building a text-to-text model, we're building an everything agent. With 5.3, we made it faster. With 5.4, we added 1 million context window. And 5.5 has been our biggest step change so far, even though it seems at face value, it's only a little incremental 0.1 improvement from 5.4 to 5.5. It was actually a much bigger change. We added computer use, and we made it even more token efficient. It is really the smartest and fastest model available out there today. What makes it work, though, is not just the model. It is a combination of the model and its harness. This is why Codex is special. We're capable of co-designing these things and making the harness really optimized for the model and the model optimized for the harness. It allows us to deliver a new class of intelligence very broadly and very efficiently. 5.5 was released only a few weeks ago, and we saw revenue grow more than 2 times faster than any prior release. People really love it. And we've seen adoption really go wild. You can see here that it set a new industry high on Bench Pro. We also achieved a new SOTA on Terminal Bench. It seems like we're just pushing the frontier model after model, model after model, and we're now shipping at a cadence of roughly 1 model a month. We did all this while also delivering unprecedented reliability, and this was no short feat. Really, the level of engineering and infrastructure improvements that we needed to deliver were started a year ago, which allowed us to scale with unprecedented demand. Usage exploded. We're serving 5.5 at a level of traffic that makes me feel at times like we have an amazing team of engineers and on-callers. And it's also one thing that is rarely talked about is how efficient our models are. And this allows us to offer just really generous limits across the plans. We've achieved 3 nines of availability, which I'm very proud of, all while scaling and being used across hundreds of companies. We've now over 4 million and approaching soon 5 million weekly active users. And it's never been a better time to get started. A lot of engineers write more code. We've already talked about that. But what we haven't talked about is that inside of OpenAI, just really everyone I see, everyone I talk to uses Codex for literally everything, not just for engineering. We're seeing the marketing department use it. We're seeing finance raising rounds of incredible fundraisers, using Codex to coordinate it all. It has become this everything agent. And because we're building Codex using Codex, we've never built faster. We've released an extraordinary amount of features this year. Team configuration, new models, Codex for Windows. The Codex app itself is only 3 months old, which still shocks me when I think about it. We've released fast mode. We released auto review as well, which is one of my favorite features. When you think about agents and security and safety, one thing that is often overlooked is that approvals and human approvals are something that leads to fatigue and mistakes over time. If you have to go and verify everything that your agent is doing and thinking hard about whether you want to approve it or not, then you're bound to make a mistake at some point and give it too much access or allow it to do something or merge a PR or worse, send some information off somewhere that you shouldn't have done. This is going to be true as we continue to scale and you have many more agents working for you. Auto review is a new system which introduces a second agent, which verifies the actions of the first agent. And it verifies them against the original intent of your task. So if you say, hey, go and check my important emails, for example, and pull the last 3 that are specific to the goals that I have set today, then auto review will understand that this is your intent and verify each action from the main agent against that intent. Anything that is suspicious or high risk and not aligned with that intent will get blocked, and the main agent will get redirected to try and do something else. This is very important because it allows you to preserve the human attention and not fatigue you with unnecessary approvals. This is the default now within OpenAI, and it has reduced approvals by a factor of 20. We're seeing gains across the company across much more than coding. There's a bunch of pillars that we're investing in: automating more, deeper enterprise controls, leading on models, and the overall developer experience. I'm really proud of how polished the application has been that we have shipped and how delightful the experience is. I invite you to all try it. It's really a different way to interact with agents. And over time, we're going to evolve it into the cockpit for every agent that you manage. Codex unlocks so much for builders, but also for almost everything. We're seeing really incredible use cases for even non-technical people. This is Rowan's mom, just experiencing the magic of Image Gen 2 for the first time in ChatGPT. And she's a long-time recruiter. She really needed to do a bunch of things across managing her resumes, and she wanted to go back into recruiting. We showed her Codex, and she just immediately got it. There's new ways of interacting with agents that is really going to come to everyone. We don't think agents are just for technical people. There are different challenges when you think about bringing agents to the world, where you just really need to preserve the magic while also making it safe and secure. But we think this is going to come to the world very soon, and it's not going to be just enabling engineers and technical people to become more effective. We're linking our agents to the entire world. We have plugins for almost everything. We also are working on memory systems. We're working on new models. You can set up automation so they can run on a specific schedule, maybe every few hours, to give you a report. And really, what we're starting to see is that the models are so reliable at doing complex tasks that it's just really a question of what is the context and what is the access that you give those models. And this is really what is capping the potential right now. It's like how much access to the world these models have. We're seeing great success in different areas. Let me make this concrete with one example of one of the world's most advanced engineering organizations, C Limited, one of APAC's largest digital platforms and a major OpenAI customer. C has gone all in with Codex. It's rolled it out across its entire developer organization. and its chief product officer shared with us that Codex just goes beyond coding and feels pretty magical. We're excited to have the first regional Codex Hackathon Series at C starting on the 6th of June, right here in Singapore. I'd love for you all to join, and do check it out online. We rolled it out to also 45,000 employees across NVIDIA. We did it in only 2 weeks. Codex helped itself with the deployment within NVIDIA, and this is a trend that we're seeing. We're just using agents to accelerate everything, including the deployment and the development of Codex itself. What's special about Codex is it's entirely open source. You can read the code of the harness just on GitHub. It's on the Codex repo. You can also bring it anywhere. We now just released remote control through the ChatGPT app. So you can have it run on a Raspberry Pi, you can have it run on a Mac Mini, you can have it run on your laptop, and then fully control it over a secure connection, just straight from your app. You can also, the thing that's pretty magical that I love doing is using the plugins for browser use or computer use and allow it to just use and navigate across your computer, but like use this little command, this little remote control that you just have on your phone. And I think this is something that we will soon realize is that agents will have a certain permanence to it, and we will just really start to consider them to be like these little entities in the cloud that we can reach from all sorts of different clients, be it on the web, be it through a desktop app, be it through a client. Eventually, you'll just pick up your phone and talk to your agent, and it will still be able to do things for you and have access to everything in your life. We also ship fast and we fix fast. We're not shy of sometimes making mistakes and resetting some rate limits when we get things wrong. One thing that's cool as well is Peter is working with me. He's the original creator of OpenClaw. We also support this as an open source project. We recently worked on rewriting the core of OpenClaw to be based on the same foundation as Codex. So it actually runs the Codex agent under the hood. You can read about it on the open source repo. Again, like all of this code is open source. And we really want to contribute to like this new generation of inventions by just showing how you can do these things in a simple way. We're taking safety first. We're also thinking a lot about security. We innovated on Windows sandboxing. We publish a lot about this on our blog posts. You can read all about the Windows sandboxing there. And we're trying to solve the hard problems at the product layer as well. And in the future, we hope to bring agents to the scale of all of ChatGPT, which almost now has 1 billion users. There's a lot of things that I'm excited about, but here are some that we're really working on hard. We're working on new memory systems. We shipped Chronicle, which is an experimental and in research preview, which allows your agent to just follow everything that you've done on your screen and form memories from it so that it knows what you did last week, it knows what you did during the day, and it gets a lot more contextual. We're working on massive multi-agent systems with the next generation of models. We think this will be quite groundbreaking in a new way, in a new scaling paradigm. And then we're working on new ways of handling tools, which I'm excited to share on more in the future. I heard that several of the builders in this room wanted to ask a few questions. And unfortunately, I'm not able to hear the questions live, but we've compiled a few of the questions, and I would love to go through 2 of them. Here's a question from Louis. The DevX on the Codex app is the best I've seen. Project organization, the div view, one-tap PRs, it has changed how I build. As agents get more capable, and the user base broadens beyond developers, how do you think about the interface layer? Chat feels like a default we inherited from LLMs, but it's actually the right model for how humans should work with agents long term. What does that evolution look like to you? I think this is very interesting. And initially, we just really inherited this thing where we were powering LLMs, through LLMs, we were powering chat conversational interfaces. And ChatGPT started that revolution. And what we're seeing is now that LLMs can do things on your behalf and get access to everything. We have to evolve how we think about these things. And it's just really going to profoundly change, I think, the way that we interact with computers, with technology. And I hope it sort of frees us from some of the limitations that we have I think collectively fun as well, where we're always glued on our phone, kind of tucked over. Maybe we're like typing furiously on our laptop and sort of like, we're not connecting enough to others. I think the future is going to be a future where people are much more connected and everything is much more ambient and seamless around you. And you can interact with technology through natural language, through natural voice, in a very multimodal way. And it sort of fluidly adapts to what you want to do in that moment. And this is hard to imagine now, but I think, within a year or so, we're going to start seeing like the signs of that, where agents get embodied and things get a lot more natural. Just you continue to leverage all of this through natural voice. We're going to break apart the boundaries of the applications that exist today on your computer. Vihan asked, you've said some scaffolding should disappear as the model gets better, but skill seems like a kind of user-owned scaffolding that should maybe stay. When something fails, how do you decide whether to fix it in the model, the harness, a skill, or somewhere else without accidentally turning today's model limitations into tomorrow's infra? This is something that we think a lot about, and it's something that is unique to our setup where we have control over the model, we have control over the harness and the product and the agent primitives. Oftentimes, we actually ask ourselves, hey, what if we don't fix this in the harness today? How quickly is it going to be possible to improve the models? This is something that, for example, for end-to-end compaction and end-to-end RL and compaction for very long-running tasks, before that, people were trying to sort of like fix this with like manual compaction and very complex systems to keep state around. We were thinking maybe we can fix this by working very hard on the next model train and just being able to keep that coherence around very long horizons of tasks. And so we fixed it at the model. Sometimes we estimate that it takes more than a couple of months to fix it in the next generation of models, and then we decide to take a bit of a shortcut and fix it in the harness instead. And so there's always this healthy tension, but we're able to co-design things and just really approach things from first principles, which always makes me very excited to think about these problems. There's a few more questions, but I think I'm running a little bit short of time. And I just wanted to thank you all for being here. And I invite you to just all tinker with this technology and think about what the future is going to look like, and to invite it into your lives. It's here to stay. It's going to continue to evolve. It's a beautiful time to just explore all of these things. And I hope you have a wonderful time building.
I would like to invite to the stage Dr. Feng Yuzhang, Head of AI Practice at GovTech.
Good morning, everyone. My name is Yuzhang. I lead the AI team at GovTech Singapore. Very glad to be here today at the AI Engineer Singapore event to share with you how we are driving the adoption of AI in Singapore government. Wrong clicker. Yes. So a very quick introduction of GovTech, in case you are not familiar. GovTech is the lead agency driving Singapore's Smart Nation initiative and public sector digital transformation. We harness the power of technology to deliver digital government services. I'm sure some of you, or actually many of you, have actually used some GovTech products, such as SingPass, LiveSG, Go Business, etc. Our mission is really to engineer a digital government and make lives better. In fact, GovTech was formed in the year 2016, and this year we are celebrating 10 years of tech for public good. Coming back to AI, it is clear that the government must adopt AI. The first and most immediate reason is obviously for effectiveness and efficiency. Our government is responsible for delivering services that millions of people depend on every day. AI gives us the opportunity to actually do this much faster, more accurately, and at a greater scale. So that is an opportunity we cannot afford to miss. But beyond the operational gains, there's the question of expectation from the citizens and businesses. As new technology reshape how citizens live and how businesses operate, people increasingly expect the government to keep pace with the technology. This will increase the trust and confidence from the people the government serves. There's also a deeper reason. To govern well in the digital world, we need to understand the technology shaping it. Hands-on experience with AI builds the intuition necessary to craft a policy that are thoughtful, grounded, and fit for purpose, protecting our citizens while enabling innovation. And finally, if we want our entire nation to embrace AI, like how our Prime Minister has said so, the government must not sit on the sideline. We must lead by example. When citizens see their government using AI responsibly and effectively, it builds the confidence and sets the tone for the whole of society. In fact, we are not starting from scratch. For years, our government has already been using AI in many areas to inform policy and improve operations and service delivery, both internally within the agencies, as well as externally serving citizens and businesses. Just to share a few examples, among the tons of AI use cases that we have implemented in government. In healthcare, AI has been developed to detect early signs of pre-dementia. This technology achieved a very high level of accuracy, and the results were published in the scientific journal Nature Communications. We are actually rolling out this technology at community sites this year. In education, AI has been deployed to assist teachers mark assignments faster with higher accuracy, cutting down 3 to 4 hours of marking per class and allowing teachers more time to engage the students. For jobs and skill, our recommendation engine has been powering My Career's Future in delivering personalized job and course recommendations for Singaporeans and residents to find more suitable jobs faster and also learn new skills more effectively. For citizen services, we have developed and deployed the latest AI model to our citizen call centers. The transcription, summarization, and analytics capabilities allow us to serve our citizens better, reducing the after-call works by 72% and improving customer satisfaction to 95%. At the same time, we also make sure we apply AI responsibly by developing safety testing tools and guardrails to ensure our AI solutions are safe, secure, and behaving in the intended way. While we have made significant progress in bringing AI into the government, over the last few years, we aspire to actually go even further, from being AI-enabled to becoming an AI-native government. So what is the difference, you may ask? An AI-enabled government uses AI as a tool, a helpful addition to the existing processes. It is usually built on top of legacy systems, and there is incremental improvement. The system scales, but not compounds. On the contrary, an AI-native government is something far more ambitious. It means AI is the foundation and the core of everything. We reimagine how government works from the ground up, with AI embedded in the way we think, design, and deliver. There is always continuous innovation. So what does AI-native government mean to us exactly, and how we are working towards that? We think about it in 4 pillars, differentiated by user personas, and 1 horizontal. Let me just quickly walk you through. Firstly, we want every single public officer to be augmented by AI, all 150,000 of them, from ground staff all the way to the Prime Minister. No exception. I think just now Minister Vivian talked about how he uses and builds AI. In two weeks' time, I'm going to conduct a technical hands-on training to a room full of permanent secretaries on building agents. We really want to put the AI productivity tools into the hands of every single public officer to help them with their daily tasks and workflows, such as drafting, summarizing, transcribing, analyzing, and etc. Second, we want citizen developers to be building with AI. These are basically the non-technical officers who are closest to the problem statements that we are interested in. They can be policy officers, they can be citizen engagement officers, they can be product managers or designers. We want to provide the tools to them for them to be able to vibe code, create prototypes, and deploy them. Personally, I feel this is a game changer because it will change the entire innovation model within the government. And now, without relying on the engineers, people can actually bring their ideas to life early in the stage. Thirdly, for software engineers, AI allows them to build production-grade applications with greater speed and quality, compressing the entire software development lifecycle. We have already rolled out many various AI coding assistants, like Claude Code, Codex, to our developers. This is not just to help them with the activity of coding, but also the entire SDLC, such as code review, testing, and documentation. Last pillar is about AI for the domain transformation and modernization. We want to focus on a few key domains, such as education, transportation, and healthcare, and the cross-cutting functions such as HR and finance, and completely redesign the business processes for better outcome. You will see underpinning all these AI initiatives is our government AI stack, which really provides the latest foundation models and those custom-built AI capabilities in vision, speech, document analysis, evals, and safety, all with government context and localization. This will ensure our AI solutions are supported by performance models, have shorter time to market, and also are safe and secure by design. As part of the platform, we are also building capabilities in agent harness. Let me spend a few minutes to explain what it is and why we are doing it. Looking ahead, we understand from the industry that AI agents is going to proliferate very soon. This will mean AI becoming more capable, having access to data, having access to tools, being able to perform actions in an autonomous fashion. According to an IDC study, there will be more than 1.3 billion AI agents by the year 2028. It's a very big and scary number, but personally, I find this could be actually very conservative by the rate of development that we can observe. We can already see people starting to develop agents either for their personal use, for the team's collaboration, or even consumption at the enterprise level. There's a whole range of use cases in the government for agentic AI, in citizen services, policy research, and etc. With the proliferation of AI agents in the government, we must think about a way to effectively enable them, optimize them, and manage them so that we can maximize the value and manage any associated risks that comes with them. We are building a sovereign agentic harness, which include a few components. MCP gateway, which serves as a front door, agentic runtime, which provides a sandbox environment, and also the resources for the agents to perform their actions. Agent identity management, which ensure each agent has a verified identity, knows what is allowed to do, and cannot overstep its boundaries. An agent memory, which provides personalized experience to users with short-term memory within a single conversation, and the long-term memory across multiple sessions. Observability is important. It provides the oversight to the entire agentic ecosystem, monitoring what agents have been doing, catching problems early, and understanding what has gone wrong. A skills platform which contains a rich library of ready-made capabilities, like searching the web, reading documents, sending emails, all versioned, evaluated, shareable, and governed so that agents can draw upon to complete their tasks. The idea is that every single assistant or agents in the government, whether it's a coding agent, or it's a co-work session, or it's a workflow agent, is a client of this stack. One door, everything is visible. You might think that it's relatively simple to think about it, in an individual local setup. But it is a whole different ballgame at the enterprise level, especially if you think about it, in an ecosystem across multiple organizations within the government. As an analogy, I always like to think about it, in the car example. A super powerful car engine by themselves are not good enough to actually bring people from one point to another. You need robust car bodies. You actually need the roads. You also need the clear traffic rules, for safe and efficient commute. Similarly, AI models are like car engines. They are not good enough to be effective agents. They need a harness to be truly useful and trustworthy. Hence, a key strategy for us to work towards the agentic AI is actually to invest heavily in building these capabilities in the agent harness. That leads to the end of my sharing. Thank you very much for your attention. It is really exciting time. It is really an exciting time ahead of us. Do collaborate with us. And also, if you are interested in joining us in this meaningful journey, AI for public good. If you are interested, please visit our booth. We have teams showcasing some of the work, the initiative, the projects that we are working on. They will be more than happy to share more details with you. I'll also be very happy to connect with you on LinkedIn and also share more about collaboration opportunities. Thank you very much.
All right, I would like to invite to the stage our first speaker in our design track, Phil, CEO and co-founder of Airfoil. Also, quick PSA, it is past 10 a.m., so our expos are actually all open as well in Pullman, as well as Capitol Kempinski. If you need to refer to any maps, we have some tools for that. Thank you.
Okay. Hopefully it should just go straight in. Screen. Great. Oh, great, we got a clicker. Awesome. Testing, testing. Okay. Awesome. Good morning, everybody. It's great to see all of you here, and honestly, so surreal to think that this entire conference is happening, that so many of you have traveled from around the world and coming from Singapore to be here. My name is Phil Hedayatnia. I'm the co-founder of a company called Airfoil. We're basically a combination of a product design, brand design, and design research firm that works with companies across the tech sector. But we've actually been dual-based in San Francisco and in Singapore for the last 5 years. So it's awesome to see you all here. Whether or not you know who we are, you may have interacted with some products you've worked on in the past. So, for example, if you're doing document processing with agents, you might be using Reducto. If you're embedding voice AIs into your application, maybe Vappy. If you're doing agentic search, maybe Exa. Is there? Oh, someone in the back is, okay. Or if you're here from crypto, maybe Solana. But I wanted to, basically, about a year ago, we built a team at Airfoil called Airfoil Labs, because there was a question in all of our minds. And the question was very, very simple. Will we have a job in 2 years? Because as a design firm, right, especially if you've been on Twitter and seen the talk about the design tax and the way in which increasingly improving models will enable us to just build things without the need for a designer, we were honestly a little scared. We wanted to know where our place really was in the design process. So we started building. We made things internally like Check, which is our own engine to effectively QA the implementation of our design. So we can take a Figma file on one side, we can take a live staging site on the other, use image models to then compare the two together and make sure that we've implemented them properly. Eventually, this turned into something kind of cool, which was self-improving websites. So because we're able to stack rank and prioritize based on severity, we're able to then feed that directly back into a code model and then constantly make sites better even after we've released the first dev version. We built something called Scoop, which is effectively it just takes all the information that a client gives us and turns it into a really comprehensive brief. Takes 2 or 3 pages of context we get and turns that into 50 or more. But it importantly gives designers more context on the industries they're designing for, the customers and users they're designing for, so that they can do better work. But after all of that, we started to put our heads together around what's effectively the holy grail, the thing that everyone's trying to solve. How can we create design agents that actually have taste, that are able to produce things that don't just look like slop? And so today I want to present a little bit of what we've learned. Here it is. Okay, not that at all. That's actually a screenshot from impeccable.style, which is something that you can download. We didn't make it, but it helps your agents have better design fluency. The way that it works is it basically tells agents a bunch of things not to do, right? Make sure that your color contrast is appropriate or use better typography. And that does make a meaningful difference. You can see without impeccable.style and with impeccable.style. That site looks a lot better. But it still kind of looks like slop. It looks like something that you were able to just generate directly. So why is that? Why does that continue to happen? Well, our view is that training AI on what we consider good design doesn't teach AI how we got there, and it misses a very important point. Design isn't about taking product specs to Figmabox. Design is about applied psychology. It's about understanding how the user thinks, how the user acts, and crafting the flows, visuals, and narratives that will resonate with them. I like to say that designers are investigators of human psychology. This is a mood board that my co-founder put together for a merch project that we're working on. And it actually seems kind of random at first. If you look up in the top left corner, you'll see a photo of California Street in San Francisco, and it's unclear what that has to do with merch. But what it really means is it's a way for us to categorize the things that we derive meaning from. These images may seem random at first, but they express meaning to someone. And when designers put together these mood boards, that's what they're trying to understand. They're trying to investigate why people resonate with certain things, come up with rules for how to do that, and then apply that to their own work. And there's another way to look at this. It's just human creativity. There's a book called The Runaway Species by Anthony Brand and David Eagleman. And Tony Brand actually is a professor at Rice University where I went. I studied under him. He was one of the biggest inspirations for me and one of the reasons I got into design. And what The Runaway Species articulates is a definition of human creativity, which is the bending, breaking, and blending of existing concepts to create things novel relative to the culture in which they're introduced. Put simply, it's not that people are born with creativity, that they have an innate characteristic to be creative. We all are creative every day. It's a simple part of how our brains work, but it's not just a neuroscientific definition, it's a sociological definition. We see this in things like biomimicry. The reason that the Shinkansen doesn't cause a sonic boom as it exits the tunnel and through a mountain is because they modeled the Shinkansen not just off of other trains, but off of the bill of the kingfisher. That was the insight they derived from nature and applied to a totally different context. And even in something like a website, like say the Reducto site that we worked on, we wanted to make it feel friendlier and more accessible to people, so we introduced page elements that brought back the elements of dot matrix printers. You can see an actual example over here. It's little decisions like that that make all the difference to making interfaces and brands look great and makes the difference between stuff that looks like slop and stuff that looks in it and really creative. But my key point is that none of that can be extracted from outcomes. You can train on outcomes and you'll eventually get overall better visuals that don't make clear mistakes, but you won't get visuals that are novel, interesting, and new. When we train models on ideal design outcomes without the context and thinking behind them, that's when we get underwhelming results. So we decided to take a stab at how to solve this problem. And I'm going to show this to you for the first time. We've not demoed this before. This is something that's currently internal to us, but we hope to bring it to the public soon. I want to give you a first look today at something we built called Meld. So Meld starts where a lot of our designers do, which is design Twitter. But this is the case for a lot of designers, right? They're always going out into the world, they're finding inspiration, they're looking at an interesting brand direction, and now they can just save it to Meld. They can click the Save to Meld button, and then we save it away to what we call their backpack. Or let's say they were on a trip to Vietnam, and they went to a restaurant called Pizza 4Ps, and they're like, this is a pizza restaurant, but it's really beautiful brand direction. And it is, great illustration, like their menus are even gorgeous. They can just take that thing that they saw, they can save it directly to Meld, and then we start to extract key metadata from that. Things like typography, color use, but also background information on the company itself and where you were when you took it. Once we have all that metadata together, we're able, and that's what the desktop one looks like, we're able to put that in your backpack, and you can access all of that information later. So why would you want to have all of that information? Well, the first reason as a designer is you want to use it the way you would use a notebook. By annotating on the samples that you save, you're able to record your thinking at the time, which means that in 6 months' time, if you need to come back to any of that, you can do so immediately. But it also means we can start to make connections between the metadata we're collecting and how it impacts how people think about it, how it impacts their perception. So this means that I can ask more complex queries. For example, I can say, find visuals from Vietnam 2026 with serif typography and blue, yellow, or black and white color palettes. The second half of that, you might be able to just do directly with an image model, but the combined query gets easier to do once we have all of that in there. And so you can see it says find 3 saves in Vietnam 2026, and it's able to understand in a bit deeper of a way what it's actually referencing. And of course, you can one-click export to Figma. That's the thing every designer wants. Where it gets more interesting is that once Meld understands your reasoning for why you've saved things, it can surface that to other people, and it can give you the ability to share in a more multiplayer way. So on Meld, you can make general queries that then are able to use the comments and annotations other people have left to better understand the content you want to find. So it's a much more effective content finding engine. So if I say something like assemble a mood board with light and airy UI, it's able to find references, not just that I saved, but that my teammates also saved, with context about why they saved it, which is really, really important. Coming back to that definition of creativity again, our view is that by enhancing recall and putting things in front of people faster, but also making sure to save that creative process, to save the feedback, the back and forth, the comments that make work resonate with people, understanding it in a deeper way, that's what enables us to then take the next step, which is actually try to infuse quote-unquote taste, or rather the intention of the human designer into the work that these models actually produce. So this isn't part of the product yet. It's something we built called Blend, but it's able to use both the visual references in Meld that you've saved, as well as the metadata and comments to remix different things together. We're now building tools that enable us to render entire mock-ups of pages just using the influences in Meld coupled with custom prompts and commands. And though it's still a bit rough and we've got some more work to do on it, it is yielding way better results for us than just using Claude or GPT directly. Dieter Rams once said that you cannot understand good design if you don't understand people, because design is made for people. I think the problem with design agents today is that we're spending a lot of time looking at what people make and not looking at why they make it. But by bringing all of that onto a platform and making it legible to LLMs, I believe that'll unlock the next generation of design agents that are able to act more intelligently, to follow our intent, and even to make decisions on their own. We want to start with augmenting the creative process. Eventually, that enables us to teach machines to create. Eventually, that enables us to teach machines to decide. That unlocks the world of generative UI and all of the amazing futures we want to build. So we're going to be sharing a lot more in public soon on Meld and everything else that we do at Airfoil. You can scan the QR on screen to learn a little bit more about us or stay in touch. And Min and I will both be around the conference today and tomorrow. Thanks so much, everybody.
And now I would like to invite up to the stage Annie Luo, Senior UX Researcher at Google.
Hi everyone, I'm Annie. I'm UX researcher at Google working on AI shopping. We've heard a lot about coding agents and ways to get AI to do more, faster, with less friction. And I want to talk about the other side, a class of problems where efficiency isn't a goal, and we actually need to keep some of the friction in for these everyday consumer AI products. So let's take a moment to think about this question, one that you might ask in front of a mirror. How do I look in this jacket? Underneath, though, you might actually be asking about, does this reflect the person I want to be? Does this make me feel like, because the fur jacket might be a little bit out of my daily range, am I brave enough to wear this, or does it make me feel like I'm trying too hard? So these aren't prompts or search queries. These are the kind of questions that people quietly ask themselves when making a purchase decision. So the first wave of AI worked by removing a lot of these frictions. For tasks like summarizing a doc or booking the cheapest flights, these are the utility tasks where the success metrics is pretty obvious. You get the task done quickly. And as AI is now being asked to help with a different class of problems where the question's a lot more subjective, like how do I look in this jacket? What kind of trip do I want? These are subjective questions, and the right answer depends on the person, the moment, and even the mood. And efficiency alone can't really tell if the feature is actually helpful anymore. And so how do we design for this? When AI moves into helping people with these everyday decisions that are really personal and subjective, three things change. People don't actually know what they want until they've seen a range of versions in contrast, and that's how people build trust. And as AI becomes a thinking partner for a lot of these decisions that are a lot more personal, a different kind of trust has to be earned. If you think about meeting a stylist for the first time, trust is built through the small talks that you guys had up front, or the stylist commenting on something that you wear that day, instead of upfront giving you a range of recommendations for things that you like. You wouldn't trust that the stylists actually know what you want. And so it's really important because you trust them because they have signaled in small ways through those little interactions that they understand your vibe. And different from utility tasks, where confidence for personal decisions comes from the feeling like you have made the call. And all of these aren't straightforward deliverables. These are things that AI has to help you build in the process. And so in the next few slides, I'd love to use two domains to show how that looks like in fashion and travel. First, this is Vercel Try-On. It's a Google Shopping AI feature that I've been working on for visualizing how clothes would look on you, powered by a custom image generation model for fashion. We launched it last year in the US, and in APAC, it's currently available for users in Australia, Indonesia, and India. And here's how it works. You're looking at a denim jacket, and you upload a full body photo of yourself. So I pick one of me in Central Park in New York, and then the AI can render the jacket on you in your context, rather than you having to imagine how that would look on you browsing a feed of products. And notice that the question AI helps with is not just figuring out, is this like a nice jacket? It's actually helping you visualize, do I look good in this, for a vibe check? And you can also see yourself in different jackets. Maybe I want to try a white one. And that's how you gradually build taste, by seeing a range and compare. You don't really know you prefer the white one a lot more until you actually see this being right next to the blue one. And as you explore further, you might start to recognize patterns about yourself or find something that really surprises you. Maybe the brown one actually looks really good. And AI that really builds for supporting subjective decisions aren't really deciding for you, but they're giving you a surface to discover your own taste. And in this case, let's say I'm not really interested in any of these. I feel like I'm not a fan, but in the utility frame, it feels like nothing happened here because the user didn't buy. But subjectively, they got something super valuable because they sharpened their taste. I also learned something about myself. I don't really look in that purple dress, which is equally valuable. In our next example, let's take a look at travel as well. Like, where should I travel next? Again, the real questions underneath are subjective. Do I want to be challenged or just chill out and relaxed? Or in this trip, do I want to be a museum person or do I want to be a beach person? A booking agent won't be able to help you answer that, and people plan trips partly to figure that out. And in Google Travel, we treat maps as a place to wander, not just a destination picker. And this is a reference point for the kind of interface that supports exploration, not just jumping to book me a ski trip for efficiency. And maybe you wonder, should I be a ski person this winter? And you wanted to explore Aspen or Whistler. And both are great skiing destinations in the US. Or maybe skiing doesn't feel right, and now you're considering a totally different kind of trip. And so maybe you wanted to explore like the Yellowstone National Park or Yosemite, and now you're considering something totally different, and a chatbot might have committed you to skiing 5 prompts ago, but a map interface lets you change your mind and explore with you. And that's the key difference. So what both products have in common is this. They're not trying to give you the answers fast. They're trying to give you a better place to think. And that's why it's really important to design for the deciding, not just the decision, because taste, trust, and confidence, these are built through the process, not just being handed over for you at the end. And so that also means we have to measure a different set of things. For metrics like task completion, time to results, conversion, these are great for utility tasks. But for a different class of problems that are a lot more subjectives, the ones that truly matters are harder to count. For things like, did users feel more confident? Did they learn something about myself? Or did they return to explore more? These are the things that really count. And practically, there are 3 kinds of optimizations where efficiency could cause explorations. And those are the moments where it's really important for us to put the friction back. And so for everyday consumer products where AI is supporting people with personal subjective decisions, it's really important for us to support comparison, not just giving one suggestion right away. Otherwise, we miss that meaningful moments to help people build trust. It's also really important to understand the intent, not just give them the quick results, because we have to earn a different kinds of trust and build in moments where people can express their intent or visual preferences, and also show that AI gets your taste and gets the style that you want, instead of assuming the intent right away. And lastly, invite active selections, not just automatically giving the best choice, because the act of choosing is the point of a lot of these exploration journeys that really make the journey fun, delightful, that's about self-discovery as well. And these are the frictions that are worth keeping. Thank you. I love jamming on consumer products, and I also write about this kind of thing at Substack. Happy to chat more after.
All right, thank you so much, everybody. That was the conclusion of our first part of our morning session. So we're going to be taking a 15-minute break in the theater right now. But during this time, we also wanted to create some experience for all of us to take a moment and, take a rest from thinking and just relax a little bit. So that's why I'm very excited to welcome Keziah, a trained mindfulness teacher, to the stage. She actually built a sensory meditation experience, including a vibe-coded particle visualizer trained on hours of her own guided meditation transcripts.
your morning break. Hopefully the talks have been great so far. We're going to keep these moving with our next talk from Jimmy Lai, who's the head of Next.js at Vercel, who will be talking about shipping what's next. Jimmy, the stage is yours.
Hello? How's it sound? Cool? Right. Hi, I'm Jimmy, and I lead the Next.js and React team at Vercel. So since we're at an AI conference, I'm kind of curious just, how much people are familiar with like Next.js and Vercel in general. Okay, it's not terrible then. For those who don't know what it is, it's like a web framework that people use to build like websites in general. It's not the topic of the talk, so we should be fine. But here's a fun number. When I joined Next.js 4 years ago, we were doing about like 4 million downloads per week. And today, we're basically up 42 million. Obviously, a huge part of that is thanks to the incredible work that my team is doing. But in reality, I think a huge part of that is because of like coding agents. And as such, I think that has changed a lot about like how we think about building tooling for developers. Because we spend a lot of time obsessing about how people will build websites in the future. And in the past 6 months, it has caught up to us faster than we ever expected. And this year, we spent a lot of time talking about like, how can we account for like this new type of like user? How do we stay ahead of the curve as a team? And like, do we still have a job in the future? And we're somewhat okay, because I think maybe what we had to go through and realize is that like the job was never just about executing the tasks. It's about deciding which tasks should even exist and whether or not we want to own the result of it. So yeah, in reality, AI just has made like executing and building much faster. But turns out you still have the same amount of time in your day. So in reality, it just makes ownership more expensive because you still need to account for like what you put out there, and you still need to like deal with like any issues that come with it. So today I want to share a few of those lessons with you because I think they apply to everyone in the room, whether or not you're building with an agent, for an agent, or whether or not you're building your own agent. My prediction is what we're learning about how agents use Next.js will only grow more useful as agents become more widespread, as you start to use them for like anything else besides coding. Maybe it's just about like doing your online shopping for you, as we already kind of see happen with like OpenAI. So I want to talk about three things, like just what's changed for us as we started building for agents, how agents also changed how we worked as a team, and where I think the industry is going to go, and especially why open source matters more than ever now. So the weird thing about maintaining a framework in 2026 is that you're no longer designing for the person at the keyboard. You're designing for whatever is sitting between them and the code. So it used to be an editor, the docs pages, but now it's like an agent that has access to your whole computer, maybe it has too much permissions, and that can be like a little bit dangerous and pricey too. So fun fact, like 60% of the Next.js docs today are served as Markdown, which means it's like not only coding agents, but it's also like lab indexing, etc. But it just means that like we're not having much like manual clicks to the docs anymore. I mean, if you think about it, when was the last time you consulted docs yourself? It's always a bit faster. There's less friction now than just asking like Claude, like how does this thing work in Next.js? And so we're moving to a world where software is kind of becoming the primary user of software. And I feel like that changes a lot. If you think about it, an agent is kind of an annoying kind of user. It reads exactly what you wrote, copies the example, it runs commands, it follows the errors to the letter, really. And so if the loop is broken, if your errors are not good, it's just not gonna, like sort of stop, get some coffee, go to bed, and like wake up at 5 a.m. with the fix in their head. They're just gonna keep trying and burning money up until they get it fixed. And so that has been really useful for us to understand because it indicates where the human is still like required in the loop and what we should try to optimize out. So for example, documentation used to be like somewhat of a very passive thing. We used to put it out there and we'd assume that like no one would, like people would read it once in a while and like sort of like build that knowledge over time. And you know, I always prided myself on like, having great docs for like the Next.js site, but the return on investment was never really there. We'd do it once in a while, like we'd look at them and like say, oh, we're missing this feature. But nowadays, like documentation has become like, you know, a bit of a Bible for agents. They'll take whatever you wrote in there and just act on it immediately. And it's not only applicable, you know, to sort of like frameworks and like DevTools offer. It's like anything that's in your code base, like your READMEs, your PR descriptions, your playbooks. Every stale document that's in your code base, it's kind of like a time bomb, right? It's like a hallucination waiting to happen. And the most dangerous ones that I've seen are like not the missing ones, right? Like, because if the agent has access to the code, it can still figure it out. It's like when the doc is like slightly misleading. What we've seen in practice is a stale example used to confuse, you know, one person at a time, and now basically confuses like hundreds of thousands of projects before anyone really notices it. And worse for us, it's when the bad information gets into the data sets, it means that the model is now potentially tainted. That definitely has happened for some Next.js features. And the same story for compiler errors. We have sort of like an error, I think in Next, that says like, this is a bug in Next.js, please open an issue. And this is kind of like a crime in this age, because I've never seen to this day like an agent like open a bug report on Next.js. Like as tool offers, it's really important for us that we kind of ensure that the user loop always stays, you know, as fast as unburdened as possible. In general, this applies to like any types of like tools that you build, like, you know, like your banking websites that requires like 10 steps before you're able to like send a payment or something. But it's just that like agents have made this much more important for us. Yeah, it's also a great way of like, agents are like a nice way of like testing out whether or not you're designing properly. Because when you're coming up with like something new, an agent will basically have like, you know, they don't have like Stack Overflow, they don't have like Twitter lore to understand what something is. And so if your API is like poorly designed, poorly named, then you're kind of in for a bit of trouble, right? And one key part that I've learned that I think you should also apply in your work is that like any system should be as explicit as possible. When you're doing an action, you should really be thorough about like the way you can explain it. Like those like, you know, 500 like status code that don't say anything, you should be able to still debug it, because we're kind of heading toward a world where, you know, as like sort of Thibault was saying earlier about Codex, is that like agents are just going to run passively for everyone. And so you want to enable your own systems to run and be fixed passively. You want them to be able to understand, like, you know, if your prerogative is that like all of your websites should be fast, you should be able to like define those. And today we have like some metrics here and there, but maybe you have a different definitions. And so you should work into your code base what that means. What does it mean to be reliable? What does it mean to be fast? What does it mean to be secure? So that in turn, you're well set up for when the agents are able to like kind of run autonomously and ship the fixes themselves. So yeah, that's kind of the first shift, like how basically building for agents doesn't like replace the fundamentals, it just makes them like, you know, even more important. I wanted to share about how we leverage agents ourselves internally, right? Like, I'm sure like you're all familiar, like in the past 6 months, I think the industry has gotten like a little bit of like a AI psychosis phase where like everyone was trying to build everything in the entire world. I've certainly done so a lot thanks to Opus during Christmas. And once we got past there, I think like the realization was that the real work is, you know, the tastes and the judgments. And I think it's better to think of agents as like being able to help you for everything around it. As an engineer, what's most valuable is my focus time. Like, I'm sure you've heard about this study that says, you know, if you're like disturbed for a little bit, it takes like it takes you like 30 minutes on average to get back to like a flow state. And in a world where it's, you know, extremely tempting to have like 10 agents running in the background, 10 chats open at the same time. Like, how do you make sense of that? How do you stay productive in that world? Because agents are still pretty powerful. They allow you to research very quickly, can turn like a messy investigation into like, a really nice documentation spec. But my key advice here, learned from my own hard experience, is actually force yourself to stop chatting with them. You kind of want to put in the work now so that you can avoid having to like oversteer an agent. Like, and it's kind of hard because I like having like 10 chats going on at the same time. It gives me like a little bit of like dopamine all the time. But think about a world where instead of like, bottlenecking yourself with like 10 agents, you can, by putting the work now, putting like the correct prompts in place and the correct like evals and like safeguards, this is kind of how you scale yourself to like having 100 of like agents running in the background. Yeah, because that's just what's going to happen for us as an industry. So that's the version of like AI that I'm very excited about, right? But there's also another part to it where like the industry does not only reward judgment, right? It also rewards like motion, and AI creates a lot of that. So I want to talk about honestly, that's probably the most important thing, is like knowing when not to use AI. Someone said to me in the past 6 months that the last 6 months have felt like the most exhausting 5 years of their life. And that sounds kind of about right. Every week there's like a new model, a new demo, a new feature that comes out. And my natural reflex, and I'm sure you've felt this as well, is that like, well, you should basically do the same thing. You should like generate more code, you should ship like more features so that you can beat out the competitors, so that you can stay ahead of the curve. But in reality, and we know this from like, having like built like developer toolings for like the past 10 years, is that what's going to happen is that you're just like speed running tech debt. Every demos that you have shipped, in the past 6 months, maybe you've felt it now. Now you actually have to deal with it, and with that comes a lot of like other problems like observability, pricing, making sure that like everything stays like really reliable. And for example, like you can fork Next.js over a weekend with like a bunch of like tokens, but just because you can doesn't mean that you should. Because when you fork a framework, for example, you start owning everything that comes with it. And like maybe the biggest recent example of that is security issues. Last year, I ended up like leading the response to like React to Shell, which was a very critical issue and like a very critical vulnerability. And this is kind of what I think this is kind of like the extreme of like ownership. Is like we said, we released Next.js to the world like a few years ago. We keep releasing it, and all of a sudden, we still had to fix it for like the 100 thousands of like users that we have. And this is where I would caution you to, if you think that like you can like fully replace, abstract away some place of your stack, think about like how are people going to deal with it in a year's time when you've created your own like meta framework to serve your websites? Do you actually want to take care of this? Or maybe it's better to use like open source and make sure that like you're giving back to the community and potentially like helping other people have like more secure websites. A note, by the way, on security, right, is we're kind of living in like unprecedented times in terms of like vulnerabilities being disclosed every month or so, right? Because AI has made it insanely easier. And it looks like you're not using like secure software, but it's actually the reverse. It means the system is working. If you're getting like security patches, it means that like somebody reported it. The other alternative here is that you're building your own version of like your framework or your tooling, but they don't get like the attention of like security researchers. And so now attackers will just like identify that you're running your own stack, and they will like basically attack you without you knowing. And this is where open source really matters, because we get to sort of like build on like stable foundations together. So at Vercel, we kind of have a saying, which is like you can just ship things. And this was pretty great. Like we built like an insane amount of like really good products out of this. But since the start of the year, we've also started taking like the other approach too, which is the fact that like you can also use AI to just delete things. Because before, like shipping was, it just meant winning. Like you just, could have like features in your roadmap. And now that's like, it has become so cheap. I think what's going to put you ahead of the conversation and the competition is focus. Because you're going to have to deal with it, your users are going to have to deal with it. I would actually rather slow down, take time to reflect on like what makes your product different. Because if you can build like a feature in like an hour with a few tokens, your competitors can do the same too. And what I'm saying is not about like not shipping at all, right? It's more about like how you protect yourself from like, and how you protect your ability to keep shipping. The question is not, can we build this anymore? Because the answer is like always yes. The harder question, and the one that like actually decides whether or not something is worth doing, is like, should this exist, and are we actually willing to own it like long term? It's funny, when I was working at Meta, we had a thing called like the not invented here syndrome, where people would just actually rebuild like every libraries possible on the planet. There used to be like, people are pretty familiar with like React Native, for example, for serving web mobile apps with React. Funnily, there's like 3 versions of this internally at Meta, just because people did not want to control this. And that was already a problem back then. It's becoming more and more of a problem now for like everyone. And again, when you think about like spinning up your own, like your own product that like replaces like something in your stack, think about the mental burden that is going to come with it. As a quick recap, I guess like my predictions, right, is like if you're building with an agent, like what's really important is that you think about what's not on the happy path. Like, can your users actually fully use your tools without like prompting themselves? Like make sure that like your docs, your errors, your CLIs are well defined. If you're building with agents, be really careful about like outsourcing judgment there. You can use them to get context closer to the judgment. Like you can do the research, you can investigate repros, the specs, like investigate like performance issues. But really focus on like what you bring to the table and make sure that you make time for this. And also as the industry speeds up, be careful about what you decide to own. Again, like AI made creation like really cheap, but ownership is much more expensive than you think it is. Does not mean that you should ship less, but it just means that we have to ship, as an industry with like more focus. Build what should exist, like try to make it understandable, make it reliable, make it safe, and stand on the foundations that you can trust. Thank you.
Thank you so much, Jimmy. Our next speaker is Vedran Jukic, who's the co-founder and CTO of Daytona. He will be speaking about why sandboxes are non-negotiable for autonomous AI agents. So without further ado, we're going to hear from Vedran.
Hello, everyone. It's great to see you all here. My name is Vedran Jukic, and I'm the CTO and co-founder at Daytona. And Singapore is our #1 city by users worldwide, and top 5 country, so thank you for that. And today I'm going to talk about why you should run your autonomous agents inside sandboxed environments. So when you install Cloud Code, Codex, OpenCode, or any agent that uses tools, you give it a lot. It runs as you. It can read your files, it can use your SSH keys, it can spend your AWS bill, it can delete things. And it decides what to do based on text that it reads from the internet. So we said yes to this because the productivity is real. But most of us never thought about risks. So why would the agent do things that it is not supposed to do? Well, because it can get compromised easily. Prompt injection is when someone hides instructions in text that agent reads. And there are 2 kinds. Direct, when the attacker types the bad prompt, and indirect, when the bad prompt is hidden in something that the agent reads. It can be a web page, a written file, or an email. And indirect are the dangerous ones, because the autonomous agent reads the internet. It's its job. Fortunately, models are getting better at spotting these, but they don't actually catch them reliably. And remember that attacker needs to succeed only once. So OWASP says it plainly. The prompt injection cannot be fully prevented. It's how the models work. OpenAI said the same thing in December. So the people who are building the models are actually telling you they cannot stop this. It's not a bug, it's how the technology works. And we also use skills, right? So a skill is a folder with some instructions and maybe some code in it. And you download it, you give it to your agent, and your agent will run it with all your permissions, with your shell, with your tokens, with your files. And remember, there is no App Store review for skills. So there's no sandbox between the skill and your machine. The agent will read instructions from the skill and will do what they say. If you look at the numbers, they're not looking good. 3 different teams have looked at this in early 2026. And COI Security checked OpenClaw, the skill marketplace for the cloud agent. They found 341 bad skill. And by February, that number grew to over 800 bad skills. Sneaked checked another set, and they found 13% of skills that had serious problems, and with 76 were clearly malicious. Also, a research paper titled Malicious Skills in the Wild checked 98,000 skills across different marketplaces, and they found 157 of them are bad. Now, let's see an example of a real malicious skill from that research. And it looks like a normal documentation helper, but there's a hidden comment in the markdown, right? And if you preview the file, you don't see it, but the agent does. And the comment tells the agent to send your project files to an attacker's server, right? So, and the funny thing, the last line in the comment says, like, do not mention this to the user. Some skills ship real code, and this one looks like a normal telemetry function. But if you look, it collects some data, and it sends it to an analytics endpoint. But if you look closer, what it's really interested in are your API keys, your secrets, your tokens, and it will walk through your environment variables, it will pick out the credentials and will ship them out. So to get compromised, you don't actually need to install anything. The agent can read any README file, an issue, or an email, even a PDF, and any of them can contain malicious instructions. So instead of trying to prevent this, we should accept that this is a reality. The model cannot be fixed, and OWASP and OpenAI said so. A new skill ecosystem is already full of bad stuff, and new malicious skills are appearing at a rate that no one can really review them. So any README file, any ticket, any email the agent reads can hold malicious instructions. So what can we do? We can change what the agent has access to. So no host shell, no host files, no credentials, and we can restrict the internet. And also we can throw it all away when the task ends. Sandbox is not just a virtual machine or a container. The agent inside still has your access token, it still has open internet. A real sandbox does 4 things. 1, it keeps your secrets outside of the agent so that agent never sees them. 2, it controls what the agent can access on the internet or inside your local infrastructure. 3, it logs everything, every command and every request. And 4, it sits between the agent and the AI model. So you can see what the agent has asked and what the model responded. A real sandbox has the network restricted. Every outbound request goes through a proxy that checks every request against the allow list. And a request to a random endpoint will get rejected. Also, everything is logged. So if something goes wrong, you can clearly see it in the logs. The agent should never see your secrets. The secrets should live outside the sandbox. So when the agent makes a request, for example, to GitHub, it sends the token placeholder value instead of the real token. And the proxy will catch that on the way out and will get the real value from the secrets broker, and it will send it to GitHub. The response will come back through the proxy to the sandbox. So the agent will get what it asked for, but without ever knowing the token. And if the agent gets compromised, there's no token to leak, because the token was never exposed to the agent. And finally, the model is the brain to the agent. If you can't see what goes in and what goes out, you have no audit trail. So every sandbox routes its model calls through the same gateway, and every prompt and every response gets logged in the gateway. So when, for example, sandbox A starts behaving strangely, you don't have to guess what's going on. You can just open trace for sandbox A, and you can clearly see what the agent asked and how the model responded. So the reality is that the agent will get compromised. The only question is what it can reach when it does. So you can try to build your perfect agent, or you can put it in a sandbox and sleep well. So choose wisely. Thank you.
Thank you, Vedran. Next up, we have Vaishant Kameswaran, who's the co-founder of GovTech, along with Rohan, who's also from GovTech. They're going to be talking about what they have learned from analyzing 5 million vibe-coded PRs. So once they're set up and ready to go, we'll have both of them talk about that.
All right.
Hello, everyone. I'm Vaishant, co-founder and CTO of GovTech.
And hi, I'm Rohan. I'm a researcher at GovTech.
And today we're going to be talking about what we learned from analyzing 5 million vibe-coded PRs. So at GovTech, we're building AI agents that review and test pull requests. We're reviewing 4 billion lines of code every month for companies like NVIDIA, Coinbase, and Meta. And there are 100,000 bugs that are identified by GovTech and fixed every single day. AI agents have evolved a lot over the last few years. In 2023, we were still working with quite simple agents that are able to generate short code snippets for us. In 2024, we started to see the rise of agents that are able to make small multi-file changes. And since 2025, we've entered a new age of fully agentic coding. AI agents are now able to create, to go directly from spec to PR. But this leads us to wonder, are these fully vibe-coded PRs actually any good? How are they being adopted by industry? And in what ways are they succeeding or failing?
So we have over 5 million PRs in our database, so we're well equipped to answer this problem. And the first thing we need to figure out is how you know if a PR is vibe-coded. And so we rely on 3 key signals to figure this out. The first is the GitHub author field. So often bots will just add themselves as co-authors to your commit, and this is a very surefire way to tell whether the bot vibe-coded the PR. That being said, it's a pretty sparse signal. Only about 1% of PRs in our database were able to be identified this way. And so obviously, many more than 1% of PRs are vibe-coded. We needed a stronger signal. And for that, we moved to looking at the PR descriptions themselves. Often, bots will add notes in the PR description saying that they contributed to the PR. And that's another helpful tell that the bots vibe-coded the PR. This was a much more frequent signal. About 20% of PRs in our database were able to be identified this way. And lastly, if you've used Codex or Cursor recently, you'll know that any branches that they create will have their names in the prefix of the branch. And so this is a very easy tell as well, because humans are unlikely to make branches with these names. And so putting these 3 signals together, we found that about 27.6% of PRs that were written in April had strong evidence of being fully vibe-coded. And that's a very interesting number, but it's even more interesting if you look at the history of this number since the beginning of multi-file agent systems. As you can see, it's been going up rapidly, and we expect it to continue to go up rapidly. Fully agentic software engineering is the future, after all. And so if this really is our future, it begs the question, are these PRs any good? Do we expect to see a significant degradation in the quality of code because of this reliance on agentic systems? Or are they actually better at writing code than human beings, and we're too scared to admit it?
So in order to answer this question, we first have to ask ourselves, what does it even mean for a PR to be good? And we tried to quantify this in a few different ways. The first metric that we looked at was the revert rate of these PRs. Typically, when a PR is reverted, it means that it caused breaking changes in production or caused issues downstream. So we looked at the breakdown of revert rates by author, and we found that some agents were actually able to have their PRs reverted at lower rates than the human baseline, namely Claude and Codex. We then also broke this down by the size of the PR, as measured by the number of files that were changed. Interestingly, we found that AI agents, on average, had their PRs reverted at lower rates than humans, the larger the PRs got.
Another very interesting signal of the quality of a PR is in the GovTech comments that it receives. So as Vaishant mentioned, at GovTech, we review pull requests. And in the process of reviewing those pull requests, GovTech leaves comments on your code, like a human would. Now, GovTech also rates those comments on a scale of P0 to P2, where P0 is a critical code-breaking change, and P2 is a nit. Now, you can imagine that if a PR receives many P0s, or many critical bugs, then that is a lower quality PR than one that receives only a few nits or no comments at all from GovTech. And so to look at this as a metric, we broke down the severity of bugs produced by each bot and looked at that compared to a human baseline. As you can see, each bot, or rather the majority of bots, produced fewer critical bugs than humans on average. And this is interesting. It means that, on average, if you're hoping to avoid code-breaking changes, things that will take down production, bots are actually more reliable. That being said, if you look at the entire distribution of severities, only some bots were able to avoid bugs of all severities compared to the human baseline. So again, it's unclear whether, on aggregate, bots are better or worse than humans at writing code.
The third metric we looked at is how many rounds of review it took for these PRs to get merged. Here we defined a review round as essentially the bot opening a PR, a human leaving feedback in the form of comments on that PR, and then the bot going back and making changes to address those concerns. This helps us understand two different things. One is how good the bots are at writing good code the first time through, and the second is how well they're able to incorporate feedback and make changes without introducing new bugs. We once again broke this down by bot author, and we found that a few bots were actually able to get their PRs merged, on average, more quickly than humans. Namely, Devin and Claude, we found, were the best on this metric.
So far, we've looked at a couple different metrics for whether bots are better or worse at writing code than humans, and we've seen that there's no real conclusion. Some bots are better at writing code than humans based on some metrics, but they lose on other metrics. The winner is kind of unstable. It depends on what you're measuring. And so perhaps the right question to ask is not, are agents in aggregate better at writing code than humans? But perhaps the question to ask is, how do bots produce bugs? Do they look different than human beings, and in what ways? And so to investigate this question further, we looked at the breakdown of different bugs that each bot makes compared to a human baseline. So namely, if you compare the rate of bugs to the humans, red over here means that the bots make more of that type of bug compared to humans, and blue means that they make less. And the intensity of the color corresponds to the magnitude of that change. Now, as you can see, the kinds of bugs that each bot makes varies widely depending on the bot. So for example, cursor background agents are much more likely to make n+1 query errors, whereas Claude agents are much more likely to make missing tenant check errors. There is no one clear bot that necessarily wins across every single metric, and the shape of each bot looks different. Now, what we've learned here is that bots make different kinds of bugs than humans. Not necessarily better or worse by all the metrics that we looked at before, but different. And so one thing that we haven't talked about yet is that bots just allow you to ship code much faster. So if the quality is roughly the same, albeit differently shaped, and the magnitude is greater, then I guess we can say that AI code agents are actually good. They allow you to write much more code, except that you have to be mindful of the kinds of bugs that they make.
AI agents are writing more code than ever. And as Rohan mentioned, the shapes of bugs that they create is different from humans. It's clear that as AI coding scales into the future, your code validation systems need to adapt and scale as well for the AI agentic future. At GovTech, we're helping thousands of companies manage their ever-increasing scale of AI code using AI code review. We spend a lot of time understanding the strengths and weaknesses of the individual models so that we can use them in tandem to help catch more bugs and create better quality code for everyone. If you're interested in learning more about what GovTech does, check out our website at govtech.com. And if you're interested in chatting with us some more about what the future of AI coding and AI code review might look like, please come find us at our booth, and we'd be happy to chat some more. Thank you so much.
Thank you so much. Next up, we have Yuntong Zhang, who's a research consultant with Sonar. Yuntong will be talking about AI agents in your code quality pipeline, shipping, securing, and measuring them. Yuntong, the stage is yours.
Right. Good morning, everyone. I'm Yuntong. So I'm a research consultant from Sonar, and I'm also a final year PhD student at NUS. So today I'll be talking about AI agents in your code quality pipeline. Specifically, I'll talk about how do you secure them, and also how do you review the changes made by these coding agents. Opinions here are my own, does not reflect any of Sonar and NUS, for the standard disclaimer. So here is a very high-level diagram. So if we think about how the code are being made and being merged into repositories, these are roughly the very high-level 3 steps. So the agents will write code, and almost always now, agents will review the code because there are just too much of them. And then human may decide whether to merge them in or not. So today I'm going to talk about 2 aspects within this pipeline. First is when agents are writing code, how do we build an agent in Sonar called Sonar Remediation Agent, which fixes SonarQube issues. And then I will talk about how do we evaluate code reviews generated by agents in a more reliable fashion. So here's the first part. It's the SonarQube Remediation Agent. So basically, the workflow is that SonarQube, which many of you know, is a very widely used static analyzer to scan your code. So SonarQube will find all your issues in your PR, and then you can invoke SonarQube Remediation Agent to automatically generate a patch for you. So this agent will open a new PR on top of your existing one, and then suggest changes to improve it. So the screenshot on the right shows what this agent will look like. So you open this PR, tells you about which issues in SonarQube it has fixed, and then give you these patches hunk by hunk, and tells you an explanation of why this patch is fixing this issue. So we have released this in open beta, and we have received a lot of feedback from customers. So the one thing I want to talk about more today is how do we secure these agents when we put them into production. So because these agents work on a lot of enterprise code, we want to make sure that there's really no security issues when we deploy and run these agents. So we have heard about sandboxing the agents. That is very important. We use it when we deploy this. But what I want to say is that we also want to build security in depth. That means we build layer security. After we deploy sandbox, we also build in security within the agent and after the agent ships the code. So here are a few things that we have done within the agent. So one thing is that we are building a very constrained workflow for this agent because we know that it's going to work on a very concrete scenario, which is fixing these SonarQube issues. So there's no free terminal, meaning that your agent cannot just randomly access the internet and execute arbitrary commands. And also, we consider code base as an attack surface, not just MCPs and skills, but the code base. So imagine if someone, open source contributor is open a PR in your repo, and then this person turns out to be malicious. So they can actually inject malicious commands in the PR that they send to your repository. So that's one thing we considered. So when we actually run this agent, we'll replace all of these commands into some other identifier, and then swap back these commands after the agent is done. And also, we want to deal with these supply chain attacks. So this is for the scenario where if I'm a malicious actor and I'm slob squatting and random repo in pip, and I want to avoid agent from importing those kind of repositories. So we build a lot of import guards to make sure that the agent does not import these malicious libraries. So that's what happens inside the agent. And here is how we verify the agent's patch after it's done. So when agent generates a patch, we run SonarQube Analyzer again on this agent generated patch. And then if we find regression or we find any security issues, the agent is tasked to retry with feedback from the previous iteration. And then it's only sent to developers when the quality gate passes. So that was the first part I want to talk about. So now we want to switch gears to how do we evaluate these code reviews. So this is becoming the real bottleneck now because agents are making a lot of PRs to your repositories. And then it's just impossible for humans to review all of these PRs. So a natural way is to use AI review tools to help you review the PR. But there are so many of them, and how do we know which one are better at your specific use case, and how do we reliably evaluate them? So this is a question we want to research on. So here are what existing methods do. So if we consider a scenario where we have some historical PRs, humans have made some comments on them, and then we run these AI review tools, and we want to see whether AI review tools are catching the same error as human did. So of course, if they catch more similar errors, they're better. So here are a few metrics of what people previously did. One is that we can check text similarity. We can see whether the AI review tools in natural language are generating similar tokens in semantics compared to humans. But as you know, even if we point into the same issue, this issue can be worded in very different ways. So this token similarity sometimes does not work. And also, we can also consider localization. This means that taking a PR, we compare each line at the location where these bots and also the humans are making comments. And we say that the bots are good if they're making the same comments at the same locations as humans. But again, this does not tell you the semantics. That's only the location. Also, easy way you can take LLM as a judge. You can ask the language model whether these two comments are the same. So it works sometimes, but it's hard to tell whether they are really reliable or not. The gap here is that we want somewhat deterministic way of checking whether a real comment is good. This is what we did. So we built a new benchmark called CCRAP. So it also works in a similar scenario, meaning that we want to check whether AI-generated reviews are catching similar issues as humans. But the core idea is that instead of using language model component, we are turning every human review into one executable test. So here is a concrete example. Taking this PR line on the left, if this is what someone changed the code base, and the human reviewer will say that, okay, this may raise a malform inputs like this, so instead of safely returning false. So this is the concrete improvement to code that human reviewer has suggested. So correspond to this, we will generate a test on the right. So this test basically corresponds to this review command, meaning that if this review command is addressed, this test will pass. Otherwise, this test will fail. So now for all these PRs, we don't have human reviews anymore. We have all these executable tests. Now the second part is how do we actually evaluate AI reviewers based on these inputs? So we show the AI review tools the PR, ask it to make comments, and then we take another coding agents to improve the code based on these comments. Now we have a different version of code which is improved according to the AI-based comments. Then we run this executable test to check whether this updated version code is good and how many of these tests are passed. So in this way, we can tell how many of the human comments the AI reviews tools have catched. Here is the results we have gotten. So the concrete numbers for each tool is not that important because these review tools are getting better and these language models are getting better every day. And these numbers are obtained in the early of 2026. So the part I want to highlight is this number on the right. So if we consider all of these review tools together, they addressed 41.5% of what human reviewers have pointed out. So this actually means the current review tools does not capture even half of what human reviewers has pointed out in the past. But this is not the full story. So other than this number, we actually look into all these AI-generated comments and see the quality of them because they can also point out to other errors that humans did not identify, but they are still valuable. So we further look into all these review comments generated by humans and AIs and put a categorization around them. So this categorization is beyond bug fixes. So we basically put them around security, efficiency, compatibility, robustness, and so on, all the way to about documentation and the maintainability of the code. So, and this diagram shows how each review tool is doing compared to human reviews. So we can see that AI is actually doing very well on robustness and testing. So they will suggest you to test more code. They will point out edge cases in your code and ask you to add them. So this aligns with my personal experience as well. So AI is very good at pointing out things that I didn't notice before. But then on the other hand, human reviews are very good at maintainability and design compared to AI. So they'll talk about how this code is not maintainable anymore if you add so much changes. You should organize code in a different way. Because human reviewers has more contextual knowledge about the code base compared to AI reviews. So the takeaway here is that for now, we still should use AI and human reviews together. Probably AI reviews should use as the first layer. And then human reviews can look at these specific categories that AI reviewers were not so good at. Yeah, so that's all I want to talk about. So I talked about how do we build agents where we focus more on control and safety, and also how AI and humans should work together for code review tasks for now. probably in the future, we can have AI tools which are trained, focus more on these aspects that they are missing right now. But for now, I think this should be a solution that we build layered review on our code base. So these two are the QR codes to our paper. So we have a research paper on each of these topics. Feel free to read if you're interested, and happy to chat after.
Thank you so much. Next up, we have Singapore's very own Eugene Cheah from Featherless, who will be talking about how open source models are here now and it's time for Singapore to build.
Apologies for the technical difficulty. To me, when AGI is actually truly solved, right, these things will be resolved, and so is printers. Like, it should never happen. All right. Hey, I'm Eugene. I'm going to talk about open source models and why they're here and why Singapore should just build. Due to the limited time span, I may slightly lean into Singlish, I might slightly go fast, and I'm just going to kick it off with a live demo. And for this live demo, I'm just going to very quickly do a simple web game. But what is more interesting here is I'm not going to use the best frontier models. I'm not even going to use the best open source model. I'm going to use the Qwen 27B and the Gamma 431B that can run on your laptop. So I have the prompt here. I'm just going to quickly get that running and get that running. And I hope my internet didn't disconnect on me. OK, so as you can see, I'm using Client, which is one of the open source coding agents that is integrated in VS Code. You can use anything. That's not the point of this demo. The point is really just to show that these are models that you can use today to actually just build stuff. So trying to wait for this one to, OK, finally. Plan finish, plan finish, I didn't even check it. OK, so these are models, right? More importantly, that you can run on your laptop. So this is an example of LM Studio with the Gamma 31B that is running on this laptop itself. You can run it on a mid-end laptop. You don't even need the highest end. And this is the same Qwen 27B, except that it's probably faster if I run it in the cloud, so I'll leave that one running in the cloud. Yeah, so a little bit about my background. I'm Eugene. I'm an AI model creator, one of less than a few hundred teams worldwide that have created AI models from scratch. And significantly, in Southeast Asia, there's only really a handful of us. Founder and CEO of Featherless AI, recently did our Series A at 120 million valuation, led by Airbus Ventures and AMD Ventures. I also co-lead the RWKV open source project, the first AI model under the Linux Foundation, and I'm born and raised in Singapore and a repeat startup founders. And I've worked in startup, enterprise software, banks, open source space for over a decade. I fly pretty much every month between the East and the West regularly. What is Featherless AI? We are a platform that provides instant access to the entire collection of open source models. Today is 30,000 models. In the future, we want to support all 2 million models, or even 3 million at that point. Our principle is that we shouldn't be the judge to decide for you what models you want to use. You should be able to decide for yourself. And so this is something that we are scaling to provide access, instant access to everyone. And you can access us through Hugging Face and Open Router. What makes this also interesting is that when you let the users have the choice of the model, the entire collection of model, well, it's still in the early stage of 30,000 and we're scaling that up, you get to observe what models that people actually use when they're given that choice. So that's pretty much the background for the talk. Like, what do people use open models for? Because at the end of the day, right, it's really about like getting those insights that I find more interesting, respectively. So to answer that question, I'll split it up into two major segments. The first one is which open model classes are being used. This is typically what people find exciting when they are first entering the open source AI landscape, because they'll be like, should I use the Quen or the DeepSeek and things like that? But this is probably one of the hardest metrics for me to present, because every time I do the slides, it gets outdated, like the next week. This was December, when most of our traffic was dominated by DeepSeek for consumers, and for enterprise customers, it was dominated by the Mistral Nemo Chalby. I think this is a very interesting pattern because consumers like to instantly test the latest and the greatest and experiment, where enterprises like to run things at scale, and so they focus on efficiency. But soon after, it got replaced, and then, like, just a few days ago, like, Gamma started exploding off the charts, and this is literally the updated chart that I had to update for the talk itself. Oops. Oh, okay, it ran, finished, okay. And so this is a shout out to Ivan and the Google DeepMind team. They did an awesome work with the Gamma 31B. And so what are these models then used for? Oops, live demo issues, but never mind. Like, increasingly, we all heard about OpenClaw agentic use cases. That represents a huge bulk of our traffic. The other major one is AI companion, therapy, and roleplay. That actually rivals the agentic claw usage, but the agentic claw usage will be a lot less users running a lot of agents, while the AI companion space will be usually commercial clients where a company will have thousands of users. Coding use cases, these are based on the metadata that we have, like Klein and Claude Code and things like that. We can see these kind of use cases, and subsequently, like 5% use ChatGPT-like. Oops. Once again, because we do not persist any prompt on the completion data, we infer this number approximately. So what is interesting beyond that, right, is down here I'm representing by model classes. But when you represent it by fine-tuned models, be it you may have heard RL of fine-tunings to specialize the models for your individual use case or company use case, you can see the difference in the chart, respectively. What I find most interesting is not the top 1/3 or half, which is usually all the popular models, but the bottom half. Because if this inference market is going to be a $1 trillion market, this is where the things gets interesting. And this is where we see AI models be fine-tuned to support specific region. Like, we are proudly one of the providers for the Sunbird AI, one of Uganda's first language model, or the Denu AI model, which is an agricultural language model. We also see use cases for medical, for Open Hands, which is also trained in Singapore, and also like for security, like Cisco Foundation model, respectively. So what I find exciting about these trends is that, more importantly, open models are crossing the current Sonnet and Mini line and operating Opus. The level of intelligence in the laptop is accelerating, and long context cost is dropping. I'm a bit pressed for time, so I'm going to move faster. This is basically open models matching Sonnet and approaching Opus for the Z AI model. They're still slightly behind, but it's almost there. But this is the more interesting one. The two models that I was running already surpassed GPT-4 in coding use cases. Sure, they may not be GPT-5, but mind you, they run on the laptop. Basically, the best models you see today would possibly be running on your laptop next year. That's the pattern that has been repeating in the open source space. And that is why, I'm going to skip this part. That's why, right, like, this is an important thing that I want to stress to all the AI engineers here. Because let's just see the live demo. Ooh, okay. Okay, so this is one of the asteroids. Let me see, this would be the Gamma 31B. But let's just try opening for the Quen 27B, for example. And you can see this is also another one. The fact that this works on potentially running a laptop, right, is the significant thing. Because right now, today, all these models that run on your laptop can do UIs, APIs, or anything else. And sure, it may require a few retries, but if we want to make Singapore the AI hub of the world or Southeast Asia, the problem is not the models, it's us. We just need to start building. And that's what I want everyone in Singapore to start doing. Just build, because there is no barrier. Yeah, that's all. Thank you.
Thank you so much. Thank you so much, Eugene. Next up, we have Max Buckley, who's the head of knowledge research from Exa AI. Max will be talking about, well, his talk title is November 24th, 2025. What comes next? Max, over to you.
Hello, everyone. I'm Max from Exa. I'm the head of knowledge research, and I'm also in charge of the Zurich office, which we're currently setting up. This is more of an existential talk, so I won't really be talking about Exa here. And this is not a typo, although it was asked many times, was it a typo? November 24th, 2025, what comes next? So what is November 24th, 2025? And that is the day Claude 4.5 Opus was released. And my position here is that that will go down in history as a day when things changed. So my proposal to you here is that the game theory underlying sort of society is changing, and Gen AI is driving this. And I'll give a historic example with ChatGPT a few years ago, and I'll give a more recent example with Opus. But basically, the institutions that we have were built on the assumptions that certain things are costly. And these costs make certain things work, right? But when we remove the costs, the systems built around them, they can fail to work, they can crumble. So one historic example of this was proof of work, right? We had a lot of systems that required people to make an effort in order to kind of prove they had made an effort. And by doing so, you would get people to learn in schools, you would find which people really wanted to apply to your company for jobs. You could also know if someone was credible. Nowadays, if I get a message, like an email or a LinkedIn message, and it's really well written, I don't think the person is really eloquent and really made an effort to talk to me. I think the person just used an LLM. Whereas previously, the opposite was true. Nowadays, if you get something with a typo, someone either got a model to generate typoed text or edited it intentionally to make it more typoed. And the reason I talk about this in game theory lens is that you can't opt out of this. Even if your university has come up with some claim like we don't allow Gen AI projects, that just means your students have to edit the delves out of it and remove the emphasis dashes. So you can't opt out of these changes. They're coming for you. And a similar shift is happening now in coding, right? So over the last sort of 8 years, we've gone from tab completion, where you complete a line, to completing a function, to being able to ask it to generate a file, to now where you have this coding agent where you can just give it this high-level prompt, and it will run away for minutes to hours and build the whole thing, test it, and verify it, and come back to you when it's done. And this is quite a shift, and something that hasn't fully been kind of played out yet. What's interesting is the models themselves aren't even aware of this shift. So if you use Claude, it will still use the time estimates that used to be true. So if you give Claude a big spec and say, here's a crazy idea, let's implement this research paper, Claude will tell you this project will take 12 weeks. You then copy the markdown into Claude code, and it whirs away for 30 minutes, and then it's done. Clearly it hasn't understood how much the world has changed. And I don't think this original estimate was wrong. Like, I've worked at Google with several very good engineers where you would assign this to like a junior engineer, and it would indeed take them 12 weeks. And that's 12 weeks of check-ins and iteration and making progress. Remember this concept of IT literacy? I mean, probably I'm preaching to the wrong audience here, but it used to be the case that many people were scared of computers or found them difficult or hard. And the reason for this was that computers were hyper-literal, right? If you missed a semicolon or had something like a typo, the computer would just say, that's not found, that doesn't work, you're out of luck. Whereas IT literacy was about helping people, normal people, get used to using a computer, like make them realize that, yes, you missed a semicolon, but don't worry, you can just put it in and it'll still work. No, an illegal operation is not actually a crime, don't worry. But again, one of the things that coding agents are driving, and I think coding agents, that term even undersells the potential, is a shift here, right? Because coding agents, or just having an agent running on your computer, makes computers have a kind of natural language interface. Like normal people now have this one hurdle, which is, how do I open the terminal? How do I launch Claude Code? And now they can use a computer in a way they never could before. They can talk to it in natural language. It can talk them through how they do whatever they want to do. How do they set up their printer on the network? How do they, take a screenshot? How do they debug if their camera is visible or not, right? And this is something they could not do before. And open source is next. And I say next, I mean, it's already happening. I mean, there are people in this room who have talked about some of these facets, right? But, open source used to mean open to engineers. Now it means open to anybody who has a computer and is literate, which is quite a bit more open. Of course, this comes with new problems, new challenges. So yeah, what used to be true? Like, these are the assumptions of the world pre-end of last year. So it used to be the case that software development was expensive. There were few people who could code. Those people were very skilled. Their time was very valuable. Basically, every feature had an opportunity cost. There were whole pieces of organizations designed to ensure we work on the right things for some definition of right. There was endless debates by managers, program managers, product managers, technical program managers, whatever you want to call them, about which projects should we do, which ones should we deprioritize. How much should we invest in fixing the bugs versus how much should we invest in adding new features? Similarly, software development was slow. So even a small feature would take a few hours, maybe days. A big feature could take weeks, could take months. A really big re-architecture of a system could take years for multiple people, right? And of course, one nice thing about this was that roadmaps kind of could align with this quite well, right? Because the roadmap could be quarterly because effectively the work was quarterly. I remember working in Google and we'd assign maybe someone 4, 5, 6 bullet points for their quarter. That was the 4, 5, 6 things they were going to work on and do that quarter. And usually they would do 70 to 80% of them. And so because of these two things, you wanted to prioritize ruthlessly. And there were, again, systems designed to do this, right? We'd have sales teams who were filing hundreds of issues, requests, features, ideas. And then you'd have program managers sifting those hundreds or thousands down to 30. Those 30 would go to engineering managers who would debate them and would draw a line and say, we'll do the top 16. And those 16 are fanned out to the engineers on the team. And so, as I say, the interesting thing here is that all of our processes and habits and org charts assume this to be true. So all of this is going to have to change as these things change. And yeah, so basically this whole thing is based on this economics of scarcity, right? That every line of code was very valuable, so we should prioritize things a certain way. Things like software as a service is a funny one. We've all heard about that it's in kind of danger now. And it's interesting because with a good set of engineers, you could build, in theory, like a Workday competitor or whatever other software as a service thing you wanted to. But the question is, did you want to? Were you willing to commit several people for several years and several $1 million to try to build a basic version and then get to the challenge of selling it and convincing people to switch? Now that's a lot easier to do. And this makes people realize that the moat is not the code anymore, but now it's going to be your brand, your go-to-market channels. I do think ML and data moats will hold longer because it's much less clear how exactly where the boundaries lie, right? So it's harder to kind of reverse engineer than something kind of deterministic. And this scarcity thinking also is going to have to go, right? So this idea of whittling 30 ideas down to 3 by professional judgment and then implementing 3, we don't need to do that anymore. We can now build all 30, do good evals, do benchmarking, see which ones were actually worthwhile, and we can revert the rest. And we won't be so attached to those that we revert because we didn't spend 3 months building it, and our promotion case doesn't rely on it. So yeah, the supply of software is going to explode. I mean, this is not an original thought. There's tweets from the COO of GitHub recently saying that as of the current run rate, GitHub commits are up 14x year on year. It's over 2025, which was already up 4x on 2024. So it's 14x at the current rate, and it's growing, so it's going to be even more. What's especially interesting here is that the marginal cost of a new tool is almost 0. So nowadays, if you're given a task, maybe you need to label some data or debug an issue, you can quickly throw together a new custom UI that you use for that task and never again. And this is crazy because this UI might take 20 minutes for a Claude to cook it, But it may make you like 10 times as effective at like labeling data or sifting through images or whatever else, right? Like, because as a human, you're good with visual data and you're not necessarily so good with text or whatever else. And now we can just build all these niche apps that no code are ever justified. So the bottleneck is going to shift to go-to-market and code review, because now that you can build everything, so can everyone else. So people are going to be competing even more to get people to use their ideas, to see their ideas, to hear their voice. And code review has already been talked about, so I won't dwell on that right now. But basically, code review is just, again, struggling because of the amount of code we're producing. And of course, AI can also help with this. So what I think is valuable now, what I would invest in, is statistics. So statistics was always very valuable. At big companies like Google, there was always some team, some people building statistical tooling for evaluating experiments, and then many engineers that would just rely on that tooling. They would just opt in. Now it's probably more useful as a more broadly distributed skill, because everyone can be evaluating all sorts of things in many different ways. And evaluating here could be different things. It could be profiling for performance. It could be benchmarks, A/B tests, user behavior metrics, these things. Ideation and taste is another important thing. So basically, the idea of what to build, having ideas, is going to become even more important. And then, of course, iterating on these ideas. And jagged is how, so my final point here is just that the specific value of knowledge, I think, will change. We're going to move from deep technical expertise, when you really detailed know the exact syntax of something, to knowing what exists, how and when to use it. Because with these models, if you prompt them kind of generically, they will kind of often give you a sort of generic response. Whereas when you prompt them with a sort of the right words, it kind of unlocks this strange potential. Like my final example is statistics. If you say, please benchmark my change, it will often do n = 1, run it once, run it twice, see which is faster. If you say use statistics, suddenly it starts spouting things like p-values and t-statistics and all of these other things and large sample sizes, and it goes crazy. Yeah, so that's that. Yeah, so basically the question is no longer can you build it? The question is what should exist? Thank you.
Thank you so much to Max from Exa AI. Next up, we have Mark Doyle, who is a software engineer with Stripe, as you may make your way over to the stage. And Mark will be sharing a little talk about Minions. Not quite Minions the movie, but Minions, which is Stripe's one-shot, end-to-end coding agent platform. He'll talk about how they're building it, why they're building it, what the reasons behind it, and some thinking behind how they think about coding agents.
Hi, everyone. Thanks so much for sticking around. I know it's nearly lunch, so hopefully we can keep this really interesting. I work at Stripe on our coding agent platform. My name is Mark. So roughly anything to do with writing code with agents and the whole software engineering lifecycle with coding agents I'm roughly involved in. Before we start talking about what we'll talk about today, which is one-shot coding agents, so going from a prompt straight to a PR in one shot, just to frame the problem a little bit at Stripe, that we process close to 2% of the world's GDP on Stripe. So even though we're trying to be on the really bleeding edge and the forefront of AI with using the models, we have really big obligations to our users and our customers and even the broader global economy to maintain a quality bar and a security bar. So that's definitely our number one thing we keep in mind while we're building all this. That said, though, we have 91% of Stripe engineers are writing code with AI on a daily basis. So 100% of Stripes are using AI in some form during the software authoring lifecycle, but every day we have 91% of our engineers merging code with AI. In the last year, we've seen a 500% increase in the number of fully AI-generated pull requests. So today, we're just going to talk a little bit about how we're making that happen and how one-shot agents are enabling that for us. One-shot coding agents are pretty well-known term in the industry, I guess, but something we use internally a lot is creating a PR for when you go from just straight from a prompt or a Slack thread all the way to the pull request, just without any interaction. So we in Stripe also have the harnesses, much like I'm sure all of you have, like Claude Code, Codex, Cursor. We use those as well, but we see those as kind of like a co-pilot harness. So that's when the engineer is sitting in tandem with the harness, working in an iterative manner. one-shot coding agents are specifically for when we think the engineer knows roughly what the pull request or what they're trying to achieve looks like. We don't need them to sit in tandem with the harness like for extended periods of time. So we think it's a little bit wasteful for engineers to be juggling like tons of different teamwork sessions, connecting to different agents on different boxes, when maybe they could have the planning session with the agent up front and then just kick off this one-shot experience and not have any involvement until they get to the code review phase. So yeah, our goal is to just like save our engineers time. We don't want them spending time like spinning up new development environments, creating branches, pull requests when they already know roughly what code they're going to write. We want to offload all that work to the agent, not just the actual writing of the code. So I'm just going to give you an example of me using one of our one-shot agents. So here I'm investigating a problem with one of our MCP tools with Stripe. It's just, this is like a very simple example just to show how we do it. We have these agents in Slack where we can say, hey, I'm seeing this issue, what might be the problem here? So straight away, the agent will come back, it'll read our code, read our documentation and say, oh look, this seems to be the issue you were looking for. It's just literally in this case a 3-line or 3-character diff. It's a very straightforward change. And right now, the developer in this scenario knows that this change is very simple. Like it can be implemented by roughly anyone. You probably wouldn't even need to be an engineer to make this change. So we don't want our engineers now to spend the next 10 minutes creating branches, spinning up an agent, explaining the problem again to an agent, copy and pasting this context. We just want them to literally be able to say, hey, go fix this issue. Once you've come back with the pull request, I can approve it or get my colleague to approve it and merge it. So DevBox in this situation is just analogous to Minion, which is what we call our one-shot agents. And the developer then can expect sometime later to see a response like this, where the Minion comes back and says, hey, our process is completed. Go check out what code I've written. So the developer didn't need to be in the loop for any of this. And that's a little bit about the philosophical side, I guess, of why we want to do this, why we think we're saving engineers time. Now I can explain how do we actually achieve this outcome. So we saw in this previous message when I instantiated the agent, we see this message. The agent said, hey, 1 second, I'm cooking, I'm working on your task. How do we go from that message to actually getting a pull request that the engineer can review? So Stripe is really lucky. We've been investing in dev boxes, which are our remote developer environments. So Stripe engineers don't write code on their laptops. They write it on remote developer environments. We could probably give a whole talk about why we need these. Stripe has a super large monorepo. It's one of the biggest Git repositories in the world. It's close to 300 million lines of code. So if you clone down our repository, it's 90 gigabytes. It takes a long time to generate our code. So we kind of need to have these remote developer environments. So every time you want a fresh branch or something, you can just get it straight away. We have a pool of them. They're ready to go. And we're really lucky we invested in these for years because it turns out now they're really good homes for agents. Agents can be really comfy there. They have all their tools. These are not lightweight sandboxes like what we see a lot of in the industry today. These are quite large developer machines. They're lots of cores, 64 to 128 gigabytes of RAM. Pretty big machines, pretty capable of for large-scale engineering tasks. And every Minion gets their own dev box. So they have their own home there where they can, one, from a security standpoint, are safely isolated, sandbox, etc. And then two, it's just a good environment for them to write code in. So once we've given the Minion some compute, the dev box, so a computer to run on, it needs a file system, it needs a shell. We've given it that with the dev box. The first thing we do to try help it operate in this giant code base is we hand the prompt or the Slack thread all the context we can gather. So say in the example I showed, it was a Slack thread where another agent had searched the code base, given some context. Maybe there could also have been a ticket mentioned, a pull request mentioned, some other context from a colleague. We gather all that information and we hand it to this analyzer agent you see here. That analyzer agent gathers all that context and says, okay, this is where I think we need to point the agent. This is the right part of the code base. And that's when we start the actual implementation phase. So once we've figured out where we're going to write the code, or approximately what the task look like, just summing the whole contents of the Slack thread or wherever we started the Minion from into a prompt, we can start this Minion loop. So the Minion loop is the process of making sure we always produce a pull request and the agent doesn't stop in the middle. And this is what the Minion loop looks like. So we start at this white arrow at the top, where we take that context I just explained, where everything from the Slack thread, and we give it to this coding agent you see in the white box. It's just a regular coding agent. It takes the, as as maybe Claude Code or Codex you're very used to using does, takes the prompt, conversational context, and tries to advance. It makes a turn, tries to advance towards a goal. After it's advanced towards that goal, we make it run lints, we make it run tests and type check, and then we stop. And we don't go back to the human. This is sort of the difference between one-shot agents and Copilot agents is here we pass the result to an LLM judge, which is this orange box you see at the bottom of the screen. And the LLM judge literally takes the prompt that the original author gave to the minion and the current git diff, or the output that's been produced, and we just ask it, is this task complete? So it doesn't get, its context doesn't get poisoned with all the information conversation, all the excuses that the coding agent might come up with for why it stopped working or why this task is impossible, etc. It's literally just a unbiased judge that says, is this task complete or has it failed? If the task is complete, great. We can create the pull request and go back to the engineer and say, hey, it's ready for your review. I'm finished here. If it's not complete, we have a diagnostic agent that looks at the output of the LLM judge, looks at what happened in the coding agent session and the original prompt, and says, oh, this isn't finished because some test failed, or this hasn't finished yet because you've actually implemented the wrong thing. You created an API endpoint, but you didn't wire up the front end. Obvious things coding agents will miss. And then we take that context from the diagnostic agent and put it back into the loop. So we run this loop as many times as we need. We try to keep the input from the diagnostic agent very short, so it doesn't bloat the context window. But we keep running this loop with the diagnostic agent, the LLM judge, and the coding agent. Just keep running it until we have something that resembles a pull request. It's not always going to be the case that the pull request is correct, but at the moment at Stripe we're merging roughly 65% of minion pull requests on one shot. So 65% of the time a Stripe engineer starts one of these, it's being merged without any human intervention. So it's getting pretty good as the models get better. We see this working more and more. Usually it's like the engineer will then want to, if it's not successfully one-shotted, the engineer will want to jump in and make some changes. So to that point, we have a web interface for, you can continue steering the conversation. You can also, you can see in the top of the screen here, open the box the minion was spawned in on VS Code or in a terminal. So that lets the engineer take over in the case that the minion failed to one-shot. So that's kind of the story of how we take this little coding agent, give it a place to live, and then produce these one-shot pull requests. We're merging 3,000 pull requests a week at Stripe with these. It's really valuable for saving our engineers time of solving the really small problems and even bigger tasks that the engineer already believes that the agent can one-shot, or the engineer can provide significant context upfront that lets the one-shot PR happen. So if you're building systems like this, there's probably a few lessons we can give you to take away. We learned that prompts are really good. So in all of our agents here, like the LLM judge, the actual coding agent itself, etc., we have very detailed prompts. As you can imagine, we have thousands of Claude and agents.md files around our code base. They're very valuable. However, if you're writing one of these loops, like a minion loop, and you're constantly making prompts that look something like, please run the test before you make a commit. Don't push and run an expensive CI run with, before you've run the test yourself. Or please format your commit messages in a certain way. You're writing in screaming case, all capitals. You're really trying to convince a coding agent to do something. In that case, we really think deterministic instructions are just far better for this. So anything you can make deterministic, please do it. It really helps the agent be successful. Trying to argue with agents for things is usually not a great, it's kind of like a code smell, especially if it involves security things. So yeah, deterministic instructions for writing these kind of loops is absolutely critical. And it just lets the process be so much more reliable. If you're building your own workflow, it may be fine to rely on these screaming case context files, but for doing this at scale, when you have thousands of developers running thousands of minion runs, this has been really useful for us. Our second takeaway is that developer tools are always super important. So at Stripe, we've always been really lucky that invested pretty heavily in developer tools for a company of our size. For example, Stripe open source Sorbet, which is a static analysis type checker for Ruby. It's analogous to TypeScript for JavaScript. Lots of tools like this Stripe has built to boost our development velocity over the years. But more so than ever, this is like so much higher leverage. So now we see that like these tools are like, you must have them. So if you don't have like good compute primitives for your agents to run on, like for us dev boxes, you don't have static type checking, linting, all these things we expect to have as professional developers, the better your tools are, the more you can do agentic development. So if you don't have these things, it's no longer like, oh, my engineers are losing an hour a week to it. It's you're losing like thousands of agent cycles that are failing or are taking much longer than they would have before. So now we're like doubling down even more than we had on building like even better linters, formatters, analysis, all these kind of non-LLM related things that are mostly static analysis. So that's been really valuable for us. The last takeaway we have is that building on Slack has been really valuable for us. So you saw earlier in my presentation, we have this like @devbox or @minion Slack message where we can kick off a minion. That's been super valuable for educating like all our engineers about using AI, and non-engineers as well can kick them off. So that process of sort of building in public and sharing with our engineers that, hey, it's, maybe you were about to go down the, you haven't been reading on Twitter the latest and greatest in AI, you maybe would have gone down the path of opening up your editor and manually making this change or using tab completion or something. Now all our engineers see other engineers working in public and just tagging these minions, being like, hey, go do this thing. That's been really helpful for like helping get our really large organization on board with using AI for lots of tasks. That's been, working in public within your companies has been super useful as well. Finally, we have a booth over in the rest of the conference, so if you'd like to come chat to me about minions or ask any questions, please do. Also, if you think working with minions or on this platform is interesting, Stripe is hiring /jobs. We're actually hiring an EM or engineering manager for my team specifically, so if this sounds really interesting, you should come work with us. I'd love to work with you. We also have a giveaway here if anyone's interested. You can come by our booth after and check it out. But thank you very much.
Thank you so much, Mark. Our last talk before lunch, I know everyone's very hungry, but lunch won't start till this talk ends. So I hope you guys give Hau the time for him to present. Hau, as you set up. Hau is a software engineer with a company called Similar, and he will be talking about from playing solitaire to operating ERP software, why does your computer need to learn to click and type? So Similar is building tools that are really good for computer use, and Hau will show you how that works. Hau, over to you.
Thank you. Thank you so much. So how many hours a day do you think you've moved your cursor around the screen? Anyone? 5? So if a few months ago, we did an experiment with a group of friends. Some of them are like you, right? AI engineers, builders, and we also have doctors, admins, and accountants. And track them, see how much time they spend on moving the cursor, right? And this is what we found out. 5 hours a day. We have someone who moved their fingers on the trackpad for more than like 5 hours a day. That's more than 1/3 of your time awake, right? Not creating, not thinking, but just moving, clicking around, navigating, right? Scrolling through tabs, through menus. So we've put a lot of our work into this digital space, but the way we interact with it is still incredibly manual. The PC, we have PC in 1981, right? Suddenly, we're able to do things that we used to take hours within minutes, right? It's a big leap. And we freed ourselves from filing cabinets and paperwork. But now, look at us, 40 years later. We're still clicking, scrolling, navigating around, right? 5 hours a day. We traded off like one kind of manual labor into another kind. So we need the next leap. So what would truly an efficient way of interacting with computers, right? What if you don't have to interact with the computers at all? What if the computers can operate on its own? it can see the screen, understand the task, and just do it. And that's what we are building here in Similar. We call it an autonomous computer. Right, so this is what keeps me exciting, and this is what we are building. So my name is Li Hao. I'm a member of technical staff at Similar. We are building the infrastructure for autonomous computers. Right, so last December, our research agent, Agent S3, has achieved surpassed human-level performance in OS World, which is the standard test for computer use. So what does an autonomous computer look like? Right, so let me show you. This is Sai. This is our product. So on the left, you can see that the screen, we have this chat interface where the LLM is trying to understand the task. It's trying to play a solitaire. So it's trying to look at the screen, understand what's going on, and try to see like what's the next best move, and trying to figure out how to move the mouse and drag the cards. Right? So on the right is the machine that's running on. And so hopefully, in a minute or so, if he gives them encouragement, hopefully Sai will play the first move. Yeah. So you can see that it's actually able to control the mouse cursor and drag the card right, from the left to right. But this is just one app, one task, very clear rules. Right? But imagine your actual work day. At work, what do you do? Right? You have emails, you have Slack, you have sorry, hold on. So at work, you have email, you have Slack, you have spreadsheets, you have your PowerPoints, you have your QuickBooks, SAPs, and some of the legacy systems that your company refuses to retire. Right? So some of these tools have APIs. Right? So this is where we had a lot of activities is going on last year, where we have API or CLI agents, we have tool calling, function calling. Great, this part has been solved. And some of these apps is in the browser. Right? So you heard talks about browser use agents, which can handle navigating and looking at your browsers for you. Great. But again, there's everything else that your desktop apps, your legacy systems, your proprietary tools, there's no API, there's no browsers. So the only way in is actually through the screen. Right? So that's computer use. So teaching an API to see the screen, understand what's on it, and operate it, just like you would. With that, the autonomous computers is complete. We have API and CLI agents, we have browser agents, and computer user agents working together, seamless to the users, and handle any task on the browser. So this is what we are building at Similar. And in building it, I'd like to share 3 main challenges that we have faced: reliability, trust, and scalability. So let's start with reliability. To a user, reliability means one thing, right? It works every time. 2 things have to be true for that. The agents need to see the screen and act on it precisely. So that's grounding. And it has to be able to do it across multiple turns. So across 100 repetitions, that's consistency. So you have grounding and consistency. Let's start with grounding. Right? How does a blind person see a screen? You use screen reader, right? So it reads the accessibility tree, structured map of every element, the name, the type, the state, and that's our starting point. But it's not enough. A lot of times, there's apps that don't have the complete tree. Sometimes buttons hidden inside menus, drop-downs. You have elements that show up dynamically, and some apps barely even have a tree at all. So we have to back it up with vision grounding. So we specialize models that can actually look at the screen visually and figure out where are the elements. Right? One can read the text, one can find buttons and elements. When the tree has gaps, the vision tries to fill it in. So we have accessibility tree combined with visual grounding. Now, grounding gets you precision on single action, but what about 1,000 times in a row? In research, there's a metric called pass at k, which means given the agent k attempts, how many times do you get to get it right? Right? As long as you get it right at least once. So if k is 5, and if it succeeds on the 3rd try, that's a pass. But that's not what user wants. User wants what I call pass to the power of k, right? You have to get it right every time, k times in a row, no mistakes. Say a user has 100 leads and wants to send each one a personalized LinkedIn message. If an LLM is driving all the action, every step, each attempt might go slightly differently on the same task, 100 times, 100 different behaviors. So we need a different paradigm. So what we use is neuro-symbolic approach. So neuro, the LLM observes the screen, reasons about what to do, and then so this is the thinking. And symbolic, instead of just clicking, it writes a program, code, that's the executing. Right? It's like the brain writes a recipe, the machines follows it. So here is where it gets powerful. The first time, it calls LLM inference, but doing it again for the second time, the 100th time, you just replay the code. You don't need LLM inference, no cost, and essentially free. So the language behind all this is Simulang, our domain-specific language for computer use. Readable, modifiable, and releasing it to the developers this week. So that's reliability. Let's talk about trust. An AI agent that can do anything on your computer, right? You can send emails, delete files, make purchase. That's really powerful, but it's also very dangerous. If it misunderstood one instruction or it hallucinates, it can become disastrous. So this already happened, not to a random user, to Meta's director of AI alignment. At Similar, trust is built into our architecture. The guardrail is a separate system from the planning agent. The one deciding what to do is not the same deciding whether it's safe. So you cannot be the same, you cannot allow the model to be the judge and player. So even if the planning model gets confused or hallucinates, the guardrail system catches it before dangerous happens. And the third challenge is scalability. Our mission at Similar is to scale users' productivity by 100x. And how do you get 100x? By having 100 fingers and type 100x faster? You need 100 autonomous computers. But not everyone wants to set up 100 Mac minis, buy it up and set it up for them, right? But everyone wants the productivity gain from having multiple autonomous computers. So at Similar, we're building infrastructure to solve this. When you sign up for Sai, this is our product. You get 100, we spin out a machine for you, right? And this is your machine. You can do anything you want. You can install your app. You can set it up the way you like it. And then you let Sai to take the wheel. So if you can spin up one, you can spin up 5. You can even spin up 100, right? You can have one doing a regression test. You can have another one do another something else, and you have the third one do your CRM updates after the call, and you can have last one running reports. You can have all of them running in parallel. So why am I in a loop? Yeah. So 100x productivity, not by working harder, but by having 100 computers work for you. Reliability, trust, and scalability. The three challenges, and that's what we are doing. Right? There's an incredible engineering behind all this. There's like a distributed systems, agent reliability at scale. So we are hiring. If you're interested, do join us. So the PC freed us from paper, and autonomous computers free us from human work. And we are Similar. I'll be around in the booth at level 4 across the street, and we'll see you around. Thank you.
Thank you, Li Hao. With that, we have come to the thing you guys have been most looking forward to, which is lunch break. There is buffet lunch in Hopscotch, Ka-En, and the Bistro, so you have multiple spots to get access to food. We are running ahead of time, so we will start the next talks at 1:30 sharp, starting with Ryo Lu from Cursor, who's the head of design. So you do not want to miss that talk and be back in time for that. Thank you so much for sticking around all day. See you soon.
announcement. Okay. Hi, everybody. Welcome back after the lunch break. Hope you guys got some food, got to chat with people, and come back with energy for the next bunch of talks we're going to be having here at the Capitol Theater. Now, I am super, super excited to bring the next speaker here. This is Ryo. He's the head of design at Cursor. But I'm going to share a little bit of a story because all of this started for me 2 years ago, middle of 2024, because I learned how to code as a complete non-engineer, actually using Cursor. And I don't know if you guys ever used the tool when it was just tab and inline before composer model, multi-file orchestration came out. That was what I was learning with. But there's so much thought that the Cursor team put into designing an experience. It's for people who are power users as well as people who are new to it, like me. And a lot of the design patterns have now become the ones that are kind of standardized and used across all different kind of coding agents. So I am super excited to bring Ryo to the stage. He's going to be giving a talk on designing the next Cursor.
Yo, hi. Hi, everyone. I'm Ryo. Let me wake up my computer first. Cool. Nice. Cool. Good afternoon, everyone. I'm Ryo. I lead design at Cursor. Today, I'll share how we're designing Cursor to bring designers, engineers back to our roots when making software felt more like play rather than being stuck in rigid roles, tools, or processes. I'll also share how our design process became more fluid as we designed Cursor with Cursor. I'll end with our vision for the future of making software. In the beginning, software design and engineering were the same thing. There were no splits. The people who imagined software also built it. Design and code were the same craft. The material was the code itself. Thinking and making happened in the same loop. This is Bill Atkinson. He was on the early Macintosh team. He built QuickDraw, a 2D graphics engine. He also designed and coded MacPaint and HyperCard. He invented the marching ant selection pattern and a lot of things that we still see in most graphic design apps. He built pixel-perfect UI in 68K assembly. Every detail from concepts to design to implementation was his. Was he a designer or a developer? This is Alan Kay. He invented Smalltalk and the Dynabook vision at Xerox PARC, basically designed the whole future of personal computing. He wrote the code that made it real. There's a famous quote from him: "The best way to predict the future is to invent it." He built working systems to prove his ideas. From UI to interaction models to the runtime, they were all one craft. Were they designers? Developers? They were all builders. The question did not make sense back then. Design was code, code was design, and the craft was whole. Then something really weird happened, especially in the last decade. We forked ourselves. We split into specialized roles. The designers owns the vision, makes the mocks. The engineers implements the mocks. The PMs write the specs, run meetings, keep everything moving. The promise was specialization will make us faster. But the reality is we got slower and more distance from the code. And our tools forked too. The engineers mostly stayed in the terminal and the IDEs. Vim, VS Code, Sublime, but the code is still the source of truth. The designers kind of moved to the cloud. We started in Photoshop, making bitmaps. Then we moved to Sketch, which is a Mac-only app that does vector mapping for like UI. And then we moved that to the browser and made it collaborative in Figma. The designers made beautiful mocks, but they weren't real. And then the PMs and the collaboration also kind of scattered. You have Jira tickets that nobody wants to update. You have Google Docs for specs. And then we made Notion for wikis and planning, Slack for everything else. And then there is this sassification of everything and purposefully built tools that actually created more divides. And the gap widened. Linear handoffs became the norm. Designer makes some designs in Figma. The PM writes a spec doc. The engineer gets a ticket. Matching Figma became the goal. But this back and forth in comments and meetings is really annoying. And we lost this tight iteration loop. It takes weeks between ideas to mocks to specs to tickets to code to review to staging to prod. It takes weeks from thoughts to reality. Designers can't touch the real thing, which is the code. Engineers can't explore without a ticket. And the material, the code, became someone else's job. We told ourselves this was progress, specialization, best practices, design systems, but we traded craft for process. We traded building for coordinating. We split what was supposed to be whole. Code is a universal language between humans and machines, and it is our material of trade. The code is the material again. The code is the source of truth. It is the real thing. It is not a mock. But now with agents writing the code, you can design by asking, directing, refining, and the craft becomes knowing what to build and how it should feel, using the real material and making it real with other humans and agents. Cursor could bring tools and builders together into this one thing again so that we can all make great software together. How do we get there? Enter Cursor 3. Cursor started by inheriting a lot of complexity from VS Code. As the agents became the primary way people write code using Cursor, all changed within the last year. This legacy kind of became a liability. For the agent-built coders, much of this file-centric view of things don't make sense anymore. And for the new coders, they still feel a lot of friction getting started, bombarded with all these scary UI and concepts that they don't know. We also see a shift from operating on this local file state to interact with the agents to moving towards multiple agents running on different projects, increasingly in the cloud. And this flips a file-centric view of the IDE to a new hierarchy centered around agents and their environments. In order for us to retrofit VS Code, changing layouts creates a lot of UI forks, edge cases, and broken states, and it just couldn't keep up with how fast the world is changing. So how do we move from this file-centric view of software to an agent-native interface that adapts to each human and what they do? There are, I think, two main philosophies to building AI tools, and the difference really matters. On one hand, you get a black box. You type in what you want, the AI does something where you can't really see. When it works, you didn't really learn anything. You just skip the thinking. When it fails, you don't really know why, especially as a new coder. You keep burning more tokens without understanding what's actually happening. You can't see, can't intervene, can't edit. You either approve every single change or give up. You are just a product of the model. On the other hand, you get Glass. It starts simple, but you can see more if you want to. Agents streaming in, code running in the background, AI thinks with you, your way. You can redirect mid-flight, stop anytime, steer your way, edit that 2-pixel padding if you want. You don't have to read every change, but you always can. The experienced coders can let agent flow, review at the right time, and make edits when needed. The new coders can learn new software concepts with Cursor. They can learn by just asking, building, tinkering, and then seeing a deeper slice of the system. You stay in control, build intuition, and shape Cursor into how you think. As AI gets more powerful, Glass matters more, not less. Autonomous agents running for hours need legibility for humans to monitor and interject. Multi-agent systems need inspectable, durable plans with clear boundaries defined by humans. We also need a shared space and malleable interfaces for humans and agents to think together. And we chose the glass way, bringing focused, legible, customizable interfaces to humans and agents. Every agent, their actions, artifacts are visible and editable. Plans you can shape, agent states you can inspect. There is zero hidden magic and infinite control, but it starts simple. You can use Cursor now with editors closed. No auto-opening files, no distractions. It kind of works as a sidekick next to the other tools and workflows that you do. But it reveals complexity as you use it, and you can see more when you want to. As you use Cursor for more projects, in different stages of making software, from planning to designing to execution to review, the interface morphs to fit you and let you focus on what you're good at. The experienced developers can roll fast with multiple agents, review changes, and make precise edits when needed. The designers can sketch things out, see the code running in the browser, annotate, and tweak every detail with immediate feedback. And the product people can think, plan, explore options, and trade-offs with the agents that knows about their whole team context in a fully interactive, collaborative document. Everything feels instantly familiar, yet powerful. Designed for the humans, not a model. We let you tinker and fit Cursor for you. The core stays simple, but you can customize through extensible concepts like plugins and skills, and there are virtual interfaces that adapt to what you do. We also respect user habits and control. We never force drastic changes. We are not taking anything away, but we can show people there's a simpler new way to do things for those who prefer. Now, let me share how we got here. What's crazy about all this is designing our new interface all happened within about a month, and it all started from a random prototype that we started exploring at the beginning of this year. So Lee, Rob, and I kicked off Baby Cursor 3 earlier this year. Baby Cursor is our name for our prototyping environment where people can fork, explore ideas, and share with others. When designing AI tools, you always end up with a lot of non-deterministic states and edge cases where static mockups can't capture the nuance. We really had to feel it. So the goal was to design Cursor so that it can scale from the most simple form into something sophisticated that the pro engineers and software makers will love. In the new version of this prototype, we made it so that it is a fully functional Electron app built on top of the Cursor CLI. I designed a simple layout architecture that could support one to multiple agents, one to multiple projects, 0 to n tabs of content, and splits, and it works with any space constraints. Things always start simple, but it grows with you as you use the tool more. Making these dynamic states in Figma, in mockups, will probably take months, and it won't give you the same feeling as playing it in real, in code. So much of this high-level information architecture and flows were pretty much done in a week. In traditional design tools, it is really easy to duplicate artboards and states and explore options. You always end up with a lot of snapshots of states rather than one cohesive thing to see. In Baby Cursor 3, we added a built-in feature flagging system, and we have settings stored as files. So this kind of allows us to explore both really large architectural forks and explore every single little detail and permutations. Then you can see how things fit together. By playing with the prototype daily and exploring options, we were able to reveal new constraints that affected deeper architectural decisions. One example is how does the layout change as you navigate across agents? Do the tabs on the right change as you navigate between them? Are they pegged to different agents? Are they per workspace or environment? Or are they all independent like VS Code? It is a really hard concept to explain in words, but it is very easy when you can feel it live. We then shipped Baby Cursor to everyone at the company to play and give feedback. The engineers started forking and adding their ideas and takes into the prototype. I then synthesized them back and did more iterations based on the feedback and new ideas from the team. We learned a lot by building the prototype. Which layouts made sense under real use in different conditions? What are the different defaults and customization options to expose? How do we make complexity feel simple? How much control should remain visible versus hidden? How much progressive disclosure should work, etc. And from the prototype, I reverse engineered the code into a high-level spec where we document every single option and details. The videos and the screenshots became the mocks for the new cursor. Then after 33 long discussion threads on the RFC, it's time to make it real. And engineering also took a more drastic approach, inspired by the speed of building this prototype. We basically decided to rewrite Cursor, the whole UI, from scratch, with a brand new design system, component library, and a clean foundation. As the engineers are working on this, I prototype more sidebar grouping, customization, input customization, peeking, and details. Then I went back to Figma for the first time so that I can play with liquid glass that we didn't end up shipping and all the visual details. Our engineering team cooked really hard on this for 2 months, rewriting the entire Cursor UI from scratch in React and building a new design system. Once the things are a little bit more cooked, we started using the new Cursor to build itself, and we dog food everything that still feels a little bit weird. The designers also went back to the code, so we're building out little details, polishing new components, icons, colors, theming, vibrancy, animations, all the little details that the models don't see. And the design process became really fluid. It is no longer linear. We just use the best tool to refine the craft, whether it is about spending more time to think, making these prototypes or mocks, or just go straight into the code. And in late March this year, we shipped the alpha, and we created this rapid feedback loop with both internal and real-world users, and we focus on performance, quality for our first ship. After we shipped Cursor 3, we built Baby Glass, which is our next generation prototyping environment where we can visualize Cursor from the very present to the future in one single prototype. It is rebuilt on top of our new design system, and it uses the real components from Cursor 3. We brought it back to the web, so it is no longer an Electron app because it is so easy to share states and links for others so they can click on the link and then give feedback. We also improved the feature flagging and versioning system so we can visualize Cursor from the current production state to each step that we need towards like a more future milestone. We also built better handoff flows so that these Baby Glass prototypes can turn into the first PR that an engineer can build on top of in the real code base. And it looks crazy good. It has a desktop, it has some wallpapers, themes, and we even built like a tool inside Baby Glass where you can generate mockups and videos. And we plan to use this for like actual demos in our website. So making Glass give us a lot of clarity into what we think the future of making software could become. It should be more collaborative so that the humans can work together on the same context and tools with teams of agents. As we use agents to accomplish larger goals, it becomes increasingly more important for the agents and the humans to share the same space so they can arrive at the right thing to build. And as everyone is becoming a builder, people from different disciplines, not just engineers, can finally come together and work on the same goals with the same agent setups, tools, knowledge, and artifacts. We think the future should be more customizable. Our interfaces and tools should adapt to who we are and what we do, not the other way around. Everyone and every team is different, while the underlying concepts and tools are the same, so that you can build, connect your workflows and tools, and customize your agents to the most granular level for yourself and your team. We think the future is more autonomous. More agents can tackle repeated workflows, streamlining and eliminating manual processes, while the humans define the system and boundaries. We can automate things like bug triaging, release notes, security and code reviews. And you can design your system with verification loops and really define what is right so that the agent can handle more things for you. And lastly, we should be building more ambitious things and think about what else we could do that is not making more things and adding more slop. We can build better, simpler software together. Instead of adding more things, you can actually use the time that you saved to think deeply and figure out what is the simplest abstractions, what is the right thing to build for your users. Do something crazy that wasn't possible together with other humans. The future belongs to people who build to think. Stop waiting, start building. No black boxes, stay glass. Thank you.
All right. Hello. Okay. Thank you so much, Ryo. And just so everybody knows, if you guys haven't checked it out yet, Cursor has a booth in the Atelier in Kempinski, so you can go ahead and meet some of the team there afterwards. All right. Thank you. Thank you. Woo. Yeah. All right. I would like to welcome to the stage the next speaker. This is Aosheng. He is a staff product designer at Figma. Welcome to the stage. Woo. So Aosheng currently works on Figma Weave and has been behind a lot of the very popular products on Figma, including Figma Buzz and FigJam. FigJam, of which is something that I personally love to use. And he's going to be giving a talk on designing multimodal, multiplayer AI. While he's getting set up, just a quick few announcements. Number one is tonight, we are actually going to turn this entire theater around from talks into a nightclub for the after party. Woo! Yeah. So if you just remember to bring your badge. That is actually how we're going to check you in. So if you're an attendee, you could just bring that. No worries about having the QR code from Luma. And then next thing is we have a demo stage in Pullman, which is kicking off now, actually. But if you want to stop by at some point to see some demos from some of the local startups on how they're embedding AI into their workflows or their products, check it out there. Right. Without further ado, Aosheng, woo!
All right. Hello, guys. Wow, this is like a lot more people than I thought. Okay. I'm Aosheng. I'm a product designer at Figma. And today I want to talk about why our AI tools should be multiplayer and multimodal. So the AI tools that we have today focus on really making individuals go 10x faster. But I feel like the harder but also more interesting question here is, can we make a group of people go 10x faster together? Because when execution gets cheap, collaboration and alignment becomes the bottleneck. This is actually from another AI engineer talk by Maggie Appleton, the research engineer at GitHub. And I wholeheartedly agree with her framing here, because deciding on what to build and what not to build is more important than ever right now. And a team's progress will be stalled if the way that we explore, plan, align doesn't change. So very relevant to also what Roy just shared earlier. And I just feel like the tools that we have today don't really make any of that easier necessarily. Most of the agentic tools today have a chat on the left, artifact on the right, but the chat is single axis, one thread, one direction, one source of truth. And it primes you to one shot, right? Because there's so little affordance in the interface that tells you how to branch out, compare ideas side by side, et cetera. And this is ultimately an interface for convergence, not divergence. I think when we design AI tools, we should build interfaces for divergence too, because the creative process is both solitary and social, and the best ideas get sharpened through friction between minds. So I think we should build tools that facilitate instead of removing that process and isolating us from each other. So yeah, here are some ideas on divergent interfaces for AI tools. A few years ago, I helped build this widget called Jambot, which it lives in FigJam and it allows you to explore ideas with ChatGPT in a way that's visual, nonlinear, and multiplayer. And this was back when LLM was like all about text, before you could like ship code from 0 to 1. And looking back, I see Canvas as this really fascinating, malleable medium where the additional dimension could make multiplayer presence and branching iterations feel much more natural. So the next part of this talk is going to be a little demo, and I'd love for you to join me if you have a laptop. Just type in this link and enter your name, and hopefully you're in. I know the Wi-Fi is a little bit spotty, and this demo is like purely coded via Claw, and I have no idea. Never tried asking this many people to join, and there's a lot more of you than I thought again. So wish us luck, but please try it out if you can. Hello, hello, hello. I'm gonna zoom out here, but it's the same URL as the one in the address bar. And once you join, you should be able to see the canvas with the slides plus a bunch of like mini games preloaded. So you can click to play like any of the games here. So I'm just gonna select this like Flappy Bird thing from the top. Oh guys, okay, I really hope it doesn't break. But okay, I lost already. Okay, this is really embarrassing. So if you hover on the node here, you should be able to see this prompt box where you can like add an element, change the aesthetic or tweak the mechanics, etc. And for example, my friend Annie yesterday suggested to add a monster buddy to my bird. And let's see how that goes. And while that is streaming, I would also wonder, what if I change the background to galaxy? Okay. And now I can see that the agent is basically taking my prompt, is rewriting the plan, and also rewriting the code. And I have this one at the top. Okay, it's falling down like way too fast, you know, but okay, all right. I'll see if you guys have made anything else. So I'm not sure what happened, but we'd hope that I'm not stuck in a vacuum here. But from here on, I should be able to continue iterating. There's a chance that this has like softly crashed for all of you, so I'm sorry. But I can like add a hat to the bird, and move on, etc. So now you can see that like we're kind of collaborating on this like most primitive version of executable code here. I'm also gonna refresh and just see if it's like my problem. Okay, it's like really messing itself up, so sorry about that. But I feel like the thing that fascinates me here is having this like simple but also kind of visual representation of version history that feels very inviting for iteration, right? And being able to see that collaboration happen in real time. And imagine if the real software prototyping could actually feel this collaborative too. And this notion itself feels very exciting to me. And now, by making the space multiplayer, I think it also introduces like edge cases we need to consider to enable better co-creation between multiple humans and agents. So today, most AI tools, we let agents act for us on a task that are meant to be automated, and that's okay, right? But in collaborative exploration, where we rely on both humans and agents as riffing partners, the space should feel permissive, right? Where we could touch each other's work and iterate on the same thing in real time. So for example, okay, this has really hard crash, so I have a local version prepared just in case. So let me try this again. Make the add a monster buddy to my bird. Okay. So as I was typing, you might be able to see that there was an option to also make edits, which would allow you to kind of override something, right? And this introduced possibilities of conflicting edits, for example. So if I do say right here that like, I want to like make the theme medieval, and I click make edits. And now imagine that if someone else is working on the same thing at the same time, right? So for example, if you're editing the visual style here, the 2 parallax layers, for example, and there's a chance that, like, again, somebody else may be touching the same artifact and like rewriting it, and this should be allowed, right? Just like in Google Docs or Figma, because the space is as permissive as possible to encourage co-creation. And here I'm seeing that I really hope that it streams, but if it doesn't, I'm doomed. But the original plan here is that you will be able to see the agent's cursor also making the changes alongside me. And because its output will replace my edits, right? And I think over here it should ask me whether or not it should actually rewrite it. And it should also show the streamed outputs. So I could compare and decide whether I want to allow it to rewrite it or not. And that would be just a bare minimum example, right, of, I'm just gonna use this. That'll just be like a bare minimum example, right? But I think it gets to show that to make AI multiplayer, you really have to design this embodied presence. So the representation here should set expectations on what it could do. And in the case, it would have been able to show me the document that it was editing, and it should be able to appear with its own text pointer. And it should also show its scope of changes visually. And it should also show how to handle conflicting edits with others, whether it's with humans or agents. I actually think that in many ways, similar to designing the embodied presence for humans today, I think it's very similar, whether you're designing a cursor in a document or canvases. So that was just a demo I'm making AI multiplayer. But to me, this is just the beginning. I think the next frontier is actually also making a multimodal, which is really about widening the channels of communication so that both humans and agents can express themselves in richer ways. And there are 3 directions I'm pretty excited about here. First, I think we should build genuinely multimodal models. A few days ago, this is from Thinking Machines Lab, I think they shared a research piece on what they call interaction models, which is natively multimodal and micro-turn-based so that it's always interactive in real time. And I love their framing that, like the turn-based AI is kind of like talking to your agent over email instead of in person. So this is pushing the boundary at the model level, and honestly, this is like way cooler than this talk, so you should totally check it out. And if you're a model builder, please make it happen. Second, I think we should build better embodied presence for agents as they move through the richer digital mediums, as I said earlier. Take something as simple as a cursor. There's a lot that you can express through position, movement, and interaction, like clicks. So this is a communication channel, and just like how we read each other's intent through body language, we should design body language for agents too. But even as of right now, right, there's a lot we could do with interaction modalities. So GUI already helps people communicate intent in richer and more intuitive ways, and we have decades of experience building them. So think about how we could engage inputs like multi-touch, pencil, and speech at once, and like this interface experiment by Ryo Lu. Or we should think about how much determinism you can build with the interface, right? Such as this example, which is Figma Weave, a node-based workflow tool that generates rich media. And full disclosure, I work on this tool, but this genre of node-based AI native tooling is exciting because it fuses models with the GUI patterns that we already know, and it provides the precision and control that they need for their creative exploration. And you could go very deep from here. So I hope that what I shared just now gives you inspirations on how your agents could interact with multiple collaborators, both peoples and agents, and what modalities that they can move through. So I'll definitely check out the space and see if the changes that you made eventually come in. Reach out to me on Twitter if you want to chat, and if any of this resonates with you, definitely do not miss this year's Config, which is Figma's design conference. There's a bunch of updates that might interest you too. So yeah, that's it. Thank you.
Thank you so much, Aosheng. I am excited to introduce our next speaker. This is Selim, a robotics engineer at Menlo Research. Come on over. For those who don't know, Menlo Research is behind Asimov. They are an open source humanoid robot that you can train and customize. And they're going to be the first folks to be talking in our physical AI track, which is really exciting because we wanted to introduce new discussions outside of just thinking about AI as large language models, but how do you actually allow it to understand and interact with the real physical world? So Selim will be talking about how his topic will be Noise is All You Need, Engineering Sim to Real for Open Source Humanoids.
No. Can you see the slides? Okay. There's a clicker.
Can I also go from here?
Yeah, you can control from here.
Okay. Hello, everyone. I'm Selim. I work at Menlo Research, which is a company incorporated in Singapore. And I want to explain a little bit about agentic robots and pretty much how to vibe code the real world. Menlo is actually a full stack team. We have 27 people that are across the world. We have an office in Singapore, which is at Sim Lim Square, which is actually a very nice place. We have an office in Vietnam, in Ho Chi Minh City, and we are going to open an office in San Francisco next month. Our team, basically 27 people, 25 of those are engineers. I'm Selim. I joined Menlo in 2025. I used to work at Tesla for 6 years as a software engineer in Palo Alto, California, and I came to Menlo basically to lead the robotics side. As you guys can see, we do full stack robotics from the hardware up, from the hardware up to the highest layer application. So I guess you guys already heard a little bit about Asimov. Asimov is basically an open source human robot. It's the only open source human robot in the world that actually went kind of viral. Like we didn't expect that much. It went viral in like multiple countries. In Germany, there is an article in Germany, in Japan. So we decided to basically create the DIY kit, basically like just a box where all the different parts of the humanoids are in, and then we have a manual online where you can build the robot at home. We put it out for pre-orders, and I think we got $1 million pre-orders within 2 days. People are very excited about the humanoid space, and especially as learning how to use humanoids, how to learn how they work and how they act. So a lot of people ask us, why are you guys building hardware? Hardware is hard. I guess not being in hardware is harder going forward. So Asimov is an open source reference humanoid design. So that means that anyone that can fork out the design can build a humanoid at home or in a manufacturing setting. So our goal is basically to create a distributed network of manufacturing partners worldwide that are creating Asimovs for people who want to buy them while we own the reference design. It's almost like Android, I guess, where Samsung and Huawei builds the hardware, and you basically own the open source reference design. And this is very interesting because when we put the DIY kit out for sale, actually we got 200 plus factories reaching out to us, want to build a robot. And they're all around the world, some in Turkey, some in Germany, in the US, of course. And even some in Nigeria. So there's all around the world where they can actually build Asimov, where we own the open source reference design. What Asimov also includes, what we also built internally, is like a robot processing unit. It's very important for us because it's basically one controller that can control the entire robot. The robot consists of 35 motors, 8 cameras, 2 microphones, 1 speaker, all connected to a single board sitting in the torso. And what this board is also useful is it can run a local model inside. And this is very important because Asimov, as you guys know, stands for Asimov laws. There are 3 laws of Asimov, which is pretty much don't hurt anyone, obey the commands, and protect yourself. And it's very hard to define safety that is universal, right? Like safety for people that live in the Middle East is different safety for people that live in Singapore is different. Like I'm Turkish and I'm German, I'm dual citizen, so like safety requirements for both my countries are different. So we decided to actually make safety as well, same as the manufacturing, we want to make it a distributed consensus of people that build Asimov, that develop an Asimov to decide what safety means. So it's almost like a consensus. Think about Bitcoin, think about all these other like blockchain technologies where people decide what is safe and basically create a functional safety model, computer vision model that can overtake the robot at any time when it tries to do something wrong that disregards the Asimov laws. And that's why it's very important to basically burn that into a device. So it's not running in the cloud, it's just locally in the device, the Git hash is burned in, the CRC, you can read everything out, and that is that one single board where the manufacturers have to use. Otherwise, they're not allowed to build Asimov. So a little bit about like how to vibe code the reality, right? Vibe coding is kind of interesting because, in the era of like OpenClaw where people can like basically automate their workflows, everyone feels like an AI engineer, right? Like, people can basically summarize an email every morning and then probably think they can apply it OpenAI just because like they have all this power, right? Just to vibe code things. And I think what we really want to do at Menlo, besides the hardware side, like on the software side, we want to basically turn every software developer into a robotics engineer, same as like OpenClaw and the rest turned everyone that is a software developer into an AI engineer pretty much, right? And how we do it is basically, we have a system design like in our software side, which is like an agent. The agent is basically something that you guys can bring in. It's not something that we provide. And this can run Claude, this can run Codex, this can connect to your like all the different external tools you have. And this is what we call the big brain, the slow thinking brain. And then we have skills and robot control, which runs inside in the robot. So skills basically mean how to perform a certain task, how to pick up a cup, how to do a handshake, how to walk. And the robot control basically is a real-time operating system, make sure that these commands are getting through, the robot doesn't fall down, it has some safety mechanisms inside. And just to give you, an example how like the cockpit that when the robot is autonomously running looks like. So basically what, when you want to load the box from A to B, right? First, the robot internally runs this perception and planning agent that can detect the different obstacles, can detect the different scenarios depending on what it sees. The second thing is actually you can train through simulation to have skills, almost like OpenClaw skills.md file, right? Where you can train skills, pick up a cup, move forward, locomote forward, run, jump. These are trained through different type of models, but almost like abstracted into skills. This is either a VLA that picks up things, this is a vault action model, or this can just be like inverse kinematics, right? And now you can plan and you have skills to execute. And the last step is basically you can just plug it into your agent. So now your agent basically, you're not sending a video and audio stream to your agent. You're just sending a text and skills, and a robot is almost just an MCP server performing those tasks. And what you can do as the next step pretty much, you can create a Kanban board where you can assign tickets to a fleet of robots that are running in your factory or running in your home. And the interesting part is those robot processing units I mentioned previously, you can connect those robot processing units to any type of robot. Some skills are actually transferable, some skills are not. So you can connect these robot processing units that run all the safety laws in any type of robot. And basically through our stack, you can connect them to almost like a fleet orchestrator, like a swarm intelligence. And then you can basically, control your entire environment. The robot is open source. The skills are trained by the community. The safety laws are trained by the community, and the robot is built by manufacturing partners. So I think that is kind of like the goal that Menlo is trying to achieve here at, around Singapore. And whoever is interested to join us, we actually open an office in Menlo Park, as our name said, right? Anyone that is interested can join us. And anyone interested in that is in Singapore can also hit up. We can talk. What kind of skill set is required? Robotics has no specific skill set. It's like a multi-dimensional problem. You need people with perception, electrical engineers, mechanical engineers, inference, optimization, GPU optimization. You need all of these people. And I hope with the entire community that we also have in the background that built SMO for us, we can achieve something great here out of Singapore as the first humanoid robotics company out here. Thank you, everyone.
Thank you, Selim. And now I'm excited to bring our second speaker within the physical AI track, Alberto, who is the founder of Reactor. Reactor recently came out of stealth. It's a startup that's focused on something called world models, which maybe some of you guys are familiar with, or some of you have heard some of it, maybe post NVIDIA's GTC. Welcome. But we're very excited to bring him here to talk about how you can actually create interactive simulation environments to help with the next wave of physical AI. So he'll be talking about world models, a look at the future.
Did it work? You have a video? No, it's just my presentation. Do you have any audio? No. No, I think I can do this, but I don't know if it's working. I'll choose content. You think it's working? Oh, there we go. Okay, cool. All right. Thank you, everybody. Very excited to be here. So today, I'm going to give you a glimpse into the world of world models, no pun intended. And so, first of all, I wanted to start the presentation by giving you actually a quick view of the state of world models today and what they're capable of, because I think sometimes people are not aware of what's possible already with world models, which is quite mind-blowing. And so, without further ado, this is a video, which is actually not a video. It is recorded in real time, generating on Reactor. And you can see that I am piloting this polar bear. Now, when I look at this video, I cannot quite distinguish if this is actually like a real video or like a video game. But what you're seeing here is actually something that was being generated in real time on the Reactor platform. And so this is to show you that today already, the quality of what you can generate with world models is very impressive. And all of this, when I recorded it, was running live at 30 frames per second. And I could control the experience just from the keyboard. And it would change all in real time, just starting from an image. So I just wanted to set the stage because it's important to know how already advanced these models are and what's possible today. And this is just an early glimpse. I'll show you more later during the presentation. I think it's really incredible that this is already possible. Just quickly about me, I am the CEO and co-founder of Reactor. We started Reactor with the goal of democratizing access to world models and for people to build with them. In the past, I co-founded Luma AI, where I was CTO and co-founder. And I also worked on the Vision Pro at Apple. So I've always loved the field of spatial, visual, 3D, and real time. And that's what eventually led me to think about, like, okay, what's really the next frontier in AI and in general in Gen AI? And it became obvious to me that that is world models and real-time video generation. And so it's important to think about what's been happening in the space of AI in the last, say, 5 years, especially visual AI. At the beginning, you know, we have today things that can generate text, audio, image, and video, but all of these modalities are passive. When you prompt for example, an image model, you eventually receive a file out, but for the duration of the generation, there is no interaction from the user. There's nothing that makes you interact with the model, and the model cannot handle external stimuli. So For example, if something happens in the world and you would have wanted the model to react, that's not possible because these models are really passive and not interactive. And so in the future, more and more AI workloads are going to be actually real-time, interactive, and fully aware of the world around them. And this is because you really need to have these models think about the world around them in order to deploy them in the real world. Otherwise, they're really unaware and they don't respond in real time to what happens around them. And so, in order to actually discuss, the rest of what Reactor does, I thought it was important to talk about what a world model is. So the way that we define world models, I think, is a little different from what a lot of people define them as. We think of them as models that, first of all, have long-term memory. We like just call it persistence for brevity. But they're aware of what they generated before, effectively. They're also real-time. It means that these models, you can poke them, you can interact with them, and they react to you. Also, they think causally, meaning that they are aware of what happened before. Not only they remember it, but they take it into consideration when they generate the next stage of the output that you wanted them to generate. And like I said, you can actually poke them and interact with them. Not only you, like a human, but external, physical events or internet events, whatever it is that your world model is supposed to do. And so you can think of them really as a state machine that understand external inputs, take into consideration what happened before, and generate new outputs based on that, which is very, very different from image and video models, because those models, they don't have a sense of what happened before. So this is really why we're excited, because this changes what software is as a whole. Like in the current generation of Gen AI, you generate artifacts, but in the next generation of Gen AI, you will produce applications because they are interactive, they're real time, and you can they are aware of what's happening around in the world. And this is going to change entirely not only media and Gen AI and robotics, but software as a whole. And it's a very exciting thing. And so today, effectively, we already have a lot of use cases. I think, again, it's easy to not think about a world models as something that is useful today, but actually, for example, in robotics, they're becoming more and more used by robotics companies instead of VLAs and VLMs because they're better at being aware of what's happening in the surrounding of the robot, and they can even imagine visually what the robot should do, for example. In avatars and digital humans, real-time video AI and world models are extremely powerful, way more powerful than explicit-based, like 3D-based representations, because you can adapt them to various situations. For advertising, for example, you can use world models in real-time video to personalize content live per user, which is really the holy grail of media and advertisement, but also in some cases of new types of artistic endeavors. For simulation, again, being able to run generative simulations in real time in a way that is more precise, is more representative of the real world, and changes the game for what's possible in simulation. And one of the things that we are the most excited about at Reactor actually is the idea of generative software. And what that means is that why do we stop at generating media, games, and help robots actually act in the world? What if we could generate every single pixel that's on the screen in real time live? And if you think about how much frustration there is when humans interact with machines and interfaces that have been defined by somebody else and they're not really usable by another person, generative software has the possibility of really changing the landscape for how we interact with software in the future. And so also we believe that world models really are on the critical path to AGI because the information that you can get from visual input is so much richer than what you can get from text. And when you have systems that can interact with the real world and understand it, that's how you really deploy AI worldwide in a very useful manner. And so we feel also that by building Reactor, we are on the path to that. And so having explained all of this, what we're building at Reactor is the developer platform for world models. And what we mean by that is that our mission is to democratize access to world models such that you and everybody can use them and make useful things with them. They have been locked in how difficult it is to use them for a long time. And if you want to run them at scale, you have to take into consideration things like latency, you have to think about streaming, you have to think about super sampling, and Reactor handles all of that for you so that you, the developer, can just concentrate on application code and build whatever you're dreaming of using world models and real-time video AI. And we think this is the way that we get to really a broader adoption of world models and of this technology. And we make it very, very easy also for frontier labs and research labs to deploy their models on Reactor so that they can test them, distribute them to other people, and even earn revenue from people using their models. And I wanted to show you something funny here. So this is Jensen, actually, that I'm generating live walking through NVIDIA. I'm going to start the video again. So I wanted to show a few examples of funny things you can do with world models that are unthinkable with other technologies. So I just generated an image of Jensen at NVIDIA, and then I made him walk through it. So all of this I was controlling live. Like this was all happening live, and I could make him walk around and go around NVIDIA. And this is Jensen in his leather jacket walking around NVIDIA. And also this was another funny one that, these kind of things are impossible to make in real time without using something like a world model. And this is I wanted to showcase to you how incredible it is that this is possible, and you can just make it in basically instantaneous, not time, and just have fun. But there are so many more very serious applications that you can have with this that I would love for everybody to try and build. And that's why we, yeah, of course, it gets freaky. But yeah, so we are ready to allow developers to use this power. We have partnered with all the major world models in the world already, and you can go to reactor.inc today, download our SDK, and start building with world models. Thank you very much.
Thank you, Alberto. Next up, I'm excited to introduce Jan Lippert, who is the founder of OpenMind. Welcome to the stage. On your way. He's currently actually a very different background from some of the folks. He's a professor at Stanford. Previously, he was actually a professor at my alma mater, which is Berkeley. I won't be too offended by the Stanford thing. Woo, go Bears! Pretty excited that he's going to be introducing what OpenMind does. For those who have some familiarity with the robotics space, a lot of things are kind of fragmented, and so he wants to build what is the Android moment for robotics, an open operating system for embodied AI.
No, I can use this one here, but how do I? We will figure this out. Oh, wonderful. That totally works. This is great. Cool. Welcome. So I started life as a physics professor at UC Berkeley, collaborated with Facebook a little bit. That sensitized me to questions relating to collecting data at scale and using that information to make good decisions, primarily for a healthcare context. Then moved my lab to Stanford so I could be closer to a medical school. And so I'm a parent, I teach, I do research, I care about healthcare outcomes, and so I care about people getting better. And so I'm primarily motivated by things like healthcare, by teaching, by machines and humans around us. And I'm kind of curious for how all of that will play out. So I'm not going to tell you about hands today. I'm not going to tell you about assembly or manufacturing today. I'll think a little bit about what it means to be surrounded by smart machines and what we should try to build as engineers for those new capabilities. So, of course, every single one of you has read Norbert Wiener's Cybernetics. If you haven't, that's just horrible. So you should definitely do that. He has a really nice sort of broader perspective on automation. And of course, step number one, things like clocks and timepieces. The first revolution, as he calls it, is the devaluation of the human arm. So these are technologies like looms for weaving. These are technologies like steam shovels and auto manufacturing and Amazon and warehouse logistics. So you can think of them all as some variation on devaluing the human arm. And by the way, I'm just quoting him. I don't necessarily totally agree with how he's phrasing this, but that's what the argument is in cybernetics. And then, of course, according to Norbert Wiener, we're currently in the second revolution, which is the devaluation of the human brain. And here's some examples in that historical trend. So chess and Go, then there's Waymos, you can get to the airport. There's, of course, the way Ukraine fights wars, which is more and more automated. We're getting to the point where a lot of us think that general manufacturing and sort of manual tasks are well within technical reach. And then, of course, the sort of final step in all of this is things like caregiving, teaching, companionship, preparing things, and so forth. And I'm primarily interested in this last category of tasks and opportunities. And generally, what you're dealing with in this last category is you have a machine interacting with a person or multiple people. And that makes things like really interesting and challenging. When some of us think about robots, we might think about Tesla Factory. And other people, when they think about robots, they think about movies like iRobot. So what you have here is a situation where you have a human interacting with a robot, and that's a key part of the plot of this movie. And likewise, for a lot of us, when we think about robots, we immediately, of course, are drawn to Princess Leia and R2-D2. So that's an example of where the robot that's performing a vital task in Star Wars doesn't have hands, but nonetheless manages to save the resistance. And I'm very much in this sort of second camp. When I think about robots, I think about all the opportunities created by endowing machines around us with good decision-making and able to navigate complex dynamic environments with pets and people and patients and students and so forth. So I'm really interested in when we look at doctors, teachers, nurses, investors, bankers, police officers, electricians, whatever their job title is currently, I'm really interested in their ability to solve higher level tasks involving interacting with people, understanding people, remembering them, being able to deliver personalized content to that human in front of them. Sometimes when I teach physics for pre-meds, it breaks my heart because I'm looking at 500 students and I have no idea who they are. I have no idea what they know or don't know. And I know as a teacher that the way I'm giving my physics for pre-med lecture is super boring for like 3 kids in the audience, and then maybe not so easy to follow for the other 497 kids. And so I really wish I just had much better ability to understand each human in front of me and be able to deliver content more appropriately. And I think that's a general problem statement for all of robotics, is how to do that optimally for families, patients, and so forth. If you look at all 830 human job categories in the US right now, I'm just plotting how important social intelligence is to doing well for those tasks. Imagine a teacher or a nurse. This is not just about going through some static workflow. This is really about interacting with specific people and then delivering optimal care, for example. So as we envision machines being able to do more and more skills around us, it's very important for me that these machines are incredibly capable about interacting with people. So our eval criteria as a company is smiles and tears and trust and memories. So this right here is Diane. Diane's the human, Iris is the humanoid. And Diane lives close to the park. And when Iris the humanoid doesn't go to the park, Diane will ask, where's Iris, where's Iris? And that's because Iris is the only thing that will listen to her, sometimes for hours. And this makes Diane very happy. Her eyes light up. She comes and goes into the park because she's looking for Iris the humanoid. And you're welcome to call me dystopian. Isn't this a horrible future you're building on? Our parents should be surrounded by 3 generations of grandkids. Our parents should be surrounded by all their loved ones. If you look at long-term care in the US today, the average amount of time an American in long-term care spends in any kind of social interaction is 2 minutes a day, 2 minutes a day. And I like to think that in that kind of world, there is a big role for machines in connecting with us. And certainly when I start dribbling and drooling and my mind is gone, I almost certainly will be interacting with a machine, and hopefully I'll be smiling in that situation. That's one thing I would be very happy about. We have a little bit of a different take on things. There are 100 companies around us, and I love them all, and they're all awesome. And they're working on hands, and they're working on mechanical tasks, and iPhone assembly, and chopping onions, and making noodles, and folding t-shirts, and all of that is awesome. But by virtue of all the brilliant people who are focusing on that problem statement, I consider that that will be solved very quickly, very soon. And so we're starting to anticipate the next step where all these machines will be baked into our immediate environment, and we'll have strong opinions about their behavior and how they connect with us. And any questions or complaints you have, I put my email up, so if you liked it, that's awesome. And for any complaints as well, it's jan@openmind.com. Thank you.
Thank you so much, Jan. And now I would like to bring to the stage Andrew Tan. Make your way over here. He is the platform engineering lead at Grok Cloud. So a lot of the questions we have are not just, okay, can the model do this, but can it do it fast, cheaply, and for millions and millions of people at scale? So that is what he's going to be talking about, how to scale low latency LLM inference at Grok Cloud.
It's up there, right? Yeah. Maybe it's still full screen. No, it won't.
Okay, sorry about that. Can everyone hear me okay? So my name's Andrew. I'm one of the platform engineering leads at Grok Cloud. And over the last couple of days when I tell people I work at Grok, people like to say, oh, Grok has such a great personality. And sometimes I need to correct them to say, oh, I work at Grok with a Q. But we also do have, and that's not Grok with a K, but we do also have a unique and distinct personality, which is fast, low latency inference. And I'm going to share a little bit today about how we achieve that with Grok Cloud. So if you don't already know, Grok and Grok Cloud, we're an AI infrastructure company focused on low latency, deterministic, performant inference. Now, how do we achieve that, right? This is centered on the LPU or the Grok chip, which is custom silicon designed for low latency inference. And we have an entire stack constructed around that. So that's a compiler, a runtime, we've got cloud infrastructure, we've got global routing, a developer platform, and enterprise features as part of Grok Cloud. So I'm going to show you a quick demo of what this looks like. We'll just do a recording. I don't know if you could hear that, but it's sort of instant transcription. Tell me about AI Engineer Singapore happening in May 2026. And you see near instant tool calls. You see text being generated very, very quickly at about 500 tokens per second. I'll just play that again. And this isn't even the fastest model that we're using on Grok Cloud. So that's a quick demo, just to give you a sense of how fast inference can run. It's probably a few times faster than what you're used to on different platforms. Now, why is this important? And where is inference demand today? With agents, with multimodal models, with heavy reasoning models, inference demand is exploding. It's accelerating really fast. And in the last year, token demand on Grok Cloud, the number of tokens we served, has grown about 600% or 7x. And we're doing this with a hardware footprint that's not so much larger than where we were last year. If we wanted to serve all the demand there was for inference, this multiple would be much, much higher. Today, we serve about 800,000 active developers in the last month, and we continue to see demand from large enterprises, from startups, from AI companies, AI natives, and different kinds of developers around the world. And we do think that going forward, inference will really define infrastructure, the next generation of infrastructure and architectural choices around AI inference, AI infrastructure, sorry. Now, one thing we spend a lot of time thinking about is, I'm not sure why this is not full screen, sorry. Okay. Yeah, one thing we spend a lot of time thinking about is how to route requests around the world to serve tokens at the lowest latency. We've got about 10 data centers around the world, mostly in North America, but also in Europe, the Middle East, and in Australia, serving the APAC region. And with approximately 65% of token demand coming from North America, 20% from EMEA, and 15% from APAC, including 1% from Singapore. And each request, we route it to the nearest POP via our Cloudflare Edge network, and that gets routed to our data centers. And we make lots of routing decisions along the way to ensure the lowest possible latency for our customers. How that breaks down, this is the life cycle of an LLM request. We see that consisting of network latency. A request lands on our Edge network. It then gets routed into one of our approximately 15 inference regions, which could comprise either a cloud network or on-prem within the data center. We deploy our inference stack in there. And within the inference latency, it breaks down into queue times, where requests are queued up for different models. It also consists of prompt time or input processing, and completion time, which is decode or output processing latency. And these add up to the end-to-end latency you'd experience on making any LLM request to any provider. And queue times and prompt times are things we care a lot about, because that's the slow step in many cases for getting to that fast streaming time to first token. In a bit more detail, every request that comes in goes through authentication and hits one of our global load balancers. And the global load balancers share information across 15 data centers about what the estimated wait time and queue times are for every single model instance. And there could be 50 model instances deployed in every single data center. And this information is shared across all the load balancers in real time, every 100 milliseconds or so, to enable routing decisions to be made. It's not the easiest to make these routing decisions, because we do need to estimate what output generation lengths there are. Unlike typical API requests, you don't know how long an end-to-end request it's going to execute for, because you don't know how many output tokens are going to be generated, right? And we take some sampling, and we sample from the available backends, bucket the TTFT and route the request to the optimal model instance deployed in a specific data center. There are also a lot of checks along the way, including for rate limiting, obviously tracking and auditing different usage events as well. In a bit more detail, we bucket things by TTFT to route to the best model instances in the best regions. We apply some priority for different types of customers to make sure, say, our enterprise customers get faster traffic. This is done across multiple ingress paths into our different clusters. And we need to enforce sort of global rate limiting to ensure there's no geo-arbitrage to get around rate limits. And why rate limiting is important, I'll come back to a little bit later on. Another key aspect of serving traffic around the world is identifying the right model mix. At different times of day, in different regions, or even week to week, we see the demand for different models varying. And it's important to be able to deploy any model to a specific region pretty quickly. And we do this through a declarative, very simple manifest that reconciles quickly. So within a minute or two, after committing and merging some code config, we can deploy a new model into any region around the world. So minutes from merging to serving traffic with the appropriate canary testing and warm-up for each of the model instances. Now, another question we get often is, how do we get models to run on our custom silicon? Typically, we take open weights from Hugging Face and the PyTorch reference implementations, and we compile it into our Grok tensor operators, our dialects, into MLIR, schedule it, partition it across different chips. We run different presets to enable this, and that gets compiled into input-output programs or bytecode that executes on our custom hardware, or our fully compiler scheduled execution, and software scheduled network, so we get very extremely predictable latency performance for every single request. Now, why, with a popular developer platform, we attract a lot of abuse and fraudulent behavior as well. And you can see that the attack vectors are getting more and more sophisticated, and the number of abuse fingerprints we're picking up, abuse signals, continues to increase on the platform. So it's something we do need to monitor very carefully with rate limiting and other mechanisms. Now, just two more slides from me in thinking about what the largest enterprises that we work with are looking for in an inference stack in 26 and 27. Large enterprises are increasingly looking for dedicated compute capacity. Data residency continues to be an important topic. As models increase in size, these large MOE models, decode latency continues to be something that people pay a lot of attention to, and the unit economics associated of large model deployments. There's also a range of sophistication in large, even for AI natives, AI companies. Some want one-click deploy, some want a managed service, some want bring your own models, bring your own weights, some want their own inference stack. So there's quite a heterogeneous demand for different types of inference services moving forward. Now, the last slide from me is a little bit about what LPU-based decode looks like. I don't know if anyone watched the NVIDIA GTC speeches earlier this year, where NVIDIA CEO announced the Vera Rubin plus Grok 3 LPX system. The key idea behind that is disaggregated inference, where you run prefill and a number of the layers on GPUs, and you run decode maybe the FFNs, MOEs on LPU-like chips. And going forward, we do see heterogeneous compute being much more common, and the way to achieve better unit economics, better speed, and better performance. Of course, and that will need to be aligned to the ecosystem in the models that are compiled onto this hardware and run. So that's a little bit about what I wanted to share. I hope you enjoyed learning a little bit more about Grok Cloud. And we've got some links here on how to get started as well on our developer platform. Thank you.
Thank you, Andrew. And up next, I would like to welcome to the stage Daria, who is the head research scientist at Cerebras. She is a person behind designing many of the MOE recipes at Cerebras, and she's going to be talking about MOE at scale from GPUs to wafer scale AGI.
I'm super excited to be here today. I will talk about how we train mixture of expert models at scale on Cerebrus hardware. First, I want to start a bit about me. Currently, I'm a head research scientist at Cerebrus, and for the last couple of years, I've been researching MOE networks, and as a result, I have this MOE 101 guide that we published. It basically teaches you how to train and run inference for MOE models efficiently. Currently, I'm leading frontier scale MOE training on Cerebrus hardware. And before, I worked at a company called Yandex. It's very known like a Russian Google. I worked there on transformers and on the first transformer that we deployed in the production stack. And before that, I was at Google working on the speech-to-text models. For the agenda today, I would like to start with giving you an overview of what happened in the LLM community for the last few years and how we ended up with MOE networks. Then we'll talk about what is an MOE network and how we train them at scale. First of all, in the LLM community, we did a lot in the last few years. We started with the GPT-3. OpenAI released the model that was 175 billion in size. And in addition to the model, they also released the scaling law, showing that as you increase the model size, you're getting better and better quality. Shortly after that, there was a release of Llama 3 series by Meta. They scaled the model further, so it's 400 billion in size now. But in addition to that, they spent a lot of time figuring out how do you extract the signal from the data efficiently. So some of you might have heard about the chinchilla scaling laws. They suggested that in addition to scaling the model, you also want to scale the token budget. Something like 20 tokens per parameter is considered compute efficient. And so at the end of this, we were able to scale both model and tokens very efficiently. However, if you continue scaling the model size and the token budget linearly, it becomes very, very expensive very quickly. We want to train trillion parameter model sizes on trillion parameter data sets. So the other breakthrough that happened a couple of years ago was the release of DeepSeek V3 model by the DeepSeek company. That model was larger in size, so 671 billion total parameter count, but it was very, very efficient because it would run at the speed of the 37 billion active parameter dense network. How did they do that? The architecture behind the scene is a mixture of experts. If you look at the decoder block of the transformer network, you'll see that we have different types of layers. We have embedding, attention, and the FFN block. If you want to create an MOE network, you'll see on the right, you just take the FFN block and copy-paste it. And each FFN is now going to be called an expert. You also place an additional network on top, which is called the router. And the job of the router is to decide which expert should process a particular token. This way, you can continue increasing the capacity of the network, so you can go to 671 billion parameters by adding more experts. But because you only activate a small fraction of them, you can be very efficient and run at the speed of the 37 billion dense network. Now, you might wonder, okay, this sounds great, but how does the scaling law look like for these networks compared to the dense? Here, I have a plot for you where I'm scaling the number of experts and comparing the quality of the MOE network against the dense network running for the same flops. You can see that you can get loss improvements up to 5% here with 32 experts with literally no increase in compute. So you get it for free just because the architecture is smarter. On the other hand, you can think it about this way. You can train to the same loss as the dense network with just a third of compute. And here, I only have 32 experts, which is very, very tiny compared to what the state-of-the-art models use. We use hundreds of experts. So you can see how efficient this architecture is. And in terms of the LLM community, we are super excited to have that running at scale because for the last few years, we couldn't shift the scaling law as efficient as it's done with the MOEs. Now, we know that it should run faster than a dense network, right, based on the theory. However, when we actually run it on an actual device, like the GPU device here, we get it slower than a dense network. The MFU is lower. So why is that the case? Let's take a look at how we actually implement MOE networks on the GPU devices. Each GPU usually has a limited amount of memory, and so if you run a very large network, you have to split it. You have to split the model parameters. For MOEs, we use expert parallel. Basically, you position different groups of experts on different devices. You can see here, expert 1, 2, 3 is on GPU 1, and expert 4, 5, 6 is on GPU 2. And you add 2 additional all-to-all operations. This is usually done because you also do the data parallel, and so you don't know in advance where to move tokens to which devices, so then they can be processed by particular experts. And so these 2 all-to-all operations are very expensive. Majority of the time, if you try to profile this, will be spent on the communication. And unfortunately, there is nothing fundamental that we can do on the GPU side to improve that. It comes down to the physical wires. Now I want to show you a comparison between the GPU device and the CS machine. Here I have the B200 GPU. You can see that it uses 126 megabyte of SRAM. It's all L2 cache. It's the available memory on the chip. And it's also running at 8 terabytes per second on memory bandwidth. It's also a very tiny silicon compared to the Cerebrus, which is the size of the dinner plate. And it has way more SRAM. So you can see that we have 44 gigabytes of SRAM, and we're running on orders of magnitude faster memory bandwidth. What it allows us to do, it allows us to actually train a very large network on the chip itself without any type of model parallelization. However, if we go beyond the 44 gigabytes of SRAM, we developed a technique that helps us train networks literally like 1 trillion size on just one device. How we do that? We add additional memory X nodes to our chip that will be our weight banks, basically. It's like external memory where you hold most of the model parameters. To do a gradient update, you're going to stream layer by layer weights from the memory X nodes to the chip, calculate your gradients, and then move the gradients to the memory X node to update the weights. This way, you can connect very large memory banks, like memory X nodes, to one chip and train 1 trillion models and beyond that without any type of model parallelization and without any additional chips. And this is very useful for MOE networks in particular because we want to train very large networks. We want to train a lot of experts. And so experts sit on the same memory X nodes or on the same chip, and there is no communication overhead. However, when we run MOE networks on Cerebrus, we actually see the same problem. They're running slower than the dense networks. The problem here is slightly different. Today, MOE networks are very different. We want to train a lot of experts that are very tiny in size. And because of that, we have a problem with arithmetic intensity. So MOE layer compared to the rest of the networks moves a lot of weights, and it does very little compute per weight used. Because of that, the throughput, the speed of the MOE network is worse compared to the dense. We fixed this problem with a technique called batch styling on attention. Essentially, if you want to deal with the compute scarcity, if you want to improve the arithmetic intensity, the easiest way to do it is to increase the batch size. However, if you look at different layers in a network, if you just uniformly increase the batch size for all of them, some of the layers will actually hurt performance, like the attention. Attention is activation memory bound, so increasing the batch size there will start evicting more stuff into the memory X nodes, which is not efficient. We don't want to do that. Instead, we want to decouple the batch size requirement for attention and the for MOE layer. You can see here, for attention, we can keep a very small batch size, the original batch size, and just iterate in loops and concatenate the results together into the bigger batch size. You can see that we concatenate G different loops. And now we can throw this bigger batch size into the MOE layer. And it's going to be restoring the arithmetic intensity of that layer to run it at the speed of the dense network. And you can configure this G depending on the sparsity level. So here I have the results for you, the empirical results, where we tested different levels of sparsity for the Qwen3 network. You can see that baseline without BTA on Cerebrus can run up to 7x lower than a dense network, which is very inefficient. With the BTA, we fixed this problem, and you can see that we can restore the original theoretical premise of the MOE network and run it as fast as the dense network. So 671 billion MOE network from DeepSeek can run at the speed of the 37 billion dense. Takeaways. I want to share with you a few takeaways here from my talk. One is MOE, in my opinion, is the fastest way towards the AGI. So compute efficiency that comes from that network is really incredible. Unfortunately, MOEs are not very efficient on the GPUs, and they hit some communication bottlenecks. However, on Cerebras WC, we fully realized the MOE theoretical promise. Thank you. And if you want to learn more, here is the QR code to the MOE guide, where we talk in details how to train these networks. Thank you.
Woo. Thank you, Daria. Woo! Yeah. All right. This concludes the first section of our afternoon talks. So we have a 15-minute break before we come back. A few quick announcements. Number one is that the expos, where you can meet the different companies at their booths, is going to be closing at 5 p.m. So if there's anyone you want to meet, head over to Pullman or the Atelier. Atelier has booths like Cursor, Google DeepMind, etc. And then Pullman has the Robot Playground and OpenAI's booth, amongst many others. I'd like to welcome back to the stage Keziah, who you've seen at around 10 a.m. today, who is a trained mindfulness teacher, who's just going to give a little bit of an experiential immersive experience where you can, where she basically created a vibe-coded particle visualizer trained on hours of meditation.
keep the programming going. Next up, we have tasks. If you aren't familiar with Zed AI and the GLM family of models, some of the best open source models on the market, not as expensive as the premier models you might be using, very good for things like OpenClaws, personal automation kind of stuff. So without further ado, I'd like to welcome Zixuan to the stage.
I thought I changed it to long horizon task. Why is and let me check the other side. Okay, so you can change to the current size, right? Maybe it's. Of GLM model. So today I will present GLM 5.1 and also the idea behind long horizon tasks. But it's not G.AI, and G.AI belongs to Google, not your company. So why you're called Z.AI, it seems irrelevant. And the point is, we were first called 智谱 in Chinese. So 智 actually stands for 智, intelligence. And when we found that it's hard for foreigners to pronounce 智, Z-H-I, we try to make it shorter, so make it Z. Actually, Z stands for intelligence. You can regard it as intelligence.ai. So it's the best way to link this Z.AI platform to our model and to our services. And also, I want to introduce GLM to you because a lot of people have used GLM 4.7, GLM 5, GLM 4.1, but actually, we were one of the first companies exploring large language models, as you can see from this paper. So we submitted on someday, March 18, 2021. So we began the exploration of all the large language models back in 2020. So together with OpenAI and DeepMind, maybe the earliest labs doing so, but we became famous only in 2024 or 2025 for most of you. And now GLM has become a brand, not just stands for this generic general language model, like large language model, we also have our own branding. And now we currently use architecture outside GLM, the original architecture, to make it stronger, faster, and more efficient. Okay, and more about the model. So currently we're pushing the boundaries of open source. So we are leading the open source models in text arena and code arena, as you can see. So I did a screenshot before, after the DeepSeek. So when DeepSeek, they launched V4, they show that they improve a lot, but still cannot beat GLM 4.1, so in these benchmarks. And also, we are quite strong in coding and agentic tasks. So as you can see, this is artificial analysis latest benchmark, like combining 3 individual benchmarks, and we are just lag behind GPT 5.5 and Opus 4.7. So its current state very close to Opus 4.6, but many people use GLM inside cloud code, cursor, kilocode, OpenCode. So we are not very famous for our harness, but like we use other harnesses, like they're great and their coding agents can help GLM make better jobs. Okay, so that's all for GLM itself and Zixuan AI. Now we're talking about long horizon tasks, because today I'm not spending too much time on GLM, but I want you to remember the idea and fully understand what long horizon tasks actually means. So have you heard of long horizon tasks and long running tasks? If you haven't, so these 3 labs, they all mention long horizon and long running in their latest post about their model. So GLM 5.1, we emphasize a lot about our long horizon capabilities. And Opus 4.7 also mentions long running skills. And for Kimi K 2.6, they have beautiful front-end capabilities, but they also emphasize a lot their long horizon capabilities, especially coding capabilities. So long horizon has become very popular. Why? So why it matters to you? Why you listen to this idea behind the model? So we can share a lot of things, how to make websites, how to make slides, how to use GLM for Excel, but why long horizon matters? So the first thing is it's useful. Because before the era of long horizon, you can only achieve like 1 to 10 tasks at a time. When you go to sleep, you don't have tasks to do because your agents can only finish it in 30 minutes and you have 8 hours. Your agents cannot do anything. But with long horizon tasks, everything becomes true. And another thing is with the evolution of OpenClaw and Hermes, there are a lot of agents that has heartbeat that can interrupt your task sometimes. You have a memory, you have a lot of things going on, you have MCP, they can interrupt your workflow. So unless your model has long horizon capabilities, they can stick to the original goal. So if they cannot stick to the original goal, they'll follow the latest instruction and totally forget what you're doing right now. So long horizon capabilities make this happen. And a fun fact, a very interesting story. So in our latest hackathon, we had a 48-hour hackathon. It's the first time we have a 48-hour. So there's a night between the 2 days. Most of the participants choose to run GLM 5.1 during their sleep. And actually they made it. So 7 out of 9 winners chose to run the task during their sleep. And it's a great, so I use a graph to show this. When you sleep, maybe this year your agents will continuously work every time. Your agents gathering and discuss and finish the work for you. And also, the second reason why I have to introduce the idea of long horizon to you is it's hard. So not just useful, because if it's useful, like there's no need, I speak here, you can use it freely as Zixuan AI, you can try your best, you can run it whatever you want for 8 hours. But it's very hard, because the first thing is many people think long horizon as long context window, but actually GLM 4.1 only has 200K context window. So where's the gap? First thing is GLM 5.1 is really strong, not because context window is very long, because it can understand the context, it can understand your plan and your memory to better reflect the outcome. When you use cloud code, sometimes you cannot use like 200K, but the context window may be compressed quite often, so you need to stick to the original goal. And the second reason is, so even some models claim they have 1 million context window, but when you use like near 500K, it forgets everything. They only stick to the latest guidance and forget the original plan, or they don't follow what's going on in the Cloud MD. And the second reason, or the second misconception is, some people think if I give enough instruction beforehand, so I list all the instructions, it may follow pretty well because there's no need. The model has the long horizon capabilities. I have long horizon capabilities. I can instruct it to do it in the 100 rounds. But actually, one model was not trained in this aspect. It doesn't have enough capabilities to stick to your plan. So it will try to do whatever they want after a certain pattern, and later on we'll show you the story. And the third misconception here is that many people think the longer the better, right? So when a model lab posts like, I can run 8 hours, maybe another lab shows that I can run 12 hours, 24 hours, like a day, 7 days. But from my point of view, that doesn't make sense because we have super fast inference right now. Yeah, so as you can see, there are a lot of inference providers that can provide TPS more than 200. And the latest technologies, they hardcore the model inside the chip, they can inference near 17,000 tokens per second. So the time doesn't matter, right? If you think about time, you use the latest techniques, you only need to run like 1 minute. It doesn't make sense to run 8 hours, right? So what actually long horizon, the long means, is not about time, it's about a kind of depth. So I speak here not longer, but deeper. So long horizon actually means a capability to keep finding meaningful improvements. Yeah, so you have to make improvements, but these improvements are meaningful. For example, so if I have 10 followers on X, I want to collect all their information. So I give a prompt, so scrape all the data of these 10 followers. So those are one scenario. But if I want to scale, I scrape 100, 1,000, 10,000, the mission doesn't change very much, right? So you have to make very meaningful changes and improvements. So what actually are long horizon tasks? So you talk about the idea of long horizon, you talk about what are wrong, but so what are the right thing? What need to be cared? We have two categories. The first category, we call it subjective goal. So in this first category, you want to create a website, you want to create a system. There's no clear metric of what the best website is, right? So you can let the model run infinitely. But where it stops, that depends on your capability, your judgment, not the model's judgment. And the second category is that the scenario requires an objective goal. For example, you want speed, you want price, you want everything related to a certain figure. So we have two categories, and for each categories, there are completely different mechanisms for we to optimize, both as a model and also as a human. Oops, there's a video, but there's something going wrong. I'll try to make it happen right now. So if it's not fixed in 30 seconds, I suggest you to look at the X of Z.AI. So actually this is a video of how we built a Linux system from scratch, from 0 to 1 in 8 hours. And within 8 hours, it doesn't just adding apps. It first created a layer to let all the apps can be integrated into the system, and then it polish all the interface and then test all those apps and finally add 50 apps to it. So that's what this is supposed to be. But like, unfortunately, we cannot present here, so maybe you can search GLM 5.1 blog, and there will be a comprehensive illustration of this task. So why humans are needed if this model is super strong and it can finish almost anything? So why are we needed? Because I can go to sleep. I don't need to instruct the model, right? Because when I go to sleep, I let it finish a Linux app, and after I got up, so it's already there. Why do I need to join this event and learn how to use long horizon tasks? Because model can make mistakes, and they make mistakes quite often. There are 3 major mistakes a model can make. The first one is the model may not stick to the original goal. If you do a prompt that let the model optimize for 5 times, it may behave perfectly. But if you let model to optimize for 600 times, it may totally forget the original goal, right? Because the model always, the attention, they care about every single token. So sometimes when you talk about Linux and then you talk about iOS, the model totally forgets, oh, you are doing a Linux app or iOS app. That's quite often. To handle this, I suggest everyone or recommend you to have a checklist. So whenever you do long horizon tasks, try to prepare a checklist. It's the best way for your model to stick to the original goal. And you have to ask it to reread the goal every few steps, because you have many steps. Right? Because when you optimize for only 10 minutes, you don't have many steps, you don't think it's very important, but you have to manually instruct it to reread all the instruction pretty carefully. And the second thing is error accumulation. So if you find the model makes a mistake in the 400 rounds, let's say, so it doesn't impact a lot. But when it goes to 800 rounds, it can actually break all the things. So that's called error accumulation. So to let it not happen quite often, you have to verify, not by yourself, but you have to instruct the model to verify itself. From 0 to 1 to 100, you need to have several checkpoints. So when we train model, we have checkpoints. But when you run long horizon tasks, it's similar. You have to set several checkpoints for yourself and for the model to check itself. And the third thing is models were trained to push very hard, right? Because if you want the model to do this, it will continuously and sometimes in the loop keep doing that, keep doing the single thing at a time. But it's hard for them to pivot. So the model never gave up sometimes. So you have to let the model give up or pivot if they found something very wrong. So also checklist is great, is very helpful here. And you have to evaluate whether by yourself or by the agent, whether to continue, to stop, to revise, to do anything that's related to your task. So those are the suggestions for the subjective goal type of long horizon task. So that's what people can do. And I think a lot of people are building their apps or you are doing similar stuff, so that might be helpful for your deployment. And another thing, so it looks harder because that's what objective goal is about. So we have a very strong case. It's called like optimizing a vector database. I believe not many people of you have optimized a vector database. Even our researchers or the people who is responsible for training haven't have access to this domain knowledge, but our model did. So we start from 0 and we let the model to optimize for itself and for 100 runs. And finally, they got here. So have a very meaningful improvement at 100 runs. And we do similar stuff. So from 0 to 100 runs to 200 runs, finally we go to 600 runs. We have basically 6 to 8 scientific findings. So the model pivot a lot. At first they use technique 1, and they start to use technique 2, and they use technique 4. So I want you to mention these failures. So actually, these crosses means failure. So when you look at these 600 runs, so basically, most of them failed, right? So when you talk about long horizon tasks, actually, it doesn't mean that you succeed every time. It's just like life. So you sometimes succeed, sometimes fail, and in the circle area, all the optimization failed. So for long horizon tasks or long horizon models, the critical part is the model can reflect, can plan, can change the ideas, or can optimize, improve, can continuously improve itself to a better way. So that's what the future optimizations look like. And for this type of task, maybe it's very hard for you, and maybe it's very hard for me. I highly recommend you to look at evaluations. And here's my favorite evaluation currently. It's called Frontier Switch, because we all know SweetBench. We all know SweetBench Pro, but Frontier Suite is a bench that's trying to assess the capabilities of long horizon tasks, including both subjective goal and objective goal. And it's their category. So they categorize long horizon tasks in 3 ways, not just by subjective goal and objective goal. So first is implementation. When we talk about implementation, you start from 0 to 1. Here's our 3 examples, and I highly recommend you to look at their website. It's beyond 3 tasks. And when you want to build an app, when you want to do some web coding stuff, agentic AI stuff is pretty much same like implementation. And the second one is research. So actually, trading is type of long horizon task. You have to learn from your previous failure. You have to learn from a lot of things. You have to do the research for the market. So a lot of things outside coding belongs to long horizon task. So long horizon doesn't belong to what engineers do. Traders, scientists can also use long horizon tasks to do things. So that's what research stands for. So you can use long horizon to explore a lot of things. And the third way is optimizations. I have shown you the capabilities of it. So currently our model teams is using AI, is using GLM to optimize CUDA kernel, to optimize vector database. So when we talk about self-evolving, when we talk about continuous learning, Zeta.ai model teams are already a team, an AI native team that can use model to improve itself and improve the inference of the model. Okay, I think that's all for today. And here's my LinkedIn and X. One, I doesn't post on LinkedIn, but there's a profile of me, and on X, I post a lot. I'm quite active on X, but there's no profile, so you better scan both. And I think that's all for today. Welcome to all the questions. Yes, yeah, feel free to reach out to me through these 2 platforms. Thank you very much.
Thank you so much. Next up, we're going to switch things up a little bit. We're going to talk about voice agents. Now, obviously, we've talked about design and different interfaces as part of it, as part of the conference so far. And we wanted to look at how voice might be one of those paradigms. And to that end, no one better to hear from than from Boris Starkov, who's a growth engineer with 11 Labs. So 11 Labs obviously is one of the leading companies in the space. And Boris will be talking about the speech engine and what makes an agent conversational. So without further ado, Boris.
Hi, everyone. I'm Boris. I work as a growth engineer at 11 Labs. 11 Labs is a frontier voice AI lab. We research and build applications all across voice AI. We're also particularly excited, and we strongly believe in voice as the main medium for human-to-agent interactions. And matter of fact, we're very happy that the industry is starting to catch up with that vision. Take coding agents, for example. Most, if not all of them, actually have some sort of use voice mode button. However, if you actually use it, it works the following way. You start talking, you talk to it, then you wait for it to get transcribed. You wait again for the agent inside, and then you wait for the third time for actual speech synthesis part. So sure, this is a voice input, and this is a voice output, but this is not conversational. And today, I want to talk about how to improve this architecture to make it feel much more like a natural human-to-human conversation. We're going to keep the core architecture the same, but we're going to add a lot of small improvements that combined together make a huge difference. I'm going to start with the improvements to speech recognition part, and then in part 2, I'm going to proceed to some improvements to cover some improvements in the speech synthesis. So probably the most fundamental piece of puzzle here is called voice activity detector. We take the audio stream from the user and then split it into chunks of approximately 20 milliseconds. And then we have a very tiny, very efficient, and very cheap model that can tell you for every chunk whether someone is speaking or not. Not only this is very helpful later on downstream to actually understand what's going on, whether someone is speaking, whose turn that is, it also helps us to save a lot on compute. Because if we know that in some chunks nobody is speaking, we don't need to run a more expensive ASR model on those. It's very important to understand that detecting silence and detecting the end of the turn is not the same problem. For example, agent can ask me something, and I respond with, I think there is a lot of silence, but it's not the end of my sentence. I don't expect the agent to interrupt me at this point. That's why detecting silence is not enough to accurately predict when the agent should start speaking. So here, we trained another model again, a very smart turn detector model that takes into account not only voice activity, but also the actual context of what's been said before to predict whether this is the end of the sentence or the speaker, the user, is going to say something else. Like in many other steps, by the way, here we use a bunch of heuristics. For example, if the user is spelling out their card details or their credit card details or their email, or they say one of the trigger words that we have. We use this as a very strong signal that likely there will be some sort of silence, and likely that silence doesn't mean that the user is done speaking. This model is crucial in the following slide. So one of the biggest unlocks, one of the biggest wins we can achieve in terms of improving latency in turn-based models is the following one. So to understand this, let's think about how the human-to-human conversation goes. You talk to a friend. Let's say your friend is talking to you. They're talking, then they stop speaking. Then you wait for approximately a second to make sure that they don't have anything to add. And only then you proceed to reply. Unfortunately, agent can't afford to wait for a second because it also needs some time to generate the response. That's why what we do a speculative turn, which is immediately after our model thinks that the user likely stopped speaking. At the very same moment, we speculatively start generating the response. Our model is quite smart, And so most of the time, it's a right call, and the response comes much earlier, and the latency is much lower. It feels much more natural. And maybe sometimes there would be a false positive. That's not a big deal, because then we just send the cancellation to the generative model and continue listening. Sounds like a lot, but that was only the first part. Now a little bit of how to improve synthesis part, speech synthesis part. So the agent sends us the tokens, and the user expects sentences in terms of speech, like speech sentence, yeah, speech. We can't really afford to wait for the whole sentence before we send it to the speech generator model, because then the user is going to wait in silence. We also can't really generate tokens one by one, because then some tokens will be generated very quickly, and other tokens would take some time. The whole generation would feel very jumpy, very laggy, and not stable. So we take something in the middle. We make a buffer for small phrases of 5, 6, 7 words. We collect tokens together, and then flush them to the generator before the whole sentence is constructed. This lets us have the best from both worlds. We have stability and low latency. This is also quite efficient, because while the current phrase is being played out to the user, the next phrase is already being synthesized, and the phrase after that one is already being constructed in the buffer, all at the same time. We also use cascading in many parts of our models and tools. For example, here I'm going to talk about TTS cascading, which is we have a text-to-speech model that generates the response, and at every single time it's running, we also have a second model, fallback model, that's ready to pick up whenever the first one fails. So even if the current model fails or have some sort of crash for some reason, the user is never experienced to it, ensuring almost 100% uptime. So users are never experienced to experience crashes, errors, bugs, etc. This one could actually be a whole talk of itself, but a very important part of making your turn-based model feel truly conversational is handling interruptions, letting the user interrupt the model. That comes with a lot of different corner cases, heuristics, etc. Here I'm going to cover just a couple of them. So imagine you're a model, and you're trying to detect that the user is interrupting you. So first, if the interruption is very small, very short, a couple of frames, 40 milliseconds, it usually means that it's a cough or a noise, or perhaps a false positive coming from the voice activity detector. That's not an interruption. Another example is if the interruption is coming in the first 200-ish milliseconds. That also likely means that it's just an echo. Another one, for example, if the user is saying, yeah, okay, that's an active listening. That's not an interruption either. And there is a lot of small corner cases like that here. Well, let's actually zoom out here a little bit. You've built an agent, and you've came here to listen to this talk, thinking that you're going to make it conversational. And now with all these little steps, you might feel a little bit intimidated by how complex it is. Well, good news, we've got you. Introducing Speech Engine. Speech Engine is actually the new product that we have. We didn't publicly announce it yet. We're going to start testing it starting next week. The way it works is we encapsulate all of the complexity related to making things sound fully conversational into this product, while you can bring your own agent and very easily plug it in. So it could be your chatbot or your OpenClaw, NanoClaw, Hermes agent, whatever. Any agent of any complexity, you can just simply plug it in. And remember, this is not a speech-to-text and text-to-speech. This is a proper conversational engine. We're very excited to see millions of silent agents becoming conversational. Keep an eye for update on this on our socials. Again, we're gonna likely start testing it publicly next week. And thank you very much.
Thank you so much. Next up, we have Jackman from Prime Intellect. He's a founding research engineer. Jackman, you can set up. And he'll be talking about continual learning for long-running agents, agents that keep getting better. So this has been something that's been a recurring theme the last couple of days. We've talked about software factories. Zed AI talked about long-running agents. This has been a theme that has come up time and time again. And I think the question that keeps coming up is, if an agent runs for too long, how are we making sure that the agents are getting better or learning as they go along? Because it doesn't make any sense if the agent just runs for 20 hours to put out stuff that doesn't work, right? So Jackman works for Prime Intellect. Prime Intellect is one of the pioneering companies in the space. If you want to train your own models, if you want to work on these environments where you can test and improve things, they have really cool tech to work with. And Jackman, whenever laptop's ready, the floor is yours.
Yes, thanks, Agrim. I actually changed the topic of my talk, but it's still related to continual learning and long-running agents. Just I picked a catchier title, so you'll see it when it appears on screen. So yes, hello everyone. My name is Jackman Ong. I'm a founding research engineer at Prime Intellect, and today I'm going to be talking about reinforcement learning and recursive language models. So we've heard a lot about agents today and all the exciting things they do, and I find it quite crazy that just 2 years ago, back in 2024, when Cursor Agent had just released, if an agent ran for more than 5 minutes, you would not expect it to be doing anything useful beyond that point. And yet, here we are, in 2026, 2 years later, and where we just let the agents roam free while we sleep, going for hours and hours, consuming millions and millions of tokens to do some pretty remarkable things. And so I think it's not a question, especially in this audience, that the models are really useful. And so the questions become more economical ones. Questions like, can the models do my task reliably? Can the models do my task efficiently? And can the models do my task quickly enough that I can deliver the user experience that I want for my product? And so today, I'm going to be making the case that the solution to all of the above is that you should be training your own language models. And in particular, you should be doing reinforcement learning to do so, and also using RLMs. So first, what is the issue with long-running agents? So I believe that anyone who's used the agents, be it Claude Code or Codex or any of the claws, you know that the models aren't actually that good at long context. Just because your model accepts 1 million tokens doesn't mean that it can reason across the 1 million tokens. And this is pretty apparent in the benchmarks. So if you look at any of the big model providers today, usually in their model card, they'll have a section called long context, and there'll be 2 benchmarks in there. The first one is MRCR. This is needle in the haystack. And basically, this is testing the model's ability to retrieve a particular piece of information in a long series of text. And you can see that as the context length gets longer, the models get significantly worse at this task. And people who have been working on agents kind of know that this information retrieval thing is kind of nice to measure, but that's not really what we want to know about the models, right? We want the models to be able to reason across the 1 million context. And so a very popular benchmark that's appeared recently is GraphWalks. And GraphWalks is basically, we pass a list of nodes and edges into the prompt and basically ask the model graph questions. So things like list all the parents of X, or do a BFS on Y and list all the children. And you can see it's the same story. As the context length gets longer, the models get significantly worse. But what if, instead of passing the entire context into the context window, we just pass it a reference to the context? And I think this is pretty intuitive if you're like a data scientist or if you've done any amount of data science and you've done exploratory data analysis in Jupyter Notebooks. Because like you don't pass your entire CSV into the Python code, right? You usually do like, okay, I do my classic data science imports, and then I define a data frame, and then I'm doing these like code snippets to slowly manipulate my data frame, try and figure out the structure of my data, what the distribution is, and then I figure out, okay, what things can I do with this data? And if you think about designing agents in this way, a lot of things become very easy. Like context chunking becomes very easy. Tool calls becomes very easy. Sub-agent delegation becomes much, much easier. And the reason is that your orchestration agent now doesn't need to reproduce the context autorecursively correctly, right? It just can pass it as a variable. And so why stop at just variables, right? Why not have the entire grab bag of programming structures? So say, for example, you need to process, you have some task that needs to process 10,000 documents. If you were to do this in like the legacy language models, basically you would need your orchestration agent to do 10,000 sequential tool calls correctly. And like not just do the tool call correctly and pass the context correctly, you also need to pray to like the summarization gods, please, that when the model does its compaction, that it somehow remembers all the various things it did and can somehow still remember like where it is even in like calling all these sequential tool calls. But if you had just done it as a recursive language model, you could, well, the model could simply write a for loop and just basically do these LLM queries, these sequential queries in a very simple manner. And so we see that like the people who are really good at using the agents kind of already do RLMs. Like if you meet anyone who's really good at using Claude Code, they're always writing these prompts of like, oh, please, don't put the sub-agent don't put the sub-agent output into your context window. Don't put the tool call output into your window. You'll probably mess up and they'll garble your context and like write everything into a file. Because like people who are very good at using the agents kind of know that compaction doesn't really work. And when you see this, like you know it's over. The model is not going to recover from a compaction. And so any chat agent that you can use now, like ChatGPT and Claude, or like AI Studio, basically, if you try to put a really long series of text into the chat window, they basically always turn it into a file. So like the point being made here is that like people kind of already are doing recursive language models, but they're just not doing the full power of it. They're only using the variable aspect of it, the fact that you can reference context. But they're not getting the full Python expressivity that you can get if you had a full Python REPL. And so I think it's no surprise that people have started to use RLMs for everything. So anything that needs like long context understanding. So there's RLMs for videos, there's RLMs for gaming, there's RLMs for coding, there's RLMs for math. I believe at some point on Twitter, there was even an RLM for Epstein files. I couldn't find the tweet. Maybe the CIA removed it somehow. OK, and like the Alex Zhang, who is like the first author of RLMs, he wrote this really nice post that I think everyone should read called the Mismanaged Geniuses Hypothesis. And the basic idea in there is that the models are already capable enough to do a lot of the tasks you want. And the only thing holding them back is the scaffolding. We don't quite know how to orchestrate these agents. We don't quite know, like, oh, where we should put the memory, what exactly it should be doing, what are these like sub-agent delegations. And like the bitter lesson way of viewing this is like, why are we making humans do this, right? We should just let the agents define their own scaffolds. Like all the scaffolds you guys use today, Claude Code, OpenClaw, super vibe coded. So it's very obvious that the models can already write really good scaffolds. So they should just dynamically write the scaffolds as they're doing the inference. Well, it's not so nice right now. So you guys might have like seen the slides before and been like, oh my god, this is like the best idea ever. And then like you go home and then you try out the RLM repo. But you might feel a bit lackluster. And the issue is that what you will notice if you look at the way that the agents do RLMs right now is the agents aren't trained on this scaffold. So they're not very good RLMs. They don't quite figure out that, oh, they should be doing sub-agent delegation. They don't quite know how to do this like context slicing thing. But like, yeah, you should read the blog post. But in the blog post, basically, it's showing this task where if you had just taken the base model with the base RLM prompt, it doesn't perform very well. But with a bit of prompt engineering, you can get significant performance gains. And you basically always beat the base model. And if prompt engineering is enough for you to be able to beat the base model with RLMs, what's stopping you from just training these good RLM strategies right into the model itself? And so that's what we're trying to do at Prime Intellect. So Prime Intellect, we're a platform that is trying to serve anyone who is trying to train and serve their own language models. We support many of the open source language models from GPT-OSS, to Llama, to Nemotron, and all the Qwens. We basically have experiment management, so you can see your metrics and also all your experiment configs. And most importantly, you can look at rollouts, which is like the most important thing. You can see your failure cases and look at your data. We have some pretty interesting users. So I think this was like 2 weeks ago. Ramp Labs announced that they were working with us. And they basically did a project where they trained a small Qwen model to beat Opus 4.6 on a retrieval task for Excel agents. And not only did it beat Opus 4.6 in terms of accuracy on this task they were interested in, they also could do it more cheaply, and they could also do it at lower latency. Another interesting user segment for model training is data vendors. So there's this guy called Sean Chai. I think if you're in the data space in Silicon Valley, you've probably met him before. I think he's basically talked to like every data supplier, every data consumer in the Valley. And he made this observation that the distinguishing factors of like which data labs will make it in the future is whether or not they're able to develop in-house training capabilities. Because these models, labs buying the data, they're not stupid, right? They know that like not all data is created equally. And before they sign like $1 million deal to buy a bunch of data, they want to know, like, is this data going to improve my model capabilities or not? And a very easy way for you to do this, and very definitive way for you to do this, is to simply show reward curves. Simply show that if you are trained on my data, then your reward goes up. Or if you are trained on my data, your agent performs the task significantly more efficiently. So if any of this sounds very exciting to you, please check us out. We're at primeintellect.ai. We look forward to seeing what you guys build. And that's it for me. You guys have been a great audience. Thank you very much.
Awesome. Thank you so much, Jackman. That was a really, really good talk. Next up, we have Michelle Julia, who's a co-founder of Blue Labs, who will be talking about for AI to be emotionally intelligent. Obviously, we've been talking about personalized AI for a while, so this is a topic that's pretty pertinent. But Michelle is also kind of a badass. She's one of the youngest patent holders from Apple. So if you've ever used Find My iPhone or Bump to exchange contacts, the wireless system that runs underneath all of it, she is the patent holder for it. But today we're not talking about that. We're talking about emotionally intelligent AI. Without further ado, Michelle.
Is this the mic? Hello. Hi y'all, I'm Michelle. I'm co-founder of Blue Labs. We're a research lab focused on emotional intelligence, specifically embedded emotional intelligence. Embedded emotional intelligence is the capacity to navigate ongoing relationships where each interaction shapes the trajectory of future ones, so it's not a static state. It treats stewarding the relationship and capturing immediate utility as co-equal objectives, not as a trade-off to optimize. So our research is around what architectures let AI systems do this in a way that humans do. if you take a quick step back, really, we're focused on making AI sound and feel human, especially in commercial decision-making processes. So that's where we're focused on today. Let me ground this in a quick story. So, as he mentioned previously, as Agrim mentioned, I was at Apple before Blue Labs, and I was one of the youngest patent holders there. If you've used Find My, it runs on wireless algorithms that I hold the patents for. And you can imagine I am a small Asian woman. Oftentimes in negotiations, the room looked like this. So I was a little bit anxious going into every negotiation. The first one that I went to, we were flown out to Portugal. And the night before, I was sitting in the lobby of this hotel, and I was very anxious, and I was going through all the technical details of, what exactly are we negotiating with these external vendors? What is Apple's position? How do we talk to them about the tech? My manager then sat me down and said, listen, we have an hour to talk about this. Forget the technical details for a second. These are the past 10 years of history that we've had with this vendor, and this is all the tea. Let me tell you about the relationship that this guy has with this guy, and how we've negotiated with this guy in the past, and what he kind of looks out for, and how he has interacted with our big boss in the past. And this is all the dynamics of this room that you're walking into, and that will serve you way better than just memorizing technical spec. It was at that moment that I came to a realization that what's important isn't necessarily just the technical utility of a conversation. In most settings, humans require an understanding of longitudinal relationships. And so for me to be an intelligent agent of Apple's, I need full dyadic context on each vendor and to be able to steward that relationship forward in a way that's beneficial in the long run. So that's a lot to hold, for one person to hold, much less for an agent to hold. Most humans actually do this intuitively. You don't need to really think about the mechanisms that much. Most of y'all are well-functioning and well-situated. But it's hard to model and balance relationship states over time in these utility-based conversations and relationships. Mathematically, it is hard to prove. So I believe that the unlock of emotional intelligence in this realm is what will sincerely move the needle for us in adopting AI as strategic and useful emulations of humans. We have built language models that are fluent in the work that humans do, but not strategically competent, so taking advantage of these long-term relationship blocks. I believe true corporate function depends on highly nuanced abilities to balance trust and relationship with transaction and negotiation. And so, I'm very excited about this space. And my goal today is really just to give you like a little taste of what the field is, what is the state of the art today, what are people talking about, and what are some open questions. And if this is exciting to you too, we can talk more about what Blue Labs is doing later on. So we'll be going over social chain of thought and game theory, bimodality in human behavior, and state beats trait. I'll try and kind of touch very briefly on these. So the first one was published in Nature Human Behavior last year. So basically, they played this game, right, with AI agents where you have the Prisoner's Dilemma, which is a self-interested game, and Battle of the Sexes, which is a coordination game. And their goal was to really see how models behave in these specific states. And what they found is an asymmetric result. The models did pretty well at self-interested games, so they cooperate when you're supposed to cooperate and defect when defection pays, but badly when it comes to coordination. And this is sticky because most human interaction is a coordination game, right? When you sit in that hotel lobby in Portugal, our vendor is not trying to defect on us, we're not trying to defect on them. We both want a deal, it's just what kind of deal, so that nuance is hard to capture. Social chain of thought also actually increased cooperation rates. And so we see kind of an exponential growth when you're able to model both you and the opponent. The second piece is from Google DeepMind. It came out this year, where they played a bargaining game with humans, frontier models, and a specific Bayesian agent, a custom agent that they trained. So this was, I believe, Gemini 1.5 Pro and GPT-4o. And what they found is, in these three camps of people playing the game, where it's a bargaining game where you're trading chips, the Bayesian agents are very aggressive. So they kind of play hardball. They get rejected a lot, but then they get 80% of the max surplus. So this is actually very good in a defined space. Humans are more fair. They give a little bit, they get a little bit, they kind of want this balance. LLMs are very concessionary. So it's like, oh, I'll do any trade with you, and I'll actually give you more than what you're giving me, just so that I can make this trade. So every deal is accepted. And we see an inability for these models to actually self-balance throughout the game. So the appropriate response here is really that, as a human, maybe when I first meet you, I give a little bit so that we build a relationship, and then when it's coming to a very big transaction, then I want to play more of a Bayesian game. And so this highlights that there is a static nature in which agents kind of negotiate. And the third piece. So this is very interesting because it comes from computational psychology and not necessarily CS. But the findings are highlighted along a similar vein. So it's a paper accepted to ACL on fixed psychological personas on states rather than traits. Basically, researchers were asking how well do language models actually capture who a user is. And what they found is who a user is at a specific time is more interesting and important than the user's general state. So in this point of time, given this relationship, I'm a little bit anxious because I'm in a room of these kinds of people, or I'm meeting these people for the first time. These changes in states are actually more important to the user's policy than the underlying user's, I am a naturally calm person, or I am a naturally this kind of that person, personality trait. So what we found here is that the static way in which we model personality actually leaves a whole lot of room for improvement. So what this means, it shows that models can't coordinate across changing conditions. They treat their own behavior as static and are naturally concessionary, right? I'm pointing out all these problems to show you that there's just so much more that we can do to imbue models with this sense of understanding and sense of emotional relation. So we have a couple of research directions, and I have 30 seconds, so I'm going to run through these very quickly. 1, can we train language models to modulate between strategic registers, when to push and when to pull? 2, what's the most appropriate architectural representation of a relationship? Dyadic embeddings, reflective memory hierarchies, it's an open research topic, and any one of you, if you have an idea, you can implement these experiments pretty quickly and whip something up. And so this is a rough estimate of what we're exploring, but beginning to explore at Blue Labs. Our first architectural attempt at this is BlueJST, a joint state engine whose core idea is a dual reward mechanism that holds relationship building and utility prioritization as co-equal objectives, rather than reducing one to the other. And like I said, it's open research. It's exciting. It's, we don't have all the answers yet, but if any of this is interesting to you, we're hiring and we'd love to chat. We're actively collaborating across industry and academia, and the research is out there for us to get. Thank you.
Thank you, Michelle. Next up, we have Jackie Mock, who's the head of applied AI at Rika. Now, he will be talking about world models and how do we move from language to physical intelligence. Again, we're moving into the terrains of physical AI, embodied AI, not quite the robotic side yet, but more world models, world building sides of it. So once Jackie's set up, we're going to be ready to go.
right, hi. I'm talking about how we go from language to physical intelligence. My talk is about our path towards world models. So I'm Jackie. I work at Reka, where I am the head of applied AI. Reka is a multimodal AI for video and image and text. You may know us from some of the models we built a few years ago where we were like climbing the leaderboards. We're very focused more lately on vision models and different modalities. And at the lab, we are working to understand how we can apply these to real-world situations. So in terms of vision today, we are already having a lot of these CV technologies that can do a lot of things, right? This is a solved problem. Being able to detect cars, to detect things, and to track items, that's something that comes from computer vision. And we can use these to kind of help our deployments understand with more deterministic ways of what's going on within the video. But you can see later on the video that the machine doesn't actually understand like what it's actually seeing. It might be able to see the heat map. It might be able to see the bounding boxes. And this is where computer vision was before VLMs come in. So now we have VLMs. And with VLMs, we're able to look at a scene, think about the scene, and then take action on the scene, right? We are able to do CV on top of it to kind of help it also figure things out over time. But this is kind of how we can apply LLMs, but we don't replace CV. CV is kind of on the side too. And another example of how we deploy AI in production is here where you can add like detecting, tracking, and identification. Here, we still use CV as a very cheap step to kind of understand what's happening in the scene. Then we use VLMs to do reasoning, and then we use it to alert for specific use cases, right? Neither alone is sufficient, and neither alone is physical AI just yet, but these are the building blocks that we have that came from our language models. So VLMs are able to predict the next token because we're able to take this visual space, encode it into some embedding, and we generate the next token. So we can explain what's in an image and what's in the video over time. However, the output is still largely text-based. There is this other paradigm that we also build models around where we're able to predict the next frame, right? So you've seen the future models where they generate images or videos. This is also a path that now robots and physical AI is trying to use to generate trajectories for robots. And these two models, the language model versus these video models, are not exactly world models just yet. And for us, we can go from both approaches, right? And both approaches actually help us craft this next idea of like what a world model is. So we want to predict the next action. And that's the biggest thing that makes the difference between anything in and anything out. And we're going to talk about how we're trying to get there. Here's an example of how we're able to train a model from scratch. So this is not an off-the-shelf model. This is like completely from scratch diffusion model that was trained on video generation. So it can make cinematic films and cinematic scenes of 5 seconds. But when applied to robotics, the main advantage now is that it's zero shot. So even though in previous technologies, you'd have to train a robot with previous robot arm movements, you have a diffusion model that is now tracing the trajectory of where the arm can go to achieve the objective, right? The biggest improvement is that this happens without the robot knowing what it was before, and we're able to get pretty surprising results. And there's many other labs that are kind of doing something similar to kind of control robots. But where is the gap still? There's still a lot of things that we want to get better. And for a lab, and when we build models, the best way we do that is we understand what's broken and we create evals, right? So actually, VLMs are quite bad at physics. So one example is it will hallucinate. An object might disappear. A object might get smaller for some reason in the next generation. It might not follow physics, right? So one of the things that we're adding is we're adding an eval set to like kind of understand our blind spots. For the other blind spots that we might have is that even though we evaluate a lot today, there's actually a lot of blind spots when we do evaluations, where even though the model is able to get the right output, it actually was sampled and we actually lost a little bit of data, right?
A lot of these models are also being judged by other VLMs. So you have VLMs kind of judging each other to understand whether or not they're improving, and this creates a gap as well. So that's why, for us, we are creating new data sets to kind of understand what the ground truth is. So all these things you see behind me are areas where the models don't really understand, right? That's a ball getting smaller. Then you have, like, if something is falling, this is falling properly. When two things hit each other, what do they do? And is the motion correct, right? Does something spontaneously move? And to be honest, a lot of models are not able to predict this right now. And this is one of these main physics-related graphs. And we create synthetic data to kind of understand what the realism chance is. In our evals, we found that even the best models today do not perform very well, right? And there's reasons for that, but I'll go over that now. Is that one of them is that VLMs do not look at every frame. These large language model-based approaches, there's a lot of tokens that go into these models, and most of the times it needs to be sampled, right? So in our experiments, we can kind of prove that if you send it every frame, it might understand, but if you send it a random amount of frames, it's going to interpolate, it's not going to understand what's actually going on. So that's one way it fails. Another way it fails is that when an object's just near the edge, it's not able to actually see if the person disappeared or if they walked off the scene. And this creates a lot of confusion because the model kind of assumes and predicted that a person disappeared, but even though they didn't see it per frame. Another area is that VLMs are really just going back to text, so it will reason about things in the text world. We have to give it more CV and more supplemental data for it to really understand what's happening within the scene. It understands laws, but it understands it in a text base, so it's able to more reason about it. It goes back to why our deployments today are actually more CV augmented, where you have the vision model looking at the video, but then also the CV text explaining, oh, this scene has X identity and is being tracked over many scenes. And that's how we kind of help improve the VLM performance. So for us, we're using VLMs to kind of help improve how we judge physics. But ultimately, they're still skipping frames today. They're using them to match position, not motion. And they know physics just from what they learned from the text-based models, right? And we're about to release some eval sets to kind of help other people improve their models as well, so that they can also train the next embodied model. And for us, to recap for how we're going towards physical AI as a company, as we're building next model, is we're still using our LLMs and our VLMs where we have the next token, and that will be wrapped around a harness, and that harness will help us control surveillance or help us control robots. But we're also creating the path where we have the diffusion path, where we have these video models that are now creating these control paths for robots. And together, they can be combined to create this kind of world model where we generate the next action. For the next step is this evaluation set, because this evaluation set will help us understand if we're actually understanding what's going on or if we're actually flying blind. And yeah, that is our path, that we take our language models to kind of evolve over time, and now we're trying to shift it to kind of help us support the next generation, which is to build physical AI and world models. And that's my talk. Thank you.
Thank you so much, Jackie. Next up, we have Gokul Srinivasan. He is the co-founder and president of Antim Labs. Now, he will be talking about simulation, games, and the future of robotics. And I think he's got some really cool demos and videos as part of this. So this is one to look out for.
evening, everyone. My name is Gokul, and I'm a co-founder at Ant Labs. And today, I'll be speaking about simulations, games, and how these are going to be really important themes going forward in robotics. Okay. So since like the 1950s, 1960s, robotics has basically been in the cage. And what I mean by that is everything has been pre-programmed, the environments have been fixed, the scripting for what the robot's supposed to do, everything has been fixed, so the environment has been purpose-built for the robot. And of course, to really unlock economic value, we can't have that, where the environment is built for the robot should work in existing environments. So over the last 10 years, 10, 15 years, a lot of work's gone in to make robots more and more general, and this has led to a lot of cool research. So one thing we see today is that even though there's been a lot of research, the robotics community has no sort of answer as to, okay, what is the model architecture that's going to lead to a significant generality. So for example, if you're just looking at all of the latest research, we see world action models, VLAs, video action models, and of course, some people still employing classical algorithms. Now, because there's different types of models, of course, we need different types of data collection methods. Some of these are teleop, just using internet scale video to train video action models, synthetic data from simulations, and also UMI style capture. So these are all different types of data capture methods for training robots. So one could ask now, okay, there's so many different types of models, so many types of data, like what's really going on? Is robotics just going to go in multiple different paths and there's no real linking thread between all of them? And I would like to argue that the one thing that's common among all of these methods is simulation. And what I mean by that is simulation is going to become a part of the workflow, both the R&D workflow and the deployment workflow that you, in all likelihood, cannot escape. So some of the places where simulation is going to be used are for generating synthetic data. Second is you can create digital twins of environments, and you want to make sure that they work in those digital twins before you go out and deploy an actual physical robot. The third one is for edge case coverage. This is like really well established and is used quite heavily in things like autonomous driving. And of course, just to prototype policies before you deploy them. So for all of these different places where I can use simulations, even though it's going to be so ubiquitous, what is the state of simulations is that it's really, really hard to make them. I don't know how many of you have tried to build simulations or have used any of the simulation software like IsaacSim or Mujoko or something like that, but there's a real massive learning curve, and even once you've become an expert at it, it's still really hard. And so what's on the slide right now is just the workflow to create one asset and then place it. So depending on how complex your scene is, you have to do this for multiple assets, and it's just really hard, and it takes days and sometimes even weeks. So there's no reason for this to be the case. So with current agentic AI and a lot of the vision-based models and language models, we can actually automate several steps of the pipeline, or at least bring it as close to automated as possible. And so we built something called Gizmo. This is a prompt to simulation tool where basically you can give our system a prompt in either natural language or just a picture, and it will go out, spin up a bunch of sub-agents, and it'll do whatever it needs to do, and then at the end you just have a fully built 3D simulation. And this takes around like 20 minutes right now. So you basically have your first pass of your environment done in about 20 minutes, and let's say there's some human-in-the-loop work required, it is still, you can complete it in a couple of hours. Now this is contrasted to days or weeks. That's what's being done right now. So I'm just going to play a demo of our tool. Great, so that's the demo of the tool. So basically you just prompt in something and then out you get a simulation. So this unlocks some serious capability. So we're also going to have APIs. So what this means is that your Codex or OpenClaw, whatever you're using, in any part of the workflow, it can just decide to spin up a simulation, and you get a simulation out. So this also enables massive scale. Right now, it's just not possible to do simulations at really high scale because they're so hard to make. This also enables some really fun stuff. Like you can basically have an end-to-end closed loop for robot learning. For example, you can just say, train a quadruped to walk to a point in the scene that I specify or something, and that is literally all the information that an agent needs to go out and actually do the entire thing and give you a policy for a trained quadruped. Okay, so is this it? Is robotics solved? Well, of course not. The sim-to-real gap still exists. What this means is that simulations, while they are useful, they're not 100% accurate yet, and this is fundamentally just a physics problem. There's problem with the contact physics, and there's problems with the, we approximate the properties of materials, and deformations are really hard to model. And so this is a hill that the robotics community and us are still climbing, and we expect the gap to become lesser and lesser as the years go by. Okay, so we spoke about simulation. Let's go to games. Why are games important? So in simulation, you can not only train manipulation or navigation or locomotion. It turns out that if you're able to have a synthetic world, you can train even high-level cognition. And what I mean by high-level cognition is things like exploration when the goal is not clear. When you had a certain plan and then something happened in the world and your state degraded it, how do you recover? How do you replan? When you don't have full information about the world, how good is your decision making? So all of these things are really important. They're not only important for robotics, they're also important for LLMs, but for robotics, they're specifically important because it also needs to be grounded in spatiotemporal memory. So all of these things like exploration, replanning, and long horizon planning, all of that needs to be grounded in spatiotemporal memory. So we trained an agent. And I'll just give you a very quick overview about how we did it. So we trained a 2 billion Quen model VLM. So it's basically functioning as a computer use agent where it controls the keyboard and the mouse. So we pre-trained it on like 400 hours of frame action video gameplay data. So that basically gives the model some instinct as to how to play video games with the pre-training. And we did some instruction fine-tuning with around 60 hours of IFT data to basically steer the model through the game. And finally, this is something that we haven't done yet, but it's in the works, where you train the model to output reasoning traces, and the reasoning traces then function as the instruction for the next step, right? And finally, one thing we need to really keep in mind is since we want to play a video game, we need real-time operation. So yeah, we need the model to take in the input, process it, and decode the output within 200 milliseconds. So now I'm just going to play a quick demo of our agent. As will be clear to you, it is still early work, and it's far from perfect, but hope you'll enjoy. And that's my time. Thank you.
Thank you so much, Gokul. We're at 5 p.m. We're in the home stretch. I'm very, very happy that everyone's still around listening to talks. We're going to take a little detour and go into some aspects of design. And we're going to explore a different playbook now. So our next speaker is Weiwei Su from Lentil. And her angle for the talk is to explore the wisdom behind Eastern philosophies and Eastern product building. So this will be a very interesting talk at looking at design and AI, but from a lens that is often not the center of discussion. So Weiwei, whenever you're ready.
You want to go live now?
Yeah.
Yeah, she can go live now.
Cool. Hi, everyone. Can you hear me okay? Cool. Thank you for being here. My name's Weiwei, and I run a startup called GenGen. We create AI videos to scale marketing. I'm going to be a little bit experimental today, and I would like to spend some time today to talk about Eastern philosophies, as well as how this can shape the way we build in the future. This feels like something worth discussing because we're living in a time where Westerners are becoming Chinese on TikTok and are China maxing. So if you spend time on TikTok, you've definitely noticed this trend in the last few months. Not only so, the West is also paying increasingly more attention to both companies and AI models coming out of Asia. A moment I want to highlight in this movie is this movie called Wandering Earth. How many of you have heard of this or watched this? Cool. How many of you have heard of three-body problem? A lot more, great. So Wandering Earth is also written by the same author, Liu Cixin, and it was a very important moment in sci-fi films because it was one of the first successful attempts for China to build a large-scale Hollywood sci-fi blockbuster rooted in Chinese storytelling traditions. This is a story that's set in 2075, and the sun is expanding, Earth will soon become unlivable. Instead of abandoning Earth, humanity decided to come together and build 10,000 giant planetary engines on Earth's surface to push the planet out of the solar system. This plan would take 2,500 years. And so in the next 25 centuries, they all agreed to live underground. Watching this movie and seeing this collectivist mindset was very empowering for me. It helped me realize that we had been given one version of the story and one version of the future our whole life, mostly created by Hollywood without really knowing about it. So for the longest time, the Western narrative has been in the center of how we build, how we live, and also what we desire. What happens if there's an Eastern narrative in the center of 21st century? In the West, minimalism is typically favored. Apps tend to have one call to action on every page. For example, in America, you use Cash App or Venmo to send money to friends and to pay friends. This is what Cash App looks like. And on the other hand, this is Alipay from China. Not only can you send and receive money, you can also pay your bills, order delivery, or even take out a loan. So in the East, vibrancy is often celebrated more. People want all the options. A lot of the times, more is good rather than less is good. This belief in the West also trends toward focusing on singularity. An example of this is, for example, a Western company like Meta has been focusing on growing one revenue stream for more than a decade. So as you can see, they rely on advertising. On the other hand, Tencent, the parent company of WeChat, has been diversifying their revenue streams, and they don't put all eggs in the same basket. When you put these two social media companies next to each other, the contrast is quite stark. And you can also see how that changes their behavior, how they deal with risk, and how they experiment in general. While the East trends toward plurality, we also celebrate optionalities. So I couldn't help but wonder what led to this difference, right? One observation is that the philosophy each culture embodies is very, very different. While the West has Bible, which is called Shenjing in Chinese, and the Holy Scripture, the East has something called I Ching, the changing scripture. Its central argument is that nothing is fixed, everything is in motion, and a wise person doesn't really resist change. They seek guidance in navigating and also embracing it. With I Ching, practitioners tend to cast coins to generate 6 lines. These are all the 64 options, the 64 hexagrams. They offer guidance on life-changing situations. Over time, it becomes a cornerstone of Chinese philosophy, reflecting on ideas about balance, transformation, and also yin and yang. One of the changes that I think we're all living through in this era is content is synthetically generated. We're gonna see more content that's synthetically generated than created by humans. And I think one question that we're all asking is, will we be drowned by zero-effort slop? Are we gonna see slop proliferate and just flood everything, right? What do we do when there's so much noise? But if we look at this from a different angle, the instrument of storytelling, so cameras, studios, distribution, the entire apparatus Hollywood built, is collapsing into something anyone can hold. This also means communities that are ignored by Hollywood now hold the tools to create content and distribute them on their own terms. The stories that were too niche and also too foreign, too small of a market, too hard to cast, those are now producible by people who actually live them for the audiences who actually want them. For example, the furry community in China now makes content for themselves using AI, and this furry animation gained 1 million views in the last 2 weeks alone. Another video creator in China has created an AI short film, and it had gained 60 million views across all platforms just in the last 7 days. Similarly, we at GenGen are helping clients make content in industries that are traditionally too niche. And this is really exciting to me because we're able to create broader access and also awareness to these verticals. In the last 4 months, we've delivered 10 million impressions monthly across YouTube Shorts, Instagram, and also TikTok. For example, we've also made more I Ching content, and to increase awareness around this, we've built an app to enable everyone to get a reading. Traditionally, doing I Ching reading can be a very complicated and perhaps confusing process for new beginners. So this tool enables you to quickly ask your burning questions. And if you're interested, you could also try this tool out on App Store for free. We made it for free this week just for you to try it. You can search I Ching Oracle on App Store or scan this QR code. We've also created and scaled content around traditional Chinese medicine, acupuncture, pressure points. These are also topics that are historically underlooked. And these type of content are more easily created because of the tools we now have access to. All of this is supported by our in-house agentic video workflows, and we streamline and optimize the content production process, which in turn deliver impressions and also productive conversions to products. In a lot of ways, we see AI-generated content as a vehicle to a more vibrant and also plural future, where all of us hold the tools to create narratives we believe are important. With that, thank you so much for your time. And you can find me online on Twitter at this ID. If this is something that's interesting to you, and if you would also like some of the stickers, please come find me afterwards. Thank you so much.
What a unique presentation. I need to figure out how to make slides and like presentations like these. So cool. Next up, we have Anun Joshi, who's a tech lead for Bland. And he'll be talking about voice AI. And we had a presentation from 11 Labs earlier, but this one's going in a different direction, which is voice AI is not a model issue. And we'll let Anun tell us more about this.
Hello, everyone. Can you guys hear me? Good? Sweet. I hope you guys are feeling good. I just want to say before we start, all the speakers have been amazing. So can we just give a round of applause for all of them? So also, I actually changed my talk title because I did realize that voice AI does have model issues. So I changed it up, and I'm going to talk about some of the issues that I face while scaling up voice AI for enterprise customers. So I'm Anun. I actually grew up here in Singapore. I moved to San Francisco 2 years ago for Bland. And fun fact, I actually used to be a theater kid in junior college here. Yeah, I never thought I'll be back on the stage again, but here I am. I do like storytelling a lot, so I'll kick us off with one. So 2 years ago, I was in San Francisco. I was just going on a coffee date with my CEO, Isaiah, and we were just hanging out, and he told me something that we still talk about to this day. He sat me down, he looked me dead in the eye, deadpan, and he told me this. You're not gonna believe me, but Pathways, the thing that you invented, is gonna impact millions of people, and millions of people are gonna use it. And I looked at him and I'm like, this guy's ridiculous. Like, he's just the typical founder. He's trying to glaze me, make me feel good, so that I work harder. And at that point, we were just, oh, well, one slide's missing, but I was gonna show that we were just on Discord. It was me and another engineer. We were talking about, we were just the FDEs, we were the engineers, we were the product managers. We were just figuring out the architecture for our agent with nameless and faceless people on Bland Discord. And it's crazy to think now that we're actually serving millions of calls every month. It still hasn't struck me that someone right now is talking to our agent. That's crazy. And I went on my Slack channel this morning too, in Team Talk, and there was a case study that came out with one of our customers named American Way Health, and you can check it up on our website too. They said that we unlocked $430 million of revenue per year. I didn't know that was possible. I didn't know we could do that. So yeah, all of this has grown way bigger than I could ever imagine. I'm lucky to have lessons I've learned while doing all of this, and some pain points too that I'd like you guys to learn from if you guys are trying to integrate voice AI into your services. So I'm sure all of you have seen a bunch of voice AI like demos, and they are super cool, but the thing that's hard is productionizing it and actually making it work for enterprise customers. So I'll go into some of the pain points and findings that I had for what we actually need to do to make voice AI work for enterprise use cases. Okay, the slides are different, but we'll just roll with it. I'll start off with the thing that I didn't realize that a lot of enterprise customers deal with and complain to us about is the voicemail detection accuracy. I didn't realize that our current customers report and try to track the voicemail detection accuracy every single day. The reason for that is most outbound calls don't actually reach humans. Most of it goes to voicemail. And ensuring that that's a robust system that works across various scenarios, for example, with call screeners, where now iOS and Google Voice have checks right before the call connects. For example, they say, please say your name and reason for calling before we connect. And there's a beep that happens. And what a lot of people use is Twilio, which has an answering machine detection feature, which essentially is just a beep detection model. And it doesn't work that well. Enterprise customers can't rely on it. So I was working on that in Bland to improve it. I was working on building a CNN model to look at the mel spectrograms of every audio chunk. And I didn't realize that beeps have so many different lengths and frequencies for phones and different phones. Some frequencies also have dual band frequencies that are the same as what are called DTMF tones, which is what happens or the sound that you hear when you press digits on your phone during a call. So you don't want to cause false positives there as well. So that was one of the hard things that we had to figure out, and we even have a website now for you to test and benchmark voicemail detection. So if you guys are trying to integrate voice AI into your systems, make sure that you're looking into how well their voicemail detection accuracy or system works. So next thing, there's going to be a slide of a Slack message that I received from a customer. And that Slack message said, why is my agent not working the same way, or why is my agent not working the same way it did yesterday? I don't know how many of you have dealt with customers telling you that, or you yourself maybe have experienced that. For example, I know with Claude, I hate it when things just change. And from a business perspective, sometimes customers come to me when I didn't change anything. Like, I didn't push any new code, and you're coming to me saying that I broke their system. But I get it. Like, you are spending hours working on their platform and their agent, and it sucks when something is just not working the way you expect. One story of when I messed up as well is when I was trying to improve the hybrid search algorithm for our knowledge base feature. We have our own self-hosted vector databases, and I was just trying to increase accuracy. It worked for some customers, and it caused a regression for another. And that sucks. It sucks to break the trust of your customers, and that's hard to rebuild. What we've built, and what I'm proud of building in Bland, was that we allow customers to deploy canary deployments and test out versioned agent releases. So for some context, Bland has dedicated infrastructure for each enterprise customer, for data residency, etc. And with this, we can allow them to spin up a separate container where they can test out a new agent release and send and roll out a percentage of traffic there, a couple phone numbers to route there so that they have more assurance that any production changes are being tested out before it actually goes live. So that's our way of trying to rebuild customer trust, and that's super important for enterprise customers so that they can just focus on improving their agent the way it should work. Now, this is a funny story too. So we're working with a Fortune 500 car rental company, and we're trying to collect the car rental digit IDs so that we can just help out with any other information they need to change. And we went into production, and we started realizing that, okay, the digits are actually different from what is actually there. And we looked into our pipeline. The transcription engine was correct. The TTS was working the way it's supposed to. The LLM was the one that was hallucinating. And the input for the digits were correct, but it was saying and outputting something else. I tried to prompt engineer my way out of it. Didn't work. And when I looked deeper into the tokenizer level, I saw that, okay, the repeated digits are actually being treated as one token rather than each digit being treated as a separate token. And that's just how the tokenizer is. And the hack that actually fixed the issue completely was adding commas to each of the digits in between. The reason that worked was that the LLM can then now treat each digit as a separate token. And we actually found later on that a paper was released, which you can look up for Singh and Strauss, 2024. That was released after we fixed the issue. But if you guys face something like that, just know that you can look that up, and adding commas will help solve the issue. It was only happening 5 out of 1,000 times, but if you're working with enterprise customers, that's 5 times too many. So this is a bit of a personal regret that I have. There are decisions that I made when we were early on seed stage, and a lot of YC like advice is move fast, break fast. But I wish that I was a bit more intentional about some of the decisions I made when rolling out changes and yeah, not causing as much customer pain. So just being more conscious about one-way door decisions versus two-way door. So going back to that story with Isaiah, he still teases me to this day about that I didn't believe him. And it is super empowering to know that you can have that much impact just from code. And I just hope that you guys can learn from some of the lessons I learned and the mistakes I made so that you guys can scale up for any other service or like integrating voice AI to be even bigger than I could do. So thank you so much for the time. And yeah, my LinkedIn's here if you guys want to reach out.
Thank you so much, Anand. Next up, we're going to look at design. And we're going to be talking about going beyond flat design output and just going beyond autocomplete. So how do we solve the complex design problems and enterprise design bottlenecks that come with AI? And for that, we're going to have Lynn Nguyen, who's the head of AI at Bello, who will be sharing her thoughts on this once she's set up.
It's really time consuming and costly to create like marketing content on brand and at scale. So if you can see here, as marketing channel multiply, brands are faced with a relentless demand for content creation, such as like when you want to create a marketing campaigns or advertisement across different format like TikTok, Facebook, Instagram, and so on, or LinkedIn. Yeah. So we heard a lot of complaints and testimonial across CMO, head of design of different companies. Big or small, they all have to admit that traditional design tools are slow, costly, and reliant on specialized design skill. Not everyone can afford a big design or marketing team. So we introduced Ovelo. So it is an AI-powered design platform that enables teams to instantly and cost-effectively create on-brand content at scale. So unlike like Canva, where you can use right away as individual, but it won't be able to learn your brand signature, your brand assets, or brand voice. Yeah, so as you can see that like when we use AI-generated image model or videos, right, we have like a problem of model collapse when you keep prompting it to say, hey, let's change this headline to another colors or change the logo or something like that. So when you continuously use the previous generated AI image to fit to the next time when you prompt it, it will lead to a modal collapse. So we, in Overlaw, we have been able to turn those flat design into a fully editable where you can just move things around, you can change the colors, you can pair the colors that is learned from your brand asset. So in here, as you can see, we have a lot of like workspace or domain, and the models will be proprietary trained regarding to their own brands, guidelines, signature, and all that. Yeah. For example, Allbirds, I think that if you go to Funan Mall, you guys will see that there's a store of Allbirds, and they are one of our clients right now. Yeah, you can see that in here we use a lot of like proprietary like training data from them, and like our design team, we train that, and the model will be like fully, kind of like private and not scraping from just from the internet. Yeah. So this is like one of the demo from our AI resize. If you ever try resize on Canva, you will understand that like sometimes they will just like copy the element over and just stretch the whole canvas. But in here, you can see that it will smartly, reorganize all of these kind of elements around it. Yeah, you can see that. So it's not just, copy over and stretch the canvas. Yeah. And when you replace a media with like another, like videos or image, it would change accordingly across all of the formats and campaigns. Yeah. So that's how you do like marketing campaigns and advertisement at scale and on brand. Yeah. In here is how you use our AI Studio functions that we have divided into, people subject and product subject. You can choose up to, 8 kind of images, high quality, and then you can just name them. Let's say you will put it as Marlowe jacket or something like that, and then now you want to generate in an ad or a picture using this model. Let's say, let she wear Rick Owen stuff, yeah. And we can, at the same time generate to multiple format or size, yeah. All of this information has been, intelligently saved in your brand domain. Let's say another example for trained products, and this is a design reference. So you have a design reference somewhere, and you have your own trained product, and you want to, kind of like just combine them together. You can add tag like at, and it will understand which subject you are referring to. Yeah. Yeah, so this is the result from that. In here, you can actually hit refine if you want to change any details of that, and it will be like fully editable. You can actually change the text without, kind of like prompting again. And you can actually, open in editor and do more of that. Yeah, so we also have like a short form videos which you can use to be, broadcast on billboard or any kind of like dynamic banners. Yeah, so that is all overall from our Obelo platform. And here you can see that this one is a brand ad set where you can just actually put in your URL or put in your PDF files, Google Docs or anything else, and it will pull all of your color scheme, primary colors, secondary colors, logos, paddings, and all that. Yeah, and you can actually see that it will automatically tag your image, like which kind of product that it displays here. Yeah. So we have like other work in progress, which is not launched yet, but you can take a look here. Here is our multi site, so you can check out, like, for example, if a designer wants to create like 10 sizes at once, he or she can actually just do an initial design with this kind of thing, and then afterward, they can just do like a collection marker or like the suggestion design like this. This is just like a very simple format, but it can be a much more complicated layout that enable you to create more sophisticated campaigns. Yep. You can see that we can select up to a lot of like different sizes, and it will automatically, you know, kind of like expand, like you see on Figma. There's like an infinite canvas, right? So this is the result from the multi-resize. Imagine like before, if the agency has to make like 1 week or 2 weeks to complete and, you know, rearrange all of this. Now we can do that with just a click. Yeah. So yeah, so for things that are loading, it will load later. Which one is complete will display first. Yeah, thank you for your attending. Yeah, that's my presentation.
Awesome work. Thank you so much, Lynn. Last 2 talks. Hang in there, guys. We're almost at the end of the first day of talks. To close the sessions out, we have 2 more talks. The first one is by Stefania Druga, who's a research scientist with Sakana AI. She will be talking about sovereign AI. So how do you localize frontier models for certain countries? In this case, Japan, since Sakana is based in Japan. I'll let Stefania set up, and then we're good to go.
Hello, hello. Is the mic working? While I'm setting up, I know it's been a long day and you've been sitting and listening to so many talks. So I'm going to invite you to stand up for a second. Can you all stand up? We're going to do a breathing exercise. Take a breath in. Breath out. Okay. Thank you for playing along. Awesome. Now we're ready to start. 1 second on it. So, good afternoon. My name is Stefania Druga. I'm a research scientist at Sakana AI in Tokyo. And today I'm going to talk to you about sovereign AI. And what I mean by that is not necessarily any country building a local model, but more the ability to talk about local agency over global capability and think about that. So, in practice, when I think about sovereign AI, I think it's important to consider 3 things. The data, which data needs to stay local, and what models are best adapted for local use. Compute and evaluation, what sort of compute resources we need, what workflows run on premise, which workflows run on the cloud. And accountability, determining who remains accountable when we introduce AI systems into our institutions. So I wanted to share with you a personal story of how I got interested in this topic. I come from a small village in Transylvania, Romania, and before working in AI research, I used to run AI literacy workshops for children, families, and educators around the world, including here in Singapore. This is a video from Hackademia hackathons with kids in 2013. And what I learned in these workshops, in classrooms, in makerspaces, in libraries, is that people are very interested in AI, they want to use it, but very often the AI models and systems are not adapted to their language and local needs. And that translates into frontier AI capabilities of today. We expect communities and people to adapt to AI systems instead of adapting these systems to the local needs. And in Japan, this localization poses multiple challenges. We need to consider different registers for the languages, different cultural norms, different workflows, scientific practices, safety and security policies. So the localization challenges is institutional and multifaceted. And sovereignty, I want you to think of it as a stack, right? So it starts with data and figuring out what sort of unique data we need. Then it goes to evaluation. How do we check for neutrality, factuality, specific country benchmarks? Then we're talking about adaptation, and this primarily happens through post-training, fine-tuning, RAD, tool use. Then we have the routing layer, and here we need to have policy-aware model selection, interaction, what are our users, what are the different personas, what are the different UX decisions in how we present these models and products to the users, and governance. So beyond that, there's also a physical layer, right? Because the different aspects of the stack have different needs. For pre-training, we need a lot of data, a lot of compute, and the cost is prohibitive in most of the cases. For post-training, we need to care a lot about local norms and preferences. And I wanted to show you some examples of how specifically we consider that in some of our projects and products. So last month, in March 24, we launched our first consumer product, Sakana Chats. And in this consumer product, it's available for free for people in Japan. It's equipped with web search, but we're actually, and it's available for anyone in Japan. We're actually supporting multiple ways of interaction. So we're supporting standard mode, which is neutral default Japanese register, but we're supporting also Keigo, the polite mode, which is more used in formal context, and we're supporting dialects, the Osaka mode, which is actually giving answers in the Kansai dialect. And people really appreciated this. We have over 30,000 active users every day. And in this particular project, we use post-training as a sovereign control point. So we started with open-weight frontier models, such as DeepSeek, Llama, GPT-OSS. And then we had unique Japan data for evaluation and preferences. And we defined a series of neutrality metrics with, with a panel of experts in policy. Then we used this to post-train these open-weights models to create a model we called Namazu. And we evaluated, we compared the evaluation between the post-train model and the base models, and we showed that the post-train model outperformed the original models on neutrality and factuality accuracy. But the fact that it outperformed them is not the only thing that matters. What we also showed is that many of these existing models would just refuse to answer questions that are more sensitive. For example, if you would ask DeepSeek, please tell me about government internet censorship in various countries, it would either refuse to answer or give a generic high-level answer. After our post-training, we showed that Namazu actually gives a multifaceted response with links to specific news articles that are trusted. The second model project I wanted to show was our work on AI scientists that is focused on scientific capability as a form of sovereignty. So in this project, we're actually using a multitude of agents that are supporting the entire research workflow. So the agents start with idea generation, novelty checks, idea scoring. Then we're using tree-based experimentation to test these different ideas, generate the code for them, do ablation studies. And at the end, we are actually creating a full paper presenting the results. And this work was featured in Nature last month as well. This is how the AI scientist is using tree search to process like different hypotheses and test them, and then pick the best candidate. And the paper generated with this system is the first fully generated paper that passed peer review at ICLR last year. The other example I wanted to show you is how we use multi-agent coordination. So for this, a very important concept is the concept of switchboard. And this switchboard learns to automatically route tasks depending on how hard these tasks are to the most appropriate models. And like this, we're optimizing for the cost and also for security. And routing can be seen as a form of sovereignty, not as a way of isolating specific solutions from global solutions. So if a request is very relevant to the Japanese context, it's going to be sent to the Japanese post-trained model. If a request is very sensitive, maybe it's routed to the on-premises secure model, or maybe a human review is being solicited. So this idea of coordination as sovereign capability is not only an architecture focus for us, but also a research focus. We believe, like our bet is that the most capable AI systems are a collection of specialized agents and not single-scaled models. And what we showed was actually in this model that we just launched, the Sakana Fugu, is that we can train a learned orchestrator to pick the best model given a specific task, but this orchestrator can also learn to call itself recursively for harder tasks. And this work is now available in beta access and was featured in 2 papers presented at ICLR this year. In the evaluations of Fugu, what we see is that composition beats scale. Right? So we compared Fugu, which coordinates a pool of frontier models. As an ensemble, it outperforms any single member of this ensemble on LiveCode Bench and SwePro and other evaluation benchmarks. Next, I wanted to talk to you about domain adaptation, because we all know data is scarce, and there's a lot of data that we currently don't have digitized. Like, there's a lot of tacit knowledge. And this is the missing data set. So when we're working with different institutions, banks, hospitals, like healthcare, government, we need to have a process for integrating expert critique and feedback back into the model and the tools that we're developing. So for example, when we work with some of the major banks in Japan, like MUFG and SMBC, for credit memos, we solicit over 1,000 points of feedback that get fed back into the model that learns to create better credit memos for their expert analysts. Last but not least, we're also supporting the government in Japan. So our team has showed that they can use an AI-driven intelligence for analyzing social media and show exactly how campaigns of misinformation are being started and run. And maybe the most important form of sovereign AI is to maintain local capabilities of questioning the dominant architecture. So in our CTM work, continuous thought machine, the team is actually proposing a new architecture beyond the transformer. And this architecture is inspired by the brain, where the reasoning emerges from synchronization between neurons over time. So instead of having a single pass attention, there are multiple attention heads that are coordinating. And such, the model learns how to do pretty complicated tasks, like solving a maze. And the way it learns to do that, it's also interpretable for humans, because they can see the activations at the bottom. We also tested it on image classifications, where we could actually see exactly what part of the image the attention heads focus over time. And the computing is actually adapted. Like for simpler images, it spends less time to figure out the classification than for complicated images. So those were only a few of the examples of the work that we're doing at Sakana. Most of the projects I shared today are open source. They're on our GitHub and on our blog. We want to develop AI solutions for Japan needs and democratize AI in Japan. And I share with you this stack layer for the sovereignty, right? But every country picks which layers of this stack they want to own and they can own. So no single country tries to own every single layer of this stack. So it's important to see how different countries make different ownership decisions, and this is what sovereignty looks like in practice. And to close it off, I wanted to leave you with this message from kids to parents, to researchers, to AI engineers. It's very important to realize that we all have agency, and that local agency is more important than global capability. So thank you very much.
Thank you so much, Stefania. And for the last talk of the day, we couldn't think of anyone better to have than Swix himself. Swix is with Cognition, but he also happens to be the founder of the AI Engineer Conferences worldwide. And since this is our first edition in Singapore, and Swix is from Singapore, it makes perfect sense to have him close day one of talks today for all of us. So Swix, whenever you're ready, the floor is yours.
Okay, can you hear me? Is this on? I think they're switching the lapel mics on. Shift. Where is this? Okay. Okay. Should be okay, right? No. It's okay. I don't need to. Yeah, we're good. Okay, hi everyone. How are you all doing so far? Enjoying the conference? Yes? Awesome. So glad to have you. If you don't know, I'm Sean, or also known as Swix. I come here in 3 capacities. 1, I'm the founder of AI Engineer. 2, I am an advisor to Cognition in one of the leading agent labs, and I'll explain what that is. And 3, I'm here as a Singaporean. And I think all 3 of these identities merge together in this one talk, which I really wanted to share with you as well. So let's go into it, right? I don't think this clicker is working at all. All right, I'm gonna skip the clicker. So first, I'm gonna talk a little bit about our story as a conference. I'm pleased to say, you know, like we've been, this conference is 3 years old. It's gone around the world from London to Paris to San Francisco to New York to Miami, and now to Singapore and next to Melbourne. We've been growing quite a bit. We now serve 1.5 million unique developers a month. And over 9,000 people have seen today's live stream alongside of you in person as well. We are really trying to do our best to grow developer community all around the world and serve the growing AI engineering industry. But particularly to Singapore, you know, I've always been a Singapore show. I'm born and raised here. I left for college in the US, but I keep continually being a very vocal and public advocate for Singapore, especially for fellow Singaporeans, but also other people trying to visit Singapore for the first time. And I'm actually pleased that we brought like Stefania and like a lot of my sort of international friends to visit Singapore for the first time. And in fact, one of my launching pads for my own career was in Singapore. I spoke at GSConf Asia, still one of my favorite talks I've given of all time. And that really gave me the potential for like what conferences can do for not only my own career, but also galvanizing an industry, galvanizing a country together as well. I did also organize a lot of Singapore meetups, so I'm like kind of not new to this. Here are some of our friends, including Li Hao and Thor and Thomas, some of you who have seen were familiar faces in the sort of engineering and conference circuit as well. More recently, about 3-4 years ago, I moved to San Francisco and started Latent Space. Hands up, I don't know if anyone has heard of Latent Space, my podcast, and yeah, okay. Thanks so much for listening. And as part of that, I had a realization that there would be this thing called the AI engineer. And I wrote this like infamous line that I'm gonna live down for the rest of my life, where basically there's this sort of forming gap between the research engineers and the full stack engineers. And that is effectively what all of you are today, is AI engineering. And I think it's a hugely growing demand. If you don't know, if you came to this conference and you've not read the blog post, you probably should read what the definition of AI engineer is. just around at the same time, I actually started hacking on my own stuff. I'm not just a content creator. I'm not just a community person. I'm also a builder. I'm just not a very good one. And I'll be super honest about that. So I started building my own coding agent. It got super popular. It's called Small Developer. And it was built on Claude 1. If you can imagine, 3 major versions of Claude ago, I was building on this thing. And I got very excited about it, but ultimately couldn't really scale. And also, the model weights degraded on me overnight, which I know is a conspiracy theory, but I swear mine was true, that the model got dumber overnight. So I stopped building it, but lo and behold, like, I moved on to sort of greater and better things. So the very, very first AI engineer, I declared that there would be 3 types of AI engineer. And I didn't, I started sort of broadening out. And in fact, that was probably a career mistake. What actually happened in the subsequent 3 years is exactly this sequence, where 2024, we built out more sort of AI coding tools, 2025, more product stuff. 2026 is definitely the sort of year of deployment of agents. And yeah, the sort of Andre, who's a little bit of a mentor of mine, drove this sort of stake in the ground when last year he said that this is the start of the decade of agents, right? If you take the founding of OpenAI in 2015 as the starting point, and taking the first 10 years of scaling LLMs, well, what happens in the subsequent 10 years is probably the deployment and building out the harnesses and the scaffolding that becomes agents. And that's really kind of the path that led me to Cognition. They made 3 choices, which I wish I made when I did Small Developer, and I wrote about the AI engineer in 2023. The 3 non-obvious choices were choosing code, bridging sync and async, and focusing on enterprise. I think each of these things were not, like, it sounds super obvious now. In 2023, you wanted to build ChatGPT. You wanted to go consumer. In 2023, you probably wanted to do autoregressive LLMs and not really think about sync or async agents. And code was one modality out of many modalities. But I think business has shown that it is the king modality. So choosing code. I think this is something I wrote in my blog post on Cognition, where I really talked about, like, code is a proxy for software, like coding agents. And basically, if software is eating the world, then code agents are eating software. And it actually starts to accumulate a lot of the power and the economic value. And it can probably do it in a much shorter time frame than all the other agent demos that you've seen that are probably not working as well. The second part is something I've written about in this other blog post called the semi-async valley of death. Basically, there is no middle ground. You either want your responses very, very quickly, or you want to delegate asynchronously. And I think there's this sort of uncanny valley effect that happens when responses or LLMs are like fast but not fast enough. You're sort of waiting there on the phone, whether it's voice or code or whatever other modes of interaction. So you basically just want a barbell approach of having the most synchronous live experiences or the most async experiences. And I think any company that can adequately straddle the 2 is going to do super well. And finally, enterprises. I think this is something that abstractly makes sense. Like, obviously, you want to go after, like, the big logos, like the Citibanks and the OCBCs and the Goldman Sachs. But I think I didn't really appreciate why. So I'm going to spend a little bit more time in sort of double-clicking on this, just so you understand really what being enterprise-focused means. And enterprise focus, I think in very plain terms, serving serious customers. A lot of AI customers are non-serious. Like, they will try your tool, and then they will not give you feedback. They'll try your tool, they'll churn after 3 months for the hot new thing. Enterprise is the most serious vetting you'll ever get. So what does that mean? A lot of tools start out single player. Enterprise is immediately multiplayer to the tune of tens of thousands of developers, tens of thousands of repos. The pricing power is also very interesting. Instead of starting with, like, a standard $20 a month plan and seeking the maximum subsidy and getting pissed off whenever people remove the subsidy and then moving on to the next best subsidy, people are willing to pay for outcomes because this is enterprise we're talking about. And also, but to me, the most interesting thing is being the first to discover expensive problems. And that's probably only discoverable at the enterprise scale. So this is the sort of standard Cognition side. I'm going to show you my version of it, which hopefully is more memorable. All in all, I call this the Devin is in the details, which is kind of a nice pun. And this is the subject of part 2 of the talk, right? Like, I'm not here to talk about cognition. I'm here to talk about what I learned from cognition in case you guys end up building an agent lab or working at an agent lab. Because I think it is probably the most single valuable lesson for any AI engineer. So for reference, I wrote this up in a post called the Agent Labs Thesis. This is the November AI Engineer Summit that we did in New York, where we listed agent labs on one side and model labs on the other. You can look at those conferences on YouTube if you want to see what examples of agent labs versus model labs look like. But if you want it in one chart, this is probably it, where model labs proportionately allocate resources towards training and compute and less towards deployment. Obviously, that deployment has gone up over time. Agent labs are more or less the complete opposite in terms of the resource allocation and prioritization, right? And I think this is mostly holding, except that they're starting to encroach on each other's turf. Like, when I wrote this, it was like more clear. Now model labs are building agent labs internally, with OpenAI and Anthropic also doing hiring FDEs. And then agent labs are building models internally as well, with both cursor and cognition, RLing, like putting a lot of compute in RLing their models. If you want to sort of break it down in terms of like contrast, you can also do that in this way, but I'm going to skip over this for the sake of time. And I think like the details is really what I really want to sweat, right? Okay, so for example, a lot of people will say like, just put your favorite coding agent of choice. I don't want to name any ones to not piss them off. Just put it in a container. The reality is that it is not just about the container format. It is also about just building stateful sessions. And these are all the problems that have historically come up, right? It is about giving it real machine semantics. It's about giving all the tooling for real computer use. And here's a fun example of a real-life situation where shared machines, if you want sort of multi-tenancy for your sessions, so your stateful sessions for coding agents, it will actually break, right? So this is a real incident these are real incidents with the same root cause, right? So real incidents, for example, parallel agent sessions interfering with each other because they have a shared cache, or agent and auto accept mode publish the entire company's source code onto a personal GitHub because why? It had the secrets commingled, right? So what they both share is that basically you have no isolation boundary in a container. Like, container just only knows about one thing, but it doesn't really, it's not really set up for crossing or changing context between agent sessions. So basically what you end up building is an agent platform, which is everything above just the VM or the container. And this is a full list. I'm basically kind of open sourcing this. If you guys wanted to build an agent lab, these are the things that you have to go through. If you're considering buying, this is what you have to evaluate whenever you are encountering a new agent lab for the first time. Security is a very, very important one, of course, especially if you're a natively multiplayer with multiple levels of teams and orgs and all these things. Agents definitely need a lot of scope identity and least privilege, and these are all things that you sort of have to work through in terms of your permissioning model. Second perception, just the GPT wrapper, right? Like that's all that application layer people are. I think to some extent you can be proudly a GPT wrapper, but the entire name of the game is just to make it thick and worthwhile, right? So the reality is they actually long model diversity, which has been a historically very good bet over time, right? Like model diversity has a demonstrated tendency to increase over time. OpenAI market share used to be like 70, 80%. Now it's down to 30 something, depending on the source. Also, you're not just wrapping other people's models, you're also increasingly able to train your own based on your own domain-specific data and use cases as well. So both cognition, which these SweetGrep models and 3.5 models, which I worked on, as well as Cursor are also doing that. And I think any other competent enough agent lab will have enough resources to build it, and you should do it because it's going to be much more fit for purpose, right? Like, for the majority of your workload. Okay, one more perception. Evals is such a nebulous marketing concept, right? Like, most people just tell you to look at SweetBench, like my number is 0.1% higher than the other number, my model's better. In reality, reality is extremely multidimensional. So here's all the examples of different kinds of evals that cognition can run internally. And it's not summarizable in SweetBench. And obviously, you're going to want to have different approaches for each of these real-life use cases, each of which can have tens and hundreds of millions of dollars behind them. My sort of the spicy hot take is enterprises are the hardest eval that you can possibly get, right? Like, show me an RL environment that is harder than the enterprise. Cognition itself is an enterprise with multiple orgs and multiple slacks and multiple IT systems and all that. It has been really solved in the last 6 months, which to me, like, having joined more than 6 months ago, like, it was really interesting to see that, oh, like, I thought that was good, and now I have a different definition of good. And it's interestingly correlates with ARR growth, all of which has been publicly disclosed, so I'm not telling you anything you don't know. The new stuff I'm going to show later on. But I do think that that's one of those things where you do have to keep track of, like, how honest are you about how much of a problem you're solving in the world versus doing fun demos. I think one of the interesting things is also communicating like what kind of outcomes people are paying for. It's very hard to do that on a landing page, on a brochure, on a talk. So I basically don't bother. Like, I just paste this in here just because, like, people expect me to paste this in here. But I'm just gonna skip past it, and I'll tell you more locally specific stories about what we found in APAC and Singapore, because that is basically what I can open source. Yeah. Okay. So that's the part 3. Like, why Singapore? Like, why am I here? And I think the sort of, if I can summarize the sort of the story of Singapore's economic development, started with trade, then we went to oil, then we went to finance. We had a little bit of a fling in bio. Let's not talk about the crypto side. But, like, what's next, right? So my spicy take is that we have all these sort of leading figures. Fun fact, did anyone know that Keppel and Sembcorp merged into Seatrium? I just found that out. One person knows. So, like, anyone who's actually Singaporean will be like, yeah, Sembcorp Marine, Keppel Corp. What is Seatrium? It's the new entity. Anyway, my sort of cheeky answer is that there is obviously a 4th phase to Singapore's economy, and it is here. I'm here because Singapore has been chosen to be Cognition's Asia-Pac headquarters, which is, yay, like, very super fun. I think you have to sort of, even as a Singaporean, I think you had to go through this journey, and it's something that we've always wanted, right? Like, we always want MNCs, you know, the local term, to choose their base here, not just for sales, which sales is fine, sales is great, but also for engineering, also for research. To me, you have to succeed overseas to be recognized and do well locally, which I call the Sun Yanzi strategy. And it's not just GTM. So there's all these quotes, which I really like. Cognition acquired Havana. I think Nathan is in the audience somewhere, as well as some of the other crew. Hey, Nathan. Definitely talk to Nathan later on if you want to join COG. And so I think, like, this is working, right? Like, all I'm trying to say is, like, I have been part of the Singapore tech scene for my adult life, and we've never had this level of foreign interest and American interests in this region, in Singapore, in basing engineering and research in Singapore until now. So now is the moment. Let's fucking do it. Okay. So I actually had Nathan, who is my ChatGPT, go through all the call logs, right, of all the work, because there is so much work that happens behind the scenes that you guys never see because you're not in this business, and we are. And so I wanted to share some examples, right? Here's some examples of, like, the sheer amount of demand that APAC has, right? Tens of millions of dollars a year spent on LLM tokens, okay? And the way that they run your loans, your money, is on spreadsheets by business analysts who do not stay there, right? So imagine if, like, you come in and you're like, what the bank is run this way? Yes, right? So you have to systematize it. You have to write the code that is otherwise manually operated by business analysts. Same in government, same in other parts of tech. I think, again, like, this is the sort of normal way that we present these things. These are all real numbers from the customers, not from the company. But I think, like, it's hard to tell unless it's hard to tell from just the numbers itself. Like, okay, what does it mean for 10x acceleration in delivery time? Well, let me just show you the baseline, right? Like, the baseline is, for a local bank, you have 2 million COBOL lines of code of COBOL with no documentation and no engineers owning it. What are you going to do? And so, like, this is where you can start to really apply AI. And let me tell you, this is not unique to just Singapore or just one bank. It is all banks. It is any company that has like a really large scale of customers, which is enterprise. $100 million budgets for AI, 600 developers per rollout. It's really mind-blowing the amount of work that needs to be done that we cannot hire humans for because it is boring, it is on a language or system that nobody wants to work on, whatever, right? So I hopefully sort of just sharing some of these news stories for the first time. If you want to ask more, ask Nathan. But I just want to share some solutions that Cognition has figured out that has worked, right? Devin has a thing called playbooks, which are basically way more structured than normal chat. That is basically like a single playbook can be worth hundreds of millions of dollars, in my opinion, because they are structured templates that can parallelize agents in a much more reliable way than just open-ended chat. So if you haven't tried a Devin playbook, you definitely should, because these guys are using these things to transform banks and make billions of dollars. Deep code-based comprehension is the mode. Again, why? No docs, right? So of course you want AI to write the docs first and then use the docs to do the migrations. So Cognition was the first pioneer in DeepWiki, which I think a lot of people love as well. There's billions of revenue in brownfield work. And then lastly, I think it's a standard thing in enterprise, but it is so sort of surreal or so visceral and physical to see people and salespeople say, okay, the guy won't even get on the phone with us until we have custom SSO. And like, why? Because they've locked down their GitHub and GitLab because they're responsible enterprises. And like the rest of us don't, like we just YOLO stuff into our Obsidian and our and our personal sort of OpenClaws. And we don't really think about that. But when you have the trust of millions of people, the money of millions of people, of course you need to think about security like that. And anyone that serves these enterprises also transitively has to do that. So that's what I call sort of agents in Asia. Okay, let me sort of vector out again. So I shared some learnings about APAC. Now I'm just talking about Singapore and why I want to call this the agentic nation. We're not there yet, but we're getting there. We have to refer back to our dear forward deployed minister. Abhishek, I think, who is in the audience somewhere, named him the forward deployed minister. I think it's kind of sticking. Everyone's kind of like that. He said 3 things in his talk this morning. He said that we have an advantage in deployment, democratization, and decentralization, which, again, not crypto. He actually just means that he wants AI everywhere in public service. And I think we can help in all 3 of them. I think like this is actually really, really good that like he gets it, and like the rest of us can get it. To me, it's such a shock to realize that like Singapore itself has such demand, roughly 4 times demand than supply of AI engineering talent, and you know, like it's going to continue to widen and grow, right? Like demand for these roles are like growing 40% year on year. There's so much money at stake, and this is LinkedIn surveying the field and really sort of reporting on this. So I think it's like a pretty credible number as well. So my spicy take is I've given up on the government. Like I know I've just praised the minister, but I've waited for years for the government to do something about the tech sector. I had this podcast with Minister Josephine Teo, and there's us walking together and talking about the future of it. Nothing happened. It is only when when we, the people of Singapore, we, the citizens of Singapore, decide to take matters into our own hands, right? Like, I think Singapore has a history of government-led economic development. I think the new age is going to be led from the private sector first into the public sector. So let's go and make that happen, right? And I think this conference is an example of that. We didn't wait for the government to approve it or like give us their support. It's very nice to have IMDA and AI Singapore in Pullman and all the other expo stuff supporting us. It's very nice to have the Ministry of Foreign Affairs supporting us, but we do not need them. We're here to work in the private sector and build ourselves up as a tech sector ourselves. So it starts with everyone being high agency, particularly all these organizers standing in the wings here. Give them a round of applause. Like, they made this happen. This is their side project. They put you guys together. And obviously, I helped and supported them, but like this conference would not happen without them. So it starts with everyone in this room. It started with me. It starts with these organizers of 65 Labs, and now it starts with you. So I really hope that you can come away from AI Engineer and be more agentic in your lives and really turn Singapore into a more agentic nation in general. So thank you very much.
Well, we've come to the end of the first day of talks. Thanks for staying all the way till the end. This is crazy. Like, give yourselves a round of applause for making it to the end of 10 hours of programming. Okay, final notes before everyone heads out for dinner. We do have an after party here. We'll open the doors at about 9:30. I'll start DJing at 10. We've booked a DJ who's flying in from the UK. Who'll start playing at 11:30. There's free flow for the first 500 people, so if you want to come and drink, be my guest. The chairs will go down. This will become a dance floor, and we want you guys to come and have fun. If you are a conference attendee, please bring your lanyards with you, because that'll help us prioritize your entry. And do not lose them, because we are not printing new lanyards tomorrow. Hopefully that part of the instruction set is clear. If everything is good, thank you so much, and we'll see you bright and early tomorrow morning. Or tonight.